A grand welcome to the second part of module 6, that is everything about Kubernetes. So kids, as we have discussed in our last video, at the end of the last video, uh, K8 is an orchestration tool, and this is the most famous and widely used tool for complex and complicated projects in using containerization technologies that we are gonna look into now. So we are gonna have blast of fun, and we are going to have a lot of learning and huge amount of practical exposure on containers and containerization and container orchestration. So here broadly we are going to look into introduction of Kubernetes, bird's eye view, high level architecture of Kubernetes, and first we will look into the Kubernetes cluster and what Kubernetes cluster consists of. We will look into node, master node, and inside the master node what all components are there inside the master node, and inside the node or agent, so what is pod, and after looking into that we will be looking into the Kubernetes objects or building blocks. These are the building blocks. We will look into what are different types of objects are available in Kubernetes, and what is that object mean, why do we use it, and how do we use it, and all those things we'll be looking into that Kubernetes objects, and we will do the and then after that we will look into the concept called choosing the right object for the right job. Then we will get into the hands-on of Kubernetes. We'll begin with Minikube, then we will go to the KubeADM, then we will look into the kops with AWS, and we are going to create an Kubernetes cluster in AWS, and we will deploy one microservices and multi-container application in our Kubernetes cluster. Why to wait? Let's begin our Kubernetes lesson or tutorial. We will begin with, so let's turn the clocks first, and we will get back to the few years back, and we'll see how the Kubernetes have come into the limelight. So Kubernetes is an open source container management solution originally announced by Google in 2014 after its initial release in July 2015. Google donated Kubernetes to the Cloud Native Computing Foundation. Since then, several stable versions have been released under Apache license. For a developer, Kubernetes provides a manageable execution environment for deploying, running, managing, and orchestrating containers across clusters or clusters of hosts. For DevOps and MLOps and administrators, Kubernetes provides a complete set of building blocks that allow the automation of many operations for managing development, test, and staging and production environments. Container orchestration enables coordinating containers in clusters consisting of multiple nodes when complex containerized applications are deployed. This is relevant not only for the initial deployment but also for managing multiple containers as a single entity for the purposes of scaling, availability, and so on so forth. So being infrastructure agnostic, Kubernetes Kubernetes clusters can be installed on a variety of public and private clouds such as AWS, Google Cloud, Azure, OpenStack, IBM, and so many. And also on bare metal servers, mainframe servers. Additionally, Google Container Engine can provide a deployed Kubernetes cluster. This makes Kubernetes similar to Linux kernel, which provides consistency across different hardware platforms, or Java, which runs on almost any operating system. Now let's look into Kubernetes high-level architecture. So a Kubernetes cluster consists of a set of worker machines called nodes that run containerized applications. Every cluster has at least one worker node. So in this example, we have a cluster of three machines, and out of which one is a master node or control plane, and second one is a node or working node, and the third one is working node or node. So that means this cluster consists of one master node and two working nodes. So the worker nodes host the pods that are the components of the application workload. The control plane manages the worker nodes and the pods in the cluster. In production environments, the control plane usually runs across multiple computers and a cluster usually runs multiple nodes, providing fault tolerance and high availability. Then let's look into the node components. Node components run on every node, maintaining running pods and providing the Kubernetes runtime environment. The nodes are bare metal servers or on-premises VMs or VMs on a cloud provider. The nodes could be anything. So we have three nodes. Out of these three nodes, this node could be a bare metal server or on-premise VM or virtual machine or VMs on a cloud provider. It could be anything, but a node means a simple host machine, a simple virtual machine, or a easy to instance in AWS. It could be an instance or virtual machine in Google Cloud Provider, or it could be a machine in Microsoft Azure. Okay, so every node contains a container runtime environment. So in this case, a Docker. For our example, we are using a Docker engine. That is our container runtime environment. So the container runtime is the software that is responsible for running containers. Kubernetes supports container runtime. Kubernetes supports container runtimes such as a containered CRI-O and any other implementations of Kubernetes CRI, that is container runtime interface. Then another component that we find in working node is kubelet. A kubelet is responsible for starting, stopping, and managing individual containers by requests from the Kubernetes control plane. As an agent that runs on each node in the cluster, it makes sure that the containers are running in a pod. The kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubelet does not manage containers which are not created by Kubernetes. Then the third component that we can find inside a working node is a kube proxy or just a proxy. A kube proxy, here it is, you can see that it's flickering. A kube proxy is responsible for networking and load balancing. It's fundamentally responsible for networking and load balancing, and this is the only component that takes care of networking and load balancing. So kube proxy is a network proxy that runs on each node in your cluster and implementing part of the Kubernetes service concept. And kubeproxy maintains network rules on nodes. So these network rules allow network communication to your ports from network sessions inside or outside of your cluster. And kubeproxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kubeproxy forwards the traffic itself. So that's how a kubeproxy is absolutely takes care of networking and load balancing inside a working node. So these are the main three components that we have seen in working node. It's the first one is a Docker or container runtime environment, a kubelet, and a proxy. A kubelet is actual one which is responsible for starting, stopping, and maintaining individual containers by request from the Kubernetes control plane, whereas the proxy is responsible for networking and load balancing, whereas a Docker is the one, a container runtime environment which receives commands from the kubelet and it starts up pods, and inside that pods you will find your containers. On the left side, we have the most important one, that is master node or control plane. Master node or control plane. So a Kubernetes cluster also contains one or more master nodes that run the Kubernetes control plane. The control plane consists of different processes. The control plane's components make global decisions about the cluster, for example, scheduling, as well as detecting and responding to cluster events. For example, starting up a new pod when a deployment's replicas field is unsatisfied. Control plane components can be run on any machine in the cluster. However, for simplicity, setup scripts typically start all control plane components on the same machine and do not run user containers on the machine. So we have such as an API server provides JSON over HTTP API. So the API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane. The main implementation of a Kubernetes API server is Kube API server. A Kube-API server is designed to scale horizontally. That is, it scales by deploying more instances. You can run several instances of Kube server and balance traffic between those instances. Then the second component that we have in control plane is scheduler. Scheduler, it selects nodes to run containers. Control plane component that watches for newly created pods with no assigned nodes and selected node for them to run on. Factors taken into account for scheduling decisions include individual and collective resource requirements, hardware, software policy constraints, affinity and anti-affinity specifications, data locally, inter-workload interface, and deadlines. So then the third component that we have here is controller manager. Controller manager runs controllers. So control plane component that runs controller processes, and logically each controller is a separate process, but to reduce complexity they are compiled into a single binary and run in a single process. So controller some types of these controllers are node controller, job controller, endpoint slice, service count, and service account. So node controller responsible for noticing and responding when nodes go down, and job controller watches for job objects that represent one of tasks, then create pods to run those tasks to completion. Then endpoint slice controller populates endpoint slice objects to provide a link between services and pods, and service account controller creates default service accounts for new namespaces. Then the fourth component that we have here is etcd. So etcd, a globally available configuration store. So etcd is a consistent and highly available key value store as a, used as a Kubernetes backing store for all cluster data. If your Kubernetes cluster uses etcd as its backing store, make sure you have a backup plan for those data. So these are the main components of control plane. So control plane consists of a scheduler, API server, control manager or controller manager and etcd. And again there are four types of specific controller are there in controller manager: node controller, job controller, endpoint slice controller, service account controller. And finally, we have a etcd, which stores a key value pairs as a key value pairs concept to store the data. That's like backing store for all cluster data. Then finally, we have kubectl, the CLI dashboard and CLI command line interface. The Kubernetes command line interface. That's a kubectl. The Kubernetes cluster can be managed via the Kubernetes dashboard or a web UI user interface running on the master node. The cluster can also be managed the cluster can also be managed via the command line tool called kubectl, which can be installed on any machine able to access the API server running on master node. So this tool can be used to manage several Kubernetes clusters by specifying a context defined in a configuration file. So this is the high level sneak peek into a Kubernetes architecture. A Kubernetes architecture is nothing but we will look into the cluster first. So the cluster consists of a master node or control plane, that is one host, and other than that you will have a working nodes in that, and working nodes consists of a docker container, runtime engine, and kubelet and proxy, whereas master node or control plane consists of API server, scheduler, controller manager, and etcd.
Chandra, so far we have seen traditional deployment, virtualized deployment, and containerized deployment, right?
Yes, of course.
So, but what is bothering me is, what is the difference between each other? Everything seems like same.
Yes, they seem same, but they are not same. Actually, there is a subtle difference between traditional virtualized and container deployment. So what is that exact difference? That we are going to see here. Okay. So if you look into the traditional and virtualized, it's basically in virtualized we use containers, whereas traditional we take just mainframes. Okay. So whereas container deployment, what is that? In container deployment we are going to use what is that? Docker, a container. Okay.
Let's do time travel to various deployment eras that are exist in IT. So first we will enter into traditional deployment era using time machine. So early on, organizations ran applications on physical servers. There was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources. And as a result, the other applications would underperform. A solution for this would be to run each application on a different physical server, but this did not scale as resources were underutilized, and it was expensive for organizations to maintain too many physical servers. So now the next deployment era is virtualized era because of the problems or challenges that we have faced in traditional deployment. To solve those challenges, to solve those problems, then came a virtualized deployment. As a solution, virtualization was introduced. It allows you to run multiple virtual machines on a single server, on a single physical server CPU. So virtualization allows applications to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by the another application. So virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware costs. So each virtual machine is full machine running at all the components, including its own operating system on top of the virtualized hardware. So the last one we have is container deployment. So container deployment era is a latest era, present era, running era. Containers are similar to VM's virtual machines, but they have relaxed isolation properties to share the operating system among the applications. Therefore, containers are considered lightweight, similar to a VM, that's virtual machine. In a container has its own file system, share of CPU, memory, process space, and more, as they are decoupled from the underlying infrastructure. They are portable across clouds and voice distributions. You may say that, yeah, from traditional deployment, we move to virtualized because of benefits of saving money and saving resources, time. And then we have moved to container deployment, where it brings a lot of ease to our deployments, and it saves a lot of risk, money, and time. But for that, we have Docker, right? Then why do you need a Kubernetes? So why do we need a Kubernetes? What are the benefits that you get from the Kubernetes? And you have Docker Compose, Docker Swarm, a lot of tools you have. In that case, why do you want to use Kubernetes? Is it that you just want to learn one more tool? No, not at all. That's the reason I'm going to tell you the benefits that we get out of using Kubernetes. Benefits of using Kubernetes. So let's look into the first benefit, that is Kubernetes agile application creation and deployment. So increased ease and efficiency of container image creation compared to the virtual machine image use, and continuous development, integration, and deployment provides more reliable and frequent container image build and deployment with quick and efficient rollbacks due to image immutability. Dev and ops separation of concerns. That's the third benefit. So, what is dev and ops separation of concerns? It creates application container images at build or release time rather than deployment time, thereby decoupling applications from infrastructure. And fourth, observability. Not only surfaces voice level information and metrics, but also application health and other signals also will be surfaced by Kubernetes. That's the very helpful tool or helpful feature of Kubernetes. Then fifth one, environmental consistency across development, testing, and production. So it runs the same on a laptop as it does in the cloud. So that consistency I'm talking about, irrespective of whether you're doing on cloud or laptop or by a mainframe or on premises, it doesn't matter. The consistency will be maintained. Sixth, application centric management. The sixth one is application centric management. It raises the level of abstraction from running an OS on virtual hardware to running an application on an OS using logical resources. And seventh benefit is cloud and OS distribution probability. So it runs on Ubuntu RHEL, that's a Red Hat Enterprise Linux Core OS on premises on major public clouds and anywhere else. Literally anywhere, anytime it runs, irrespective of what type of distribution it is. Ubuntu, Red Hat Enterprise Linux, Core OS, and on-premise public clouds, private cloud, anywhere it works. Then 8, loosely coupled, distributed, elastic, liberated microservices. Applications are broken into smaller, independent pieces and can be deployed and managed dynamically, not a monolithic stack running on one big single purpose machine. So we have seen what is a microservice in our previous part of sixth module, that is Docker. In that we have seen the what is microservice, what is monolithic, and in addition to that we have deployed an emart app which is microservice based. Then the ninth benefit is resource isolation. Resource isolation, a predictable application performance. So, and we have one more, that's a resource utilization, a high efficiency and high density. Then the next question that arrives and pops up in your mind would be why you need Kubernetes. Okay, that's okay. There's a lot of benefits, but why do we require that? Why you need a Kubernetes and what it can do for us? What it can do for us. So containers are a very good way to bundle and run your applications. In a production environment, you need to manage the containers that run the applications and ensure that there is no downtime. This is very, very important in production, specifically in production. No downtime. There is no space for downtime. For example, if a container goes down, another container needs to start at any cost. Wouldn't it be easier if this behavior was handled by a system? Of course. So that's how Kubernetes comes to the rescue. That's how the Kubernetes comes to the handy, that Kubernetes provides you with a framework to run distributed systems resiliently. Resiliently, it takes care of scaling and failover for your application, provides deployment patterns, and more and more. For example, Kubernetes can easily be managed. Sorry, Kubernetes can easily manage a canary deployment for your system. So Kubernetes provides you with the following benefits. The first one is services discovery and loading balance. So service discovery and loading balance, in this Kubernetes a, can expose a container using the DNS name or using their own IP address. And Kubernetes provide you with a lot of information in addition to this. That is, it does not limit the types of applications supported. Kubernetes aim to support an extremely diverse variety of workloads, including stateless, stateful, and data processing workloads. If an application can run in a container, it should run great on Kubernetes. Then we have storage orchestration. Storage orchestration, Kubernetes allows you to automatically mount a storage system of your choice, such as local storage, public cloud providers, and more. And automatic bin packaging, you provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and memory each container needs, so Kubernetes can fit containers onto your nodes to make the best use of your resources. And fourth, the most important is automated rollouts and rollbacks. You can describe the desired state for your deployed containers using Kubernetes, and it can change the actual state of the desired state at a controlled rate. For example, you can automate Kubernetes to create new containers for your deployment, remove existing containers and adopt all their resources to the new container. And self-healing, the fifth one, Kubernetes restarts containers that fail, replaces containers, kill containers that don't respond to your user-defined health check, and doesn't advertise them to clients until they're ready to serve. And the sixth reason to use Kubernetes is secret and configuration management. So Kubernetes lets you store and manage sensitive information such as passwords, OAuth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. So not only this, there are more. So does it even Kubernetes provide you? It does not provide storage systems as built-in services. Such components can run on Kubernetes and or can be accessed by applications running on running on Kubernetes through portable mechanisms such as Open Service Broker. And Kubernetes does not dictate. So what and Kubernetes does not dictate logging, monitoring, alerting solutions. It provides some integrations as a proof of concept, that's a POC, and mechanisms to collect and export metrics. And it does not provide nor mandate a configuration a language or system. For example, JSONnet. It provides a declarative API that may be targeted by arbitrary forms of declarative specifications. And also, it does not provide nor adopt any comprehensive machine configuration, maintenance, management, or self-healing systems. Additionally, Kubernetes is not a mere orchestration system. In fact, it eliminates the need for orchestration. The technical definition of orchestration is execution of a defined workflow. First do A and then B, then C. In contrast, Kubernetes comprises a set of independent composable control processes that continuously drive the current state towards the provided desired state. It should not matter how we get from A to C. Centralized control is also not required. This results in a system that is easier to use and more powerful, robust, resilient, and extensible. So from high level architecture of Kubernetes, so we have a master node, working node, and one master node and two working nodes. Out of the master node or control plane, we are going to look into APIs. APIs. So the Kubernetes API, the core of Kubernetes control plane is the API server. The API server exposes an HTTP API that lets end users different parts of your cluster and external components communicate with one another. The Kubernetes API lets you query and manipulate the state of API objects in Kubernetes. Some examples of Kubernetes objects are pods, namespaces, config maps, and events, and secrets, and many more, many more. And most operations can be performed through the kubectl command line interface or other command line tools such as kubeadm, which in turn use the API. However, you can also access the API directly using REST calls. So open API specification. The Open API specification OAS defines a standard programming language agnostic interface description for HTTP APIs, which allows both humans and computers to discover and understand the capability of a service without requiring access to source code, additional documentation, or inspection of network traffic. When properly defined via a open API, a consumer can understand and interact with the remote service with a minimal amount of implementation logic, similar to what interface descriptions have done for lower level programming. The Open API specification removes guesswork in calling a service. Then persistence. Kubernetes also stores the serialized state of objects by writing them into etcd. So we have seen in our, just let me show you that one more time. In master node or control plane, we have API. In addition to that, we also have etcd. So this etcd is going to store the objects, the Kubernetes objects such as pod, namespace, config, their state of these objects are into etcd in key value pairs. Then API extension. The Kubernetes API can be extended in one of two ways. The first one is custom resources let you declaratively define how the API server should provide your chosen resource API. And the second one is you can also extend the Kubernetes API by implementing an aggregation layer. This is all about API and API servers and API specification and API persistence, which is a main component of master node or control plane, which is what makes the communication possible between all the nodes and all the external communications, whichever is possible in Kubernetes cluster. We have seen a Kubernetes architecture and we have seen a sample Kubernetes cluster with 2 working nodes and 1 master node or control plane. So now what we are going to do is we are going to jump into this cluster architecture, and we are going to explore each and every component of this Kubernetes cluster architecture. We had begun with the API. So API, we have discussed about the API, and then after that Kubernetes API, we are gonna jump into a Kubernetes working node. A Kubernetes working node is part of Kubernetes cluster. Kubernetes runs your workload by placing containers into pods to run on nodes. A node may be a virtual or physical machine depending on the cluster. So don't get confused when somebody says Kubernetes node or agent or working node or master node or control plane. Don't imagine that, don't be illusionized that this is something different. No, not at all. It is just a machine, a virtual machine, or an EC2 instance, or any a physical machine or wire mainframe, whatever it could be. A machine or computer is known as a node in Kubernetes terminal. So normally we use a cloud, so that's the reason EC2 instance could be our working node. One EC2 instance is our working node or maybe master node. Similarly, if you use a physical machine where you have created a virtual machines, in that case a virtual machine could be our working node or master node. So each node is managed by the control plane and contains the services necessary to run pods. We have seen the control plane in our previous slide, which is on left portion of our slide, and the components on a node includes the kubelet, a container runtime, and the kubeproxy. Let me show that again. So the components of a node, a working node specifically, it's not just a node. Of course, if you say node means it's just working node. So but if you want to mention, if you want to I talk about a master node, you have to specifically mention either master node or control plane, whereas a normal node is also known as a working node. So this working node consists of three components. One is a kubelet, you can see this here, and other one is a kubeproxy that you can see here, and final one is container runtime engine. The container runtime, that could be a Docker. Here we are using Docker. This is most famous tool. So there are two main ways to have nodes added to the API server. API server is this. So this is what is our API server. We have discussed about the API server just before. Now there are two main ways to have nodes added to the API server. One, the kubelet on a node self-registers to the control plane. This is what this kubelet automatically self-registers to the control plane. This kubelet will do that act, or another human user manually adds a node object. These are the two ways. Either kubelet will do the same work for you, or else you can manually add a node object to the API server. So after you create a node object, or the kubelet on a node self-registers, the control plane checks whether the new node object is valid. For example, if you try to create a node from the following JSON format, I'm going to show that. So this is what we are using. With this following JSON format that you can see on your screen. If you try to create a node from this, this is called JSON manifest. So Kubernetes creates a node object internally, the representation. So Kubernetes checks that a kubelet has registered to the API server that matches the metadata dot name field. Here is that metadata dot name field. So this my first case node. Okay. So the practical demonstration of all the objects, all the Kubernetes objects like node, pod, and secrets, config, and many, all we are gonna do in our objects, Kubernetes objects section. But for now, we are going to understand the subtle differences and then the core concepts in depth of every component of cluster. That's what we are doing here. After that, we'll do all the demonstration of each and every object of Kubernetes. So here the Kubernetes checks that a kubelet has registered to the API server that matches the metadata dot name field of the node. If the node is healthy, that's all necessary services are running, then it's eligible to run a pod. Otherwise, the node is ignored for any cluster activity until it becomes healthy. Note that Kubernetes keeps the object for the invalid node and continues checking to see whether it becomes healthy. You or a controller must explicitly delete the node object to stop the health checking. So the name of the node should be given to check that. So node name uniqueness. The name identifies a node. Two nodes cannot have the same name at the same time at any cost. So Kubernetes also assumes that a resource with the same name is the same object. In case of a node, it is implicitly assumed that an instance using the same name will have the same state. Example, state here means similar kind of network settings, root disk contents, and attributes like node labels. Everything remains everything similar. It assumes that everything same. So this may lead to inconsistencies if an instance was modified without changing its name. If the node needs to be replaced or updated significantly, the existing node object needs to be removed from API server first and re-added after the update. So now first we will look into self-registration of nodes, because we have discussed about two types of registration. The concept is pretty simple. So I will take you back to the previous slide so that it will be much clearer. See, here we have a master node. That means let's consider it is one EC2 instance, and this is a working node. This is another EC2 instance, and this is working node, another EC2 instance. So that what we are going to do here is we have created three EC2 instances separately. Okay, now I have considered this as a master node or control plane. In this, I have installed the required tools or required utilities. Now, the one more instance I have is EC2 instance. That EC2 instance, I want to consider it as a working node. Absolutely fine, no issue at all. But how would the master node understands that this is a working node? How would the master node get to know that that is his son? Let's take that example. How would your father knows that this is his son? Obviously, there is some connection. The name is given. He knows from the childhood because it is inherently connected. It is self-registered because it has come from him after your mother tells him. Okay. So here also the EC2 instance has been created. Now we have to make a connection between master node and working node. For that, we have two methods. One is self-register, second one is manual register. For self-register, automatically self-register will be done through kubelet, whereas manual register, you have to do that. So once it has been registered with once once it's been registered with once it's been registered with the master node, that's it. The system considers it as a working node, and it will do the health checkups, and if it is absolutely healthy, then the master node will allow the working node to make pods inside that. So that's what we have discussed so far. So now let's move ahead. So now how the self-registration of nodes takes place. That's what we are going to do. So when the kubelet flag register node, the kubelet flag register node is true, the kubelet will attempt to register itself with the API server. This is the preferred pattern used by most distros. I'll show you that code first. Yeah, this one. So if you use that register node, I'll show you that. Yeah, this one. This option automatically register with the API server. Just remember this or write down these flags or options on your notebook. When the time comes, we will put into the action. We will take them and we will put these things into the action. Okay. So then uh, for self-registration, the kubelet is started using the following option. One is the kube config flag. So it is path to credentials to authenticate itself to the API server. First one, authentication will be done. Then cloud provider. If it is a cloud provider, how to talk to a cloud provider to read metadata about itself. Then register node, we have seen it. It's automatically register with the API server. Then we have register with taints. So register the node with the given list of taints. So we have to mention the key and value pairs there, and then node IP. So IP address of the node should be provided, and node labels we can attach labels to that, labels to add when registering the node in the cluster. Then we have a node status update frequency. So specifies how often kubelet posts its node status to the API server. So these are the widely used flags when you register your nodes to the API server or to the master node. Unless you register your EC2 instance or virtual machine to the API server into the master node, it will never consider it as a working node. I hope it's pretty much clearer. It's pretty much clear. Then we will look into the manual node administration. So you can create and modify node objects using kubectl. When you want to create node objects manually, set the kubelet flag, that is register node. The register node, you remember that flag. We are going to use this register node flag. You put that you set it as false. So you can modify node objects regardless of the setting of register node. For example, you can set labels on an existing node or mark it unschedulable. So you can use labels on nodes in conjunction with the node selectors on pods to control scheduling. For example, you can constrain a pod to only be eligible to run on a subset of the available nodes. So marking a node as unschedulable prevents the scheduler from placing new pods onto that node, but that does not affect existing pods on the node. So this is useful as a preparatory step before a node reboot or the other maintenance. So this step is also pretty much important, that what do you call that, uh, labeling and unscheduling, labeling and unschedulable. So these things are also pretty much usable to mark a node unschedulable. So for that we can use kubectl cordon. This is a recent one. You can use that. So pods that are part of daemon set tolerate being run on unschedulable node, but daemon sets typically provide node local services that should run on the node even if it is being drained of workload applications. So if you want to mark a node unschedulable, you have to run this kubectl cordon and the name of the node that you have given using a label. Then now let's look into the node status. A node's status contains the following information. One is addresses, the second one is conditions and capacity and allocatable info. So you can use kubectl to view a node's status and other details. So but how can you use that? So when you look into the addresses, the usage of these fields, for that the command that you have to use is kubectl describe node. When you mention kubectl describe node and then you have to insert the name of the node there, then it will show you the required information about the node. So the information consists of addresses. The usage of these fields varies depending on your cloud provider or bare metal configuration. However, few components of these addresses are common, that is host name. The host name as reported by the node's kernel can be overridden by the kubelet, so host name overridden parameter. You can use the overridden host name overridden parameter to override the host name. Then in the Kubernetes API, a node's condition is represented as the part of the status of the node resource. For example, you can look into this conditions. You can look into this conditions file. Okay. Now, this example describes a healthy node. Last heartbeat time, last transition time. So it literally basically represents a healthy node. So then external IP will have an external IP and an internal IP as part of the kubectl describe node data. Then we will look into the conditions. The conditions field describe the status of the running nodes. So some of the examples of the status of the running nodes are ready, disk pressure, memory pressure, PID pressure, network unavailable. So disk pressure will get it true if pressure exists on the disk size, that is if the disk capacity is low, otherwise false. Similarly, PID pressure, that is process ID pressure, and we will get a ready. If we get the ready status, a node condition, then if the node is healthy and ready to accept nodes, accept pods, if the node is absolutely healthy and ready to accept pods, then we will get a ready, or else we'll get ready false. Then that means the node is not healthy and is not accepting pods and unknown. If the node controller has not heard from the node in the last node monitor grace period, default is 40 seconds. So that's what the condition of nodes basically convey. Now let's look into the capacity and allocatable. This capacity and allocatable describes the resource the resources available on the node, such as CPU, memory, and the maximum number of pods that can be scheduled onto the node. That's what this capacity and allocatable section of the node's description will tell us or convey us. So the fields in the capacity block indicates the fields in the capacity block indicate that the total amount of resources that a node has. So when we work on with our objects, that time we are gonna experiment all these things. Then we have info describes general information about the node, such as a kernel version, Kubernetes version, kubelet and kubeproxy version. So contain a runtime details and which operating system the node uses. The kubelet gathers this information from the node and publishes it into the Kubernetes API. So far in our cluster architecture, we have seen API server and we have seen the nodes are working nodes and how to register these nodes with the API cluster. So now we are going to look into how to establish a communication between nodes and the control planes, and how the communication takes place between the nodes are working nodes and the control plane are the master plane. So this slide talks about the communication paths between the API server and the Kubernetes cluster. The intent is to allow users to customize their installation to harden the network configuration such that the cluster can be run on an untrusted network or on fully public IPs on a cloud provider. So node to control plane. Kubernetes has a hub and spoke API pattern. Hub and spoke API pattern. All API usage from nodes terminates at the API server. So none of the other control plane components are designed to expose remote services. The API server is configured to listen to remote connections on a secure HTTPS port, typically 443, with one or more forms of client authentication enabled. So one or more forms of authorization should be enabled, especially if anonymous requests or service account tokens are allowed. Nodes should be provisioned with the public root certificate for the cluster such that they can connect securely to the API server along with valid credentials. The good approach is that client credentials provided to the kubelet are in the form of a client certificate. So pods that wish to connect to the API server can do securely by leveraging a service account so that Kubernetes will automatically inject the public root certificate and a valid bearer token into the pod when it is instantiated. The Kubernetes service is configured with a virtual IP address that is redirected to the HTTPS endpoint on the API server. The control plane components also communicate with the API server over the secure port. As a result, the default operating mode for connections from the nodes and pods running on the nodes to the control plane is secured by default and can run over untrusted and or public networks. So now let's see control plane to node. So first we have seen a node to control plane. Now we will look into the control plane to the node. So There are two primary communication paths from the control plane to the nodes. So control plane is nothing but our API server to the nodes. The first is from the API server to the kubelet process which runs on each node in the cluster. The second is from the API server to any node, pod or service through the API server's proxy functionality. Again, I'll show you that. One is using kubelet, this part, and other one is using proxy. So now let's look into the API server to kubelet first. API server to kubelet. The connections from the API server to the kubelet are used for the main purpose of using this connection between API server to kubelet is fetching logs for pods. Second, attaching usually through kubectl, attaching attaching to running pods, and third, providing the kubelet's port forwarding functionality. So these connections terminate at the kubelet's HTTPS endpoint. By default, API server does not verify the kubelet's service or serving certificate, which makes the connection subject to man-in-the-middle attacks and unsafe to run over untrusted and or public networks. So to verify these connections, what we do is we use the kubelet certificate authority flag kubelet certificate authority. This flag, if you use this flag, we can basically verify the connection with the root certificate bundle to use to verify the kubelet serving certificate. Then if this is not possible, if this certification using certification is not possible, then we can go for SSH tunneling. SSH tunneling between the API server and kubelet if required to avoid connecting over an untrusted or public network. Finally, if neither works, kubelet authentication or authorization should be enabled to secure the kubelet API. And now let's look into the another type of communication, that is API server to nodes, pods and services. The connection from API server to a node, pod or service default to plain HTTP connections and are therefore neither authenticated nor encrypted. So they can be run over secure HTTPS connections by prefixing HTTPS colon to the node, pod or service name in the API URL, but they will not validate the certificate provided by the HTTPS endpoint nor provide client credentials. So while the connection will be encrypted, it will not provide any guarantees of integrity. So these connections are not currently safe to run over untrusted or public networks. So then we will look into SSH tunnels, because that is a secure way of connecting, making a communication or connecting between node to control plane. So that's the reason what we are going to do is we are going to look into this. So the Kubernetes support SSH tunnel to protect the control plane to nodes communication paths. In this configuration, the API server initiates an SSH tunnel to each node in the cluster, that to basically that connecting to the SSH server listening on port 22. We know this because throughout this course we have used this SSH tunnel so many times to connect with our EC2 instance. If you remember, if you do not know, kindly watch all our previous videos. Every video we are gonna do the same, and passes all traffic destined for a kubelet node, pod or service through the tunnel. This tunnel ensures that the traffic is not exposed outside of the network in which the nodes are running. Now we are going to look into the most important component of cluster architecture. Kubernetes cluster is controller. So the controller in robotics and automation, a control loop is a non-terminated loop that regulates the state of a system. Yes or no? If anybody has come from mechanical background or ECE or that's telecommunication background or EEE background, you might have heard about this, or operations and process automation, you might have heard about that automation. So basically automation is a control loop, is a non-terminating loop that regulates the state of a system. So now you may think, what is the difference between that control loop and this controller? I'm gonna tell you, don't worry. So here is one example of a control loop. Example, let's take a thermostat in a room. Okay, when you set the temperature, that's telling that thermostat about your desired state. When you set a temperature, a certain temperature, example at 23 degrees Celsius in your thermostat, that means you are telling the thermostat about your desired state. That's what I want. That's what the temperature I would like to have in this room. Okay, the actual room temperature is the current state, but the at that moment the actual room temperature could be 32 degrees Celsius. That 32 degrees Celsius is the current state. So the thermostat acts to bring the current state, which is 32 degrees Celsius, closer to the desired state, which is 23 degrees Celsius, by turning the equipment on or off. Here, what is that equipment? It is not that important for us because we are neither dealing with AC nor dealing with refrigeration. Okay, but the thing should be understood is the difference between a current state and a desired state. So similarly, in Kubernetes, controllers are control loops that watch the state of your cluster, then make or request changes where needed. Each controller tries to move the current cluster state closer to the desired state. That's what the purpose of controller. A controller tracks at least one Kubernetes resource type. So these objects have a spec field that represents the desired state. The controllers for that resource are responsible for making the current state come closer to the desired state. Current state come closer to the desired state. So unlike manually created pods, the pods maintained by a replication controller are automatically replaced if they fail. So that is one more. The most important benefit of controller is, if you take it, there is another type of controller that's called a replication controller. A replication controller are automatically replace a pod if it fails, if it gets deleted, if it gets terminated, whatever it may be, that is going to be replaced. So there are several controller types such as a replication controller, deployment controller, all those things we are going to look into it now. So control via API server. The job controller is an example of Kubernetes built-in controller. This is a built-in controller and a widely useful controller. Built-in controllers manage the state by interacting with the cluster API server. So job is a Kubernetes resource that runs a pod. This is also an important aspect. Job is a Kubernetes resource that runs a pod or perhaps several pods to carry out a task and then stop. So once scheduled, pod objects become part of the desired state for a kubelet. When the job controller sees a new task, it makes sure that somewhere in your cluster, the kubelets on a set of nodes are running the right number of pods to get the work done. The job controller does not run any pods or containers itself. Instead, the job controller tells the API server to create or remove pods. Other components in the control plane acts on the new information, and eventually the work is done. After you create a new job, the desired state is for the job to be completed. The job controller makes the current state for the job be nearer to your desired state, creating pods that do the work you wanted for the job, so that the job is closer to completion. Controllers also update the objects that configure them. For example, once the work is done for a job, the job controller updates that job object to mark it finished. It seems like how thermostat turns a light off to indicate that your room is now at the temperature you set. So always, if you are a mechanical engineer or automobile engineer, just compare a thermostat with your controller of Kubernetes. It would be much easier. To the analogy will give you a complete understanding. So now there are different types of control, out of which the first one is a direct control. Direct control, in contrast with job, some controllers need to make changes to things outside of your cluster. For example, if you use a control loop to make sure that there are enough nodes in your cluster, then that controller needs something outside the current cluster to set up new nodes when needed. So controllers that interact with external state find their desired state from the API server, then communicate directly with an external system to bring the current state closer in line. The important point here is that the controller makes some changes to bring about your desired state and then reports the current state back to your cluster's API server. Other control loops can observe that reported data and take their own actions. In the thermostat example, again we are taking the analogy. If the room is very cold, then a different controller might also turn on a frost protection heater. With Kubernetes cluster, the control plane directly works with IP address management tools, storage services, cloud providers, APIs, and other services by extending Kubernetes to implement the similar kind of feature or function. So now let's see the difference between the desired state versus current state. So the Kubernetes takes a cloud native views of systems and is able to handle constant change. Your cluster could be changing any point as work happens, and control loops automatically fix failures. This means that potentially your cluster never reaches a stable state as long as the controllers for your cluster are running and able to make useful changes. It doesn't matter if the overall state is stable or not. And let's see some of the ways of running controllers. Kubernetes comes with a set of built-in controllers that run inside the kube controller manager. These built-in controller provide important core behaviors. First one is the deployment of controller and job controller are examples of controllers that come as a part of the Kubernetes itself. They are built-in controllers. Deployment controller and job controller. These are two built-in controllers. Kubernetes lets you Kubernetes lets you run a resilient control plane so that if any of the built-in controllers were to fail, another part of the control plane will take over the work. So you can find controllers that run outside the control plane to extend Kubernetes, or if you want, you can write a new controller yourself. You can run your own controller as a set of pods or externally to Kubernetes. What fits best will depend on what that particular controller does. So then we have a controller types. We will look into various controller types here. The first one is a replication controller. Of course, there are a lot of controllers, but mainly we will be looking at the most important controller and which are widely used in Kubernetes. A replication controller is responsible for running the specified number of pod copies, or in a proper Kubernetes language, we can say that replicas across the cluster. The main function of replication controller is to maintain the replicas that you have desired. That is our desired state. If the current state has been changed to, see, for example, our desired state is 5, but because of some unhealthy issue during the checkups, if the pod has been turned off, if the pod has been removed, then automatically the current state will become 3. Then the replication controller comes into the action and it will make the current state as a desired state. It will start a new 2 or sorry, it will start 2 more pods and then it will make a desired current state as a desired state. Then we have one more controller, that is a deployment controller. A deployment controller defines a desired state for logical group of pods and replica sets. It creates a new sources or replaces the existing resources if necessary. A deployment can be updated, rolled out, and rolled back. A practical use case for a deployment is to bring up a replica set and pods. Then update the deployment to recreate the pods. For example, to use a new image, later deployment can be rolled back to an earlier version of the current deployment if current deployment is not stable. Then we have the final type that we are going to talk here is the replica set. So a replica set is that next generation replication controller. A replication controller supports only equity based selectors, while a replica set supports set based selectors. Now let's look into the cloud controller manager. So cloud infrastructure technologies let you run Kubernetes on public, private and hybrid clouds. Kubernetes believes in automated API driven infrastructure without tight coupling between components. The cloud controller manager is a Kubernetes control plane component that embeds cloud specific control logic. The cloud controller manager lets you link your cluster into your cloud provider's API and separates out the components that interact with the cloud platform from components that only interact with your cluster. By decoupling the interoperability logic between Kubernetes and underlying cloud infrastructure, the cloud controller manager components enables cloud providers to release features at a different pace compared to the main Kubernetes project. The cloud controller manager is structured using a plugin mechanism that allows different cloud providers to integrate their platforms with Kubernetes. And anyway, we are going to integrate AWS cloud platform of my account with Kubernetes, and we are going to work on one Kubernetes project. So cloud controller manager functions. The controllers inside the cloud controller manager include a node controller, a route controller, and service controller. A node controller is responsible for updating node objects when new servers are created in your cloud infrastructure. The node controller obtains information about the hosts running inside your tenancy with the cloud provider. The node controller performs the following functions. One, it updates a node object with the corresponding server's unique identifier obtained from the cloud provider API. One, and second, annotating and labeling the node object with the cloud specific information such as the region the node is deployed into and the resources that has available. And three, obtain the node's host name and network addresses. And four, verifying the node's health. In case a node becomes unresponsive, this controller checks with your cloud provider's API to see if the server has been deactivated or deleted or terminated. If the node has been deleted from the cloud, the controller deletes the node object from your Kubernetes cluster. Then let's look into the route controller. Route controller is responsible for configuring routes in cloud appropriately so that the containers on different nodes in your Kubernetes cluster can communicate with each other. Depending on the cloud provider, the route controller might also allocate blocks of IP addresses for the pod network. Then the last one is our service controller. Service controller these services integrate with cloud infrastructure components such as managed load balancers, IP addresses, network packet filtering, and target health checking. The service controller interacts with your cloud provider's APIs to set up load balancers and other infrastructure components when you declare a service resource that requires them. And finally, authorization. This authorization section breaks down the access that the cloud controller manager requires on various API objects in order to perform its operations. Now let's see one more component of working node, specifically working node, that is container runtime interface. So this is container runtime interface. The CRI, a container runtime interface, is a plugin interface which enables the kubelet to use a wide variety of container runtimes without having a need to recompile the cluster components. You need a working container runtime on each node in your cluster so that the kubelet can launch pods and their containers. A pod and their containers. The container runtime interface, CRI, is a main protocol for the communication between the kubelet and container runtime. The kubelet's container runtime interface defines the main gRPC protocol for the communication between the cluster components, kubelet, and container runtime. So next, the API, which makes all these things possible. The kubelet acts as a client when connecting to the container runtime via gRPC. The runtime and image service endpoints have to be available in the container runtime, which can be configured separately within the kubelet by using the image service endpoint and container runtime endpoint command line flags. These are the two flags which we gonna use. Then garbage collection, the last one. Garbage collection is a term for the various mechanisms Kubernetes used to clean up cluster resources. This allows the cleanup of resources such as terminated pods. We want to terminate the pods. We want to clean up the completed jobs, and we want to clean up objects without owner references and unused containers and container images and dynamically provisioned persistent volumes with storage class reclaim policy. So all those things will be cleaned up and put it in garbage collection. This is what we call it as a garbage collection. And nodes deleted in the following scenarios, such as on cloud when the cluster uses a cloud controller manager, on premises if the node is on premises when the cluster uses an add-on similar to cloud controller manager, whatever it may be. So all these kind of things will be deleted using garbage collection. Now let's look into the difference between imperative and declarative orchestration. Before getting to the practical steps of the Kubernetes deployment and Kubernetes objects and Kubernetes mega projects, it is important to understand the key approaches to orchestration. So the first one is imperative approach. The classic imperative approach for managing software involves several steps or tasks, some of which are manual. When working in a team, it is usually required that these steps be documented and in an ideal case automated. So preparing good documentation for a classic imperative administrative procedure and automating these steps can be non-trivial tasks, even if each of the steps is simple. And second approach that we have here is a declarative approach. A declarative approach for administrative tasks is intended to solve such challenges. With a declarative approach, an administrator defines a target state for a system, example application, server, or cluster. So typically, a domain specific language DSL is used to describe the target state. An administrative tools such as Kubernetes takes this definition as an input and takes care of how to achieve the target state from the current observable state. So Kubernetes object management using imperative and declarative. The kubectl command line tool supports several different ways to create and manage Kubernetes objects. So this slide provides an overview of the different approaches. So management techniques, imperative commands, it operates on live objects, and a recommended environment is just development projects and practicing. For practicing, it would be helpful. And imperative object configuration, this is operates on individual files and it can be used in production projects also. Then we have the third one, which is declarative object configuration. So it declarative object configuration can be operated on directories of files. So production projects also, this will be widely used, and a recommended environment for this technique is production projects. So imperative commands, what are the imperative commands? What does an imperative command means? When using imperative commands, a user operates directly on live objects in a cluster. What is an object? That we are going to discuss in a while, but don't worry. So in a simplest way, let's consider an object means a state, a node. In this case we are going to consider as a pod is one object, a pod. Okay, pod is one object. So when using imperative commands, a user operates directly on live objects in a cluster. That means a live pods on a cluster. The user provides operations to the kubectl command as an argument or flags. This is the recommended way to get started or to run a one-off task in a cluster, because this technique operates directly on live objects. It provides no history of previous configurations. For example, if you want to run an instance of nginx container, for that we have to create a deployment object. If you want to run an instance of nginx container, you have to create a deployment object. So this deployment object, because there are different types of objects are available in Kubernetes. A pod is one object, deployment is one object, service is one object, secret is one object, and config map is one object, job is one object. So however, we are going to see each and every object in Kubernetes, and we are going to do practical demonstration of how this how can we work on this each and every object. So all these things we are going to see, but for now we will consider one example. One is, now we want to run an instance of nginx container in a pod. So if you want to run an nginx container, so obviously you need to go for a deployment object. So we have to create a deployment definition file, and then when we say create this deployment object, then the required thing will be happening. For that the command is will be kubectl create and deployment nginx, and image name is nginx, deployment name is nginx. Here image option and nginx is the name, it's gonna fetch it, whereas the deployment name we have given is nginx. And for this we need to have this is as an imperative command, so we don't need to have a file. If you okay, now we are looking at the imperative command, so we don't require a file, we'll just type the command itself. Okay, so next, imperative object configuration. In imperative object configuration, the kubectl command specifies the operations such as create, replace, etc. Optional flags and at least one file name can also be used. So the file specified must contain a full definition of the object in YAML or JSON format. That's what I was talking about. So basically, an imperative object configuration, the difference between an imperative command and an imperative object configuration is pretty simple. For imperative command, you just type the command and you execute. For this, you say to create, to run an instance of nginx container, what we are gonna do is, when imperative command is to give a command, that's it, kubectl create deployment, name of the deployment is nginx, and image from which you want to run a container is nginx, that's it. Whereas imperative object configuration, we are going to write a definition file. It's a simple file, YAML file, but normally in Kubernetes language we call it as a definition files. So we will write a definition files. In that definition file we will mention each and every property of that deployment object, and once it is run, then once it is done, then you can create deployment object from that. So example, again we have taken the same, create the nginx, run an instance of the nginx container. So for that it's pretty simple. We'll say kubectl create remain same option f, and then you have to give the definition file, that is nginx.yaml. This is our definition file to create uh, either you can call it as a definition file, or sometimes they call it as a configuration file. However it may be, it's gonna create a respective deployment object. So delete, if you want to delete the objects defined in the configuration file, so if you have two configuration files, still you can delete it easily. So again you have to use that configuration file only, even if you want to delete it. So for to delete that, you have to mention kubectl delete option f nginx yaml, that is one configuration file or definition file, and redis.yaml file, this is another configuration file or definition file. So the imperative replace command replaces the existing spec with the newly provided one, dropping all changes to the object missing from the configuration file. So this approach should not be used with the resource types whose specs are updated independently of the configuration file. Services of type load balancer, for example, have their external IPs field updated independently from the configuration by the cluster. So examples, like create the objects defined in the configuration file of nginx.yaml or redis.yaml. So then we have the third type, which is declarative object configuration. So here, when using declarative object configuration, a user operates on object configuration files stored locally. However, the user does not define the operations to be taken on the files. Create, update, and delete operations are automatically detected per object by kubectl. So this enables working on directory where different operations might be needed for different objects. So note that declarative object configuration retains changes made by other writers even if the changes are not merged back to the object configuration file. So this is possible by using the patch API operation to write only observed differences instead of using the replace API operations to replace the entire object configuration. So now let's look into some of the examples. So to process all object configuration files in the config directory and create or patch the live objects, you can first def to see what changes are going to be made, and then you can apply. That's it. This is how you use a kubectl diff to see what changes are going to be made, and then once you apply -f config, so all the files, all the definition files which are there inside this directory will be executed, and based on the instructions that are mentioned inside that YAML file will be executed and will be created and will be deployed, and whatever type of object it could be, that object will be run. So that's how with one command you are able to create all objects. You are able to create all the objects. So that's why it's called declarative object configuration. So recursively process, if you want to recursively process directories, for example, in the directory subdirectory you have attached definition files of various objects. So then you can give kubectl diff option r of option f configs, and finally you say apply option r, that is recursively to process recursively to process the directories recursively. We use option r, and configs is the directory where our definition files of objects are presented. Now let's look into this imperative and declarative, the differences between imperative and declarative more. So imperative commands, so advantages compared to the object configuration. So commands are expressed as a single action word. That's the best advantage. And then commands require only a single step to make changes to the cluster. Disadvantages, disadvantages compared to object configuration. Commands do not integrate with the change review processes. Commands do not provide an adult trail associated with changes. And one more disadvantage is commands do not provide a source of records except for what is live. And commands do not provide a template for creating new objects. And imperative object configuration, the next one, the advantages of imperative object configuration compared to imperative commands are object configuration can be stored in a source control system such as Git, whereas imperative it is not possible, because even it can be saved, it can be used later. So object configuration can integrate with processes such as reviewing changes before push and audit trials. So object configuration provides a template for creating new objects. Disadvantages of imperative object configuration compared to the imperative commands are following. So object configuration requires basic understanding of the object schema, and object configuration requires an additional step of writing YAML file, YAML file. Until unless you write YAML file, it is difficult to make the way of working as imperative object configuration. Then we have a declarative object configuration. So advantages of declarative object configuration compared to the object configuration, imperative object configuration. So changes made directly to live objects are retained. So even if they are not merged back into the configuration files. So the declarative object configuration has better support for operating on directories and automatically detecting operation types. It could be create, patch, delete per object. It's basically this Kubernetes is absolutely dependent on objects. Then some of the disadvantages compared to imperative object configuration are declarative object configuration is harder to debug and understand results when they are unexpected. So partial updates using defs create complex merge and patch operations. Now it's time to work with Kubernetes object. A most awaiting session in Kubernetes is working with Kubernetes object. So without working on Kubernetes object, if you try to do something, that is all useless. because it's the heart and soul of Kubernetes. That is, the heart and soul of the Kubernetes is object. So let's begin Kubernetes object by understanding what a Kubernetes object is. So this slide explains how Kubernetes objects are represented in the Kubernetes API and how can you express them in .yaml format. Kubernetes objects are persistent entities in the Kubernetes system. Kubernetes uses these entities to represent the state of your cluster. Specifically, they can describe what containerized applications are running and on which nodes. 2. The resources available to those applications. 3. The policies around how these applications behave, such as restart policies, upgrade policies, and fault tolerances. A Kubernetes object is a record of intent. Once you create the object, the Kubernetes system will constantly work to ensure that object exists. By creating an object, you are effectively telling the Kubernetes system what you want your cluster's workload to look like. This is nothing but your cluster's desired state. So now let's look into object spec and status. Almost every Kubernetes object includes two nested object fields that govern the object's configuration. The first one is the object spec and the object status, out of which for objects that have a spec, you have to set this when you create the object, providing a description of the characteristics you want the resource to have its desired state. The status describes the current state. The object status describes the current state of the object supplied and updated by the Kubernetes system and its components. The Kubernetes control plane continually and actively manages every object's actual state to match the desired state you supplied. For example, in Kubernetes, a deployment is an object. A deployment is an object, and we'll see what all objects are there. But before that, we'll see one example. That's a deployment. A deployment is an object that can represent an application running on your cluster. When you create the deployment, you might set the deployment spec to specify that you want 3 replicas of the application to be running. The Kubernetes system reads the deployment spec and starts 3 instances of your desired application, updating the status to match your spec. So then you can describe a Kubernetes object. Describing a Kubernetes object, for that, when you create an object in Kubernetes, you must provide the object spec that describes its desired state, as well as some basic information about the object, such as the name of the object. When you use the Kubernetes API to create the object, either directly or via kubectl, the API request must include the information as a JSON in the request body. Most often, you provide the information to kubectl in .yaml file that you can see on the screen on the right side or right portion of your screen. And The kubectl converts this .yaml file information to JSON when making the API request. So minimum required for fields in the in the .yaml file for the Kubernetes object that you want to create, you will need to set the values for the respective fields. The first one is API version, which version of Kubernetes API you are using to create the object. Then kind, which version of the Kubernetes, of which type of Kubernetes object you want to execute, you want to run. That's our kind. Then metadata data that helps uniquely identify the object, including a name string, UID, and optional namespace name string. Then finally, we have the most important component of this object.yaml file is spec. So spec basically talks about what state you desire for the object. So in that spec, there will be selector and then match labels, app that you want to run. This is basically state of the object or desired state of the object, replicas, template, metadata inside the spec. All these sub objects will be presented. Containers, more and more. If you want to run a container, either you can build it or you can run from image, then you have to give image name. So that's what is a .yaml file to create an object. So in another way, we will call it as a definition file. We can call it as a definition file. So in this example that you see on the screen, .yaml file that shows the required fields and object spec for a Kubernetes deployment. This is a deployment object. One way to create a deployment using .yaml file like the one above is to use the kubectl apply command in the kubectl command line interface, passing the .yaml file as an argument. So to do this, to run this deployment, to create this deployment object, so we have to give this command, that is kubectl apply and f option and then /, or here you have to give this application.yaml file as an argument. If you have in a local machine, you can directly give it as a local directory, or if you have somewhere stored in HTTP, so then you have to give the complete URL of the same. So the output you will get it like this: deployment.apps. The deployment object has been created. So now let's see most widely used objects which are part of uh, Kubernetes are the following. The first one is pod. Pods are the smallest deployable units of computing that you can create and manage in Kubernetes. A pod is similar to set of containers with shared namespaces and shared file system volumes. And then what we have is a service. A service is an abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and load can load balance across them. The third object that we are going to see is replica set. So a replica set's purpose is to maintain a stable set of replica pods running at any given time. As such, it's often used to guarantee the availability of a specified number of identical pods. Then we have deployment object. A deployment object provides declarative updates for pods and replica sets. You describe a desired state in deployment. We have seen an example in our previous slide also. What we do in deployment, you describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. You can define deployments to create new replica sets or to remove existing deployments and adopt all their resources with the new deployments. And the next object that we are going to see is config map. The config map object is an API object used to store non-confidential data in key value pairs. So pods can consume config maps as environment variables, command line arguments, or as configuration files in volume. A config map allows you to decouple environment specific configuration from your container images so that your applications are easily portable. And secret. A secret is an object that contains a small amount of sensitive data such as a password, a token, or a key. Such information might otherwise be put in a pod specification or in a container image. Using a secret means that you don't need to include confidential data in your application code. Then we have a volumes object. On disk files in a container are ephemeral, which presents some problems for non-trivial applications when running in containers. One problem is the loss of files when a container crashes. The kubelet restarts the container but with a clean state. A second problem occurs when sharing files between containers running together in a pod. So the Kubernetes volume abstraction solves both of these problems. And the last one that we have here is a namespace object. In Kubernetes, namespaces provides an mechanism for isolating groups of resources within a single cluster. Names of resources need to be unique within a namespace but not across namespaces. Namespace-based scoping is applicable only for namespaced objects, example, deployments, services, etc. And not for cluster-wide objects such as storage class, nodes, persistent volumes. Now let's look into object names and IDs also. So each object in your cluster should have a name, and that should be unique for the type of that resource. And every Kubernetes object also has a UID that is unique across the whole cluster. For example, you can only have one pod named my app 1 2 3 4 within the same namespace, but you can have one pod and one deployment that are each named my app 1 2 3 4. For non-unique user provided attributes, Kubernetes provides labels and annotations. So now names and IDs, again some of the names we are going to see. A client provided string that refers to an object in a resource URL such as /API /v1 /pods, and here you will get the name of that object. Okay, so this is the location, and here at the end you will have that name of the object, and before that what type of object you are using, which resource is that also will be mentioned there. So only one object of a given kind can have a given name at a time. However, if you delete the object, you can make a new object with the same name. So we will see some of the types of commonly used name constraints for resources. So below are 4 types of commonly used name constraints for resources. First one is DNS subdomain names. So most resource types require a name that can be used as a DNS subdomain name as defined in section RFC 11123. This RFC 1123 consists of a standards to label. So this means that the name must contain at least more than it should contain no more than 253 characters. It should contain only lowercase alphanumeric characters, or start with an alphanumeric character, and it should end with an alphanumeric character. Then RFC 1123 label names. These are some of the basically constraints under which you have to name your object. Okay, that's why you just go through it. If you use a RFC 1123 label names, it should contain most 63 characters, and it should start with alphanumeric and end with alphanumeric. That's a remain same. Similarly, 10235 label names by and large same. Path segment names, the most important aspect of path segment names is some it should not name may not contain / or percentage. That should be remembered. Then let's look into one example in the same. Here is an example, a manifest or definition file for pod named nginx demo. As usual, begins with API version, then we'll go for the kind, then we'll go for the metadata, and metadata consists of a name. See, name. This is what we are talking about. Either of these 4 constraints, out of which anything can be used, but you should not cross these constraints. If you cross those constraints, you will it will be error will be thrown. So nginx name, and spec. Inside the spec you can see the image also, that's nginx 1.14.2. then we also have a container port which is mapped with 80, which is exposed, the application has been exposed to 80. So then we'll look into UID also. So every object Kubernetes systems generated string to uniquely identify objects. UID is it is generated by Kubernetes, and it is used to uniquely identify objects. Every object created over the whole lifetime of a Kubernetes cluster has a distinct UID. It is intended to distinguish between historical occurrences of similar entities. And Kubernetes UIDs are universally unique identifiers, also known as UUIDs, universally unique IDs, and they are standardized as ISO /IEC 9834 option 8, and also as ITU -t x.667. Now let's look into labels. Labels are key value pairs that are attached to objects such as pods, deployments, services. So these are called labels. For example, a pod labels can be attached to resources at creation time as well as added and modified at any later time. Labels are intended to be used to specify identifying attributes of objects that are meaningful and relevant to users but do not directly imply semantics to the core system. Labels can be used to organize and to select subsets of objects, okay? And labels can be attached to objects at creation time and subsequently added and modified at any time. So each object can have a set of key value labels defined. So each key must be unique for a given object. So now let's look into some of the examples of key value pairs of labels. Here inside the metadata, of course, it's a JSON format. You can do the same with AML format also. So metadata, inside that you have to mention the labels, and then inside that labels you have to give key value pairs as the labels that you want to attach with the specified object or specific object. So here two labels, example labels that we can take is release is one label, and release the value for release is stable, and release canary. So this kind of labels you can have, or else environment dev, environment QA, environment production, and tire front end, tire back end, tire cache, and partition customer A, partition customer B. A number of labels you can have. Track daily, track weekly. So then, before we look into the syntax, let's look into one more concept, so like why these labels are necessary. Labels enable users to map their own organizational structures onto system objects in a loosely coupled fashion without requiring clients to store these mappings. So service deployments and batch processing pipelines are often multi-dimensional entities. So now let's look into syntax and character set. So labels are key value pairs as we have discussed earlier. So valid label keys have two segments, an optional prefix and name separated by a slash. The name segment is required and must be 63 characters or less, and beginning and ending with an alphanumeric with dashes, underscores, dots, and alphanumeric between. So these conditions are by and large similar to our naming convention. It's not that much difference. Okay. So for example, here is the configuration file for a pod that has two labels: environment, that's a production, and app nginx. So API version kind is pod, then metadata. Inside the metadata, you can see the name, and then after that we have attached the labels. This is right side you see is AML format, whereas on left side it is JSON format. So here we have given two labels, and this is a pod object. So one label is environment. The value for environment is production. This is a production environment. The pod that we are creating, we are creating inside a production environment. And second one is app label. So the app pod that we are creating is nginx. Then we'll have a spec and spec containers, and then name, image name, where, and port. So that's how we label our Kubernetes objects. So then let's look into label selector also. So unlike names and UIDs, labels do not provide uniqueness. In general, we expect many objects to carry the same labels via a label selector. The client or user can identify a set of objects. A label selector is the core grouping primitive in Kubernetes. The API currently supports two types of selectors. One is equality based and set based. A label selector can be made of multiple requirements which are comma separated. So first we will look into equality based requirement. Equality based or inequality based requirements allow filtering by label keys and values. So matching objects must satisfy all of the specified label constraints, though they may be have additional labels as well. So some of the operators that we use here is equal, double equal, and exclamation equal. That's a not equal. And some of the two examples you can see while using equal, so we can make environment equals to production, and another label is tire that is not equal to front end. This is not a front end tire. So then we have an example of the same kind pod metadata, and here is a spec and containers resources limits and node selector is mentioned here at the bottom. Accelerator accelerator colon NVIDIA Tesla P100. Then we have set based requirement. A set based requirements allow filtering keys according to set of values. Three kinds of operators are supported: in, not in, and exists. So you can see this example: environment in, and these are the values: production and QA. Tire not in, front end and back end, or partition, or just simply not partition. This is another way of basically mentioning the labels. That's called label set based requirements. Then API list and watch filtering. List and watch operations may specify label selectors and to filter the set of objects returned using a query parameter. Both requirements are permitted. So equality based requirements and set based requirements both are permitted in API list and watch filtering. So here you can see one example. Both label selectors can be used to list or watch resources via a REST client. For example, targeting API server with kubectl and using equality based one may write kubectl. We want to see all the pods, and then this and forward slash, that's the line continuation, sorry, backward slash, that's a line continuation, and two labels are mentioned: environment equals to production and tire is equals to front, and these are the two labels are mentioned here. So or if you want to write the same using set based requirements, you can write kubectl get pods and then environment in, that's production one, and tire in is our front end one. So as already mentioned, set-based requirements are more expensive. For instance, they can implement the OR operator on values also. You can you can do that using OR operator also. Then we will see Kubernetes objects annotations. What is annotation? Annotation are, you can use Kubernetes annotations to attach arbitrary non-identifying metadata to objects. So clients such as tools and libraries can retrieve this metadata. So attaching metadata to objects, you can use either labels or annotations to attach metadata to Kubernetes object. So labels can be used to select objects and to find collections of objects and that satisfy certain conditions. In contrast, annotations are not used to identify and select objects. So the metadata in an annotation can small or large, structured or unstructured, and can include characters not permitted by labels. So here are some of the examples. Annotations, they are like labels, key value pairs. You see that example, annotation key 1 value 1, key 2 value 2. So again, syntax and character set. Annotations are like key value pairs, and the conditions under which, the constraints under which you have to mention the uh, annotations are remain same, like similar to label and names. There is nothing much to discuss, we have gone through it earlier. So here is an example. If you want to see, for here is a configuration file for a pod object. This is a pod object definition file that has the annotation. So you see that annotations demo. So image registry you have mentioned, and then after that you have given the value. Then we will look into the final concept of Kubernetes object components. So owners and dependents. In Kubernetes, some objects are owners of the objects. For example, a replica set is the owner of a set of pods. So these owned objects are dependent on their owner. So ownership is different from the labels and the selectors mechanism that some resources also use. For example, consider a service that creates endpoint slice objects. The service uses a label. The service uses those labels to allow the control plane to determine which endpoint slice objects are used for that service. In addition to that, labels, each endpoint slice is that's managed on behalf of a service as a owner reference. Then owner references in object specification. Dependent objects have a metadata dot owner references field that will reference their owner object. And Kubernetes set the value of this field automatically for objects that are dependent of their objects, like replica sets, daemon sets, deployments, jobs and cron jobs, and replicant controllers. Then we have ownership and finalizer. When you tell Kubernetes to delete a resource, the API server allows the managing controller to process and finalizer rules for the resource. So finalizer prevent accidental deletion of resources. Your cluster may still need to function correctly. For example, if you try to delete a persistent volume that is still in use by a pod, the deletion does not happen immediately because the persistent volume has the Kubernetes.io protection finalizer on it. Instead, the volume remains in the terminating status until the Kubernetes clears the finalizer, so which only happens after the persistent volume is no longer bound to a pod. So Kubernetes also adds finalizers to an owner resource when you use either foreground or orphan cascading deletion. In foreground deletion, it adds the foreground finalizer so that the controller must delete dependent resources that also have. Now let's wrap up this objects with recommended labels. You can see the following recommended labels. You can visualize and manage Kubernetes objects with more tools than kubectl and the dashboard. A common set of labels allow tools to work interoperably, describing objects in a common manner that all tools can understand. So in addition to supporting tooling, the recommended labels describe applications in a way that can be queried. So metadata is organized around the concept of an application. So Kubernetes is not a platform as a service and and it does not have a have or enforce the formal notion of an application. So here share labels and annotations share a common prefix, that is app.kubernetes, and labels without a prefix are private to users. That's how you have to differentiate the public and then private labels. The shared prefix ensures that the shared labels do not interfere with customer user labels. You can say that these are public IO and the name instance version component part of managed by, and this is the key, and these are the description, and here you could see the example, and these are the type string type. To illustrate these labels in action, consider the following stateful act. For that, you have to take this example and see all the labels I mentioned. You can clearly see that all the labels app.kubernetes.io /name is MySQL, instance is MySQL ABC XZ by version 5.7.21 component database part of WordPress managed by Helm. Now it's time to make our hands dirty. So to do all the experimentations on various Kubernetes objects, we require a cluster, a Kubernetes cluster. So that's what we are going to do here. So we are going to create a Kubernetes cluster using kops and Amazon Web Services. So how do we do it? So to create a Kubernetes cluster, the first step is we need a domain for Kubernetes DNS records. So I have my domain imlike.com from GoDaddy. So you also have to create your own. Then once that is done, we have to create a Linux virtual machine and setup. So here I'm going to use EC2 instance, and inside that EC2 instance we have to install kops, kubectl, SSH keys, and AWS CLI. Then we have to log into that AWS account, and we have to set up S3 bucket. I am user for AWS CLI Route 53 hosted zone. S3 bucket is to store the state of the objects. Then final step, log into domain registrar to cross check. And once we log into the domain registrar, you have to create NS records for subdomain pointing to Route 53 hosted zone NS servers. So naming servers basically. So naming this NS servers should be a Route 53 hosted zone NS server should be connected with the NS records of the subdomain, so that the EC2 instances which are part of the AWS can be put into the domain of subdomain of GoDaddy, so that we can access these EC2 instances through the domain names using naming server. So let me put these activities into our sticky note, and this is Kubernetes in action. So the first exercise in this is to create a Kubernetes cluster using kops. So first what we are going to do is we will open GoDaddy and we will create our domain. Then as usual, AWS EC2 instance T2 medium. I'm gonna go with T2 medium, and once that is done, we will also create S3 bucket IAM user and route 53 hosted zone. And once this is done, so we will log into our domain registrar, that's a GoDaddy, and then we will point out we'll point out the route 53, or a simple way we'll make connection between route 53 hosted zone, NS servers, and GoDaddy or our domain. Okay, connection. Okay, so these are all steps for now. Then we will proceed further. Once these are all done, we will proceed further. So for that, first we will get into our GoDaddy account if you have one, or else you have to create one account. So let me get into this. This is my AWS instance, and first let me log into GoDaddy. Login. If you do not have, you have to sign up. If you have an account, you can sign in. So I have my account, I have signed in. So now here type the domain you want. So I have my domain imlike.com. If you want to create a new domain like cherry tails, this could be the start of something. So you can find out some cherrytails.com, cherrytails.in. So a lot of .co.in, .co.tv, .shop, .club. So a lot of domains are given. So this is exact match. So if you want to buy it, you have to click it, make it yours. Then you have to continue to the cart, and then you have to pay money. It's 139 rupees for the first year with a 3-year registration. Okay. However, I have my domain, so I'm not going to go with that. So I will use my domain itself. Okay. You have to create your own domain if you do not have. So my domain is imlike.com, because my domain belongs to machine learning and artificial intelligence. So that's the reason I've taken imlike, MLAI. Okay. So let me click OK. And these are all some other, this domain taken, this imlike.com, that's mine itself. But now the charge is, now it's pretty costly. It's 5,249 rupees. We might be able to help you get it. See how. Let me click how to get it. So here is how this works. You get a dedicated domain broker. When you purchase the service, a dedicated broker will help you formulate a strategy and budget to try to acquire your domain. So basically I have taken this domain now. So if somebody wants a similar kind of domain, so some dedicated domain broker will be allocated this work. So he will set up that meeting with the other person who is basically having this domain. So he will talk to the both, and he will create and he will come up with the final solution, and somehow you will get it. The domain broker works the deal for you, and the domain is securely transferred to your account. That's how it works. If somebody wants my domain, so you have to just ask for add to cart, and the domain broker will speak to me, and then if a deal is struck between me and domain broker, and domain broker will pay that money to me, and then it will securely transferred. The domain will be securely transferred to the new person, whoever wants that. However, this is my domain. Now it's costing 5,249 rupees, but before I purchased it at 139 rupees. That's fine. Okay. So now let me get back. So yeah, go back to the work. Yeah. So here you can see this is my, so just click my products, and here you could see account alert, keep you up to date, add SMS alert. That's fine. Okay, this is my domain. So I have my domain, so I don't need to create. If you do not have, kindly create your domain. So if I click on DNS, I have some existing naming servers. I'll delete all this. TTL, okay. So I have some existing naming servers, and okay, this 6 DNS records has been deleted, and I'll delete these also, so that when we are working on this, it would be pretty clear for you, or else you will get confused. So that's the reason I'm deleting the existing, yeah, 5 new DNS records also has been deleted. So yeah, now I do not have any, uh, yes, any DNS domain naming system records. Okay, nice. Yeah, DNS records. So these are all default one. Let's keep it. Okay, you've seen my DNS, and you should also get similar page for your domain if you have created, and you can click on manage to get into more information about your domain. So okay, just come here. This is all about your domain, forward domain, manage DNS, and if you click here and here, you will have your emails with imlike.com with your domain name. I think it's pretty clear now. So I hope you also created a domain name with this account. So let me mark up this. So the first one, let's open GoDaddy and create our domain. So the domain name should be remembered. It's imlike.com. So let me copy this and keep it in sticky note. This is what my domain is. Okay. So now what's the next step? It's time to create our EC2 instance. Now let's log into our AWS account, and we'll create an EC2 instance. So this is our AWS EC2 instance, AWS account, and this is our AWS console. And if you do not have AWS account, kindly create AWS account and then join with me in this session. So I will click on EC2 instance service. So this is Tokyo. I'm gonna go with US East 1, East 2, Ohio, and West 1, West 2. I'm gonna go with US West 2, that is Oregon. Yeah, here I'm gonna launch my EC2 instance. So just note down here, it's US West 2, that's Oregon. That's the region, and this is kops. The name of the instance I'm gonna give is kops. That's a KOPS, kops. I'll go with Ubuntu 20.4, 20.04, and here I'm gonna give T2 medium, then key pair. I'll create a new key pair, so I'll say kops key. Yeah, then network setting, I will go with the simple network settings, only SSH, nothing much. kops SG and kops SG. So this one my IP, and rest all remains same. So let me launch this EC2 instance. By the time I'm gonna take, okay, so EC2 instance successfully initiated, successfully it's been initiated. So now let me go to the downloads and take this kops.key and let me put it into create cluster. So this is where I'm gonna put my kopskey.pm. So that's it. Let us check. By the time it gets and it's up and running, we will do other tasks. So this is done. The first step is done. Second step, AWS EC2 instance creation is also done. That to T2 medium. So now we are gonna create S3 bucket first and IAM user, then route 53 hosted zones. Okay. So let me, yeah, I'm here only. So now S3 bucket. Next one is S3 bucket scalable storage in the cloud. Let me click on S3 bucket service in AWS services. Now you can see that Amazon S3 store and retrieve any amount of data from anywhere. If you want to go through this, you can go through it, so that you'll get a clear-cut understanding of what is S3 bucket. But for now, we will create our bucket. So name of the bucket I'm gonna give is V profile Charan kops state, because this is we profile this bucket where we will be using it to store the state of each object. So that's the reason the name we gave as a V profile Charan kops state. Okay, so we have created S3 bucket and we'll put it in US West, Oregon West, US West 2. Fantastic. You don't need to touch it. Region is also fine. And rest all you can keep it same or default settings. You don't need to attach anything else. Rest all will go with the default settings. Okay. Rest all fine. Let me create a bucket. So name of the bucket and region of the bucket are important for us. So now successfully created bucket. Bucket name is this V profile Charan cop state. Let me copy this. No. just name, I just want to copy this bucket. So put it in here. Yeah, this is our bucket name S3. Next, S3 bucket is done. Now it's time to create IAM user. So let me go to IAM services. Why do we require IAM user? So we want to access AWS, our AWS account from some other instance, some other machine. But how can you do that? So the only option is you have to create an user and then you have to give access to that user, and the security key, the access key should be stored in a machine from where you want to access this through AWS CLI. For that, you need to install AWS CLI in another machine, and there you have to provide the security keys of this user, so that from that, as a user, through your AWS CLI, you can access your Amazon Web Services account from a third machine or third party machine, or the machine which is not directly connected with the AWS. Okay, so now let's create a user. Let me click on users first. So we have IT admin, Terra admin. So now we are going to create a new user named kops admin. So the name I'm going to give is kops admin, KOPS. Let me make it small. Kops admin is the name. So enable console access optional. That's not, console access is not. For programmatic access, you can generate access keys after you create the user. So let me click next. Let me click attach policies directly, and what policy I'm gonna give is administrator access. So AWS access type programmatic access, and then permissions I'm gonna give administrator access. Rest all fine. Permissions boundary is not set. We'll keep it same, optional. Then we'll go one step ahead, and now you can see review and create administrator access tag is not required because we have attached a kops admin. Now let's create a user. So now it's creating a user. User has been created successfully. You can view and download user's password and the email instructions for signing into the AWS management console. So let me either click here view user, or else we can click there. Yeah. So now here we can find out a security credentials. Okay. Let's enable console access, or else we'll directly create create an access key. So access key best practice, that's okay. Let us directly create a CLI, command line interface access. Okay. And click next. And check I understand the above recommendation and want to proceed to create an access key. So key, the name I'm going to give is kops admin access, and create access key. So it's been created, and here is that, and you can download the .csv file from here. So cut and paste it in your directory. This is your file. kops admin, and here you can see your access key and secret access key. So never access key and secret key. So never ever reveal this access key ID and secret access key to anybody. This is very secure and you have to keep it safe. I'm gonna delete this user from this, so that's the reason I'm basically showing it to you. However, I don't encourage you to share this with anybody, even with your friends. So now so the second activity is also done successfully. So now, so S3 bucket is done and IAM user is also done. So, and now the name of the is kops admin is the name of the user, IAM user. Now it's time to create route 53 hosted zone. Route 53 hosted zone. So for that, I will again route 53. Yeah, we can see that service route 53 hosted zone. Yes. Now we are gonna create hosted zone, and let me click on create hosted zone. So the domain name, this is the name of the domain that you want to route traffic for. So I'm gonna give cube vpro.imlaic.com. Yes, so that's what and it's a public hosted zone, and I'll give the same description. This is hosted zone for cube cluster. Rest all remains same. I'm not touching anything. So let's create a hosted zone now. So the hosted zone has been created. Let me close this. So 0 records. Cube Wipro, sorry, spelling is wrong. Let me delete this zone and create new zone. Create a hosted zone. This time at least I have to give proper one. Cube Wipro dot imlaic.com. Rest all hosted zone for cube cluster. Create this hosted zone now. Yes, kubewipro.imlaic.com. Everything is fine. So here you can click for the hosted zone details, and these are 4 naming servers. These are 4 name servers that we have, and here you can see that kubewipro.imlaic.com. This is a routing, and these are the 4 naming server, and this is SOA, and this is simple one, like basically, and here this is not the naming server. Okay, so this is also done. So name of this hosted zone is cube vpro imlaic dot com. Okay, now it's time to make a connection between route 53 hosted zone name servers and domain. So for that, what we have to do is we have to copy this. I'll copy all these 4, yeah, and I'll put it in our, yeah, here is fine. Yes, so now let's get back to our GoDaddy. Yeah, here it is, and yeah, this is my DNS, and let me click on DNS, or yeah, now you can see our DNS records. In this, I'm gonna add a new DNS record, domain naming server record. So choose an account. So I'm gonna go with NS, and this one I'm gonna exactly name. I will give Cube Wipro, and here the first one DNS. Let me get here the first, yeah, NS1, then TTL. I'm go with the default. I'm not gonna touch that. Okay, and so let's add this. Let's add this record. Update a DNS record imlike.com success. So you should find this here. So NS, yeah, NS Cube Wipro, fine. So now let's add one more record. Again NS name, yeah, and it's the second one. Default, I'll go with the default. Done. Next we will attach a third record. NS Cube Wipro, and default is absolutely fine. Let me, done. And the final record of naming servers NS and Cube Wipro, and paste the final naming server record, and TTL is default, and let's add record. That's it. All records has been added, and you can see that these are the 4 records has been attached. So now let's get into our sticky note. So the connection between Route 53 host John and NS server domains, Route 53 host John, NS servers and domain has been established. So now let's get into our hosted John and refresh it. Yeah. So far we have done with domain, the first step, and the third step, and the fourth step. Now it's time to do this installation of kops, kubectl, SSH keys, and AWS. These are the steps left. Let's do that. So for that, the steps follow like this. Let me go back to the AWS EC2 instance step. So here I'm gonna do. So first, once we log into the EC2 instance, then SSH keygen, we will generate that. Then we will install AWS CLI, then AWS configure, then once AWS configuration is done, then we will install kubectl and install kops. Once installation of all are done, then we will verify the domain and we'll create our cluster. That's it. Once all are done, Next, the fifth step is to create a cluster and verify our domain. That's it. Okay, let's begin our installations. Let's begin with SSH key gen. Now, but before that, we have to log into our system. Let's get into our AWS and then we'll see what's the condition of EC2 instance. So EC2, I should be in US West 2 region, Oregon. Yeah, it's a Tokyo. Let me change to US West 2. That's Oregon. Yes, here one instance is up and running. So let me click on that instance and click on connect and copy the SSH command and get into my directory where kops key is there and open a git bash there and then paste the command there and enter. So yep, we have successfully logged into the system. Now let's begin our activities. Okay, now pwd, yeah, it's a root directory, so snap. Other than that, nothing else. So here I am going to create my ssh keygen, ssh keygen, and execute. So generating public private RSA key pair, it's asking the file name. I will give kops SSH. So enter passphrase. I will give okay. That's it. Our SSH key has been generated, and this is the random art image that you can see here. And let me show you that. ls, you see that kops SSH and then kops SSH.pub. This is our public key and this is our private key. That's it. So now let's begin our installations one by one. The first installation we are going to do is AWS CLI sudo apt update. Okay, you can see that US West 2, this instance belongs to. Yeah, all done. So now it's time to give, say, apt install AWS CLI option Y. So the installation process has been started and it's being installed. It's unpacking the package. So 95% is done. Let's wait for rest to be done. So but once installation is done, the next task is to configure this AWS CLI with our AWS user that we have created in AWS account, so that we can access our AWS account from this EC2 instance, from this kops server using, sorry, this is not kops server, this is just a kops. From kops machine we can access that AWS account. So let's give AWS configure. So it's asking AWS access key ID. So we have downloaded it. If you remember, here is that. This is our AWS access key ID. Let me copy this and paste it here. Now it's asking AWS secret access key. Again, let me copy this and paste it here. So now default region name, it's US. Let's confirm one more time. It's US West 2. Okay, US West. US West. Yeah, correct. Then default output format, I'll go with the JSON. And that's it. Configuration is successfully done. So now what's left? Let's install one by one. So before that, let's see the status. So SSH keygen AWS CLI installation is done. Configuration is also done. Now kubectl and kops are left. For the kubectl, let's get into our documentation. Yeah, install and set up kubectl on Linux. Install kubectl binary with curl on Linux. So we have to download. This is common. This is only for Linux. You can use it, or you can just directly come here. Debian based distributions. This is a specific way of doing. But what we are going to do is we will use this directly. Curl instead of using packages. We will use the curl. This is far better. Download the latest release with the command. So we'll use this. Yeah. So get back and paste it here. kubectl AMD64 bin Linux, absolutely fine, stable version. Yeah, that's okay. So now it's being fetched, it's done. Now what we have to do is we have to give permissions to execute this binary file for all the users. So that's the reason I'm going to give +X, and the name of this is kubectl. That's done. Then let's move this kubectl binary file. You can find out here. You see that the kubectl, this file, and if we do lslrt, you could see that for the kubectl we have given execute permission for all. All means all. For the owner, for the group members, and for others, everybody can execute kubectl. So now what I'm gonna do is I'm gonna move this kubectl file from root directory to the, that's a root user home directory, to the binary file, binary directory. So for that I'm putting to user, I'm going to put this into user local and then bin directory. That's it. It's been placed into the bin directory. You could see that no kubectl here. So now let's validate the installation of kubectl. For that I'm going to say kubectl help option. That's it. kubectl has been successfully installed, and you can see some of the commands. So all these commands we are going to use. Don't worry at all. Deploy commands, basic commands: create, expose, run, set, describe, delete, rollout, scale, everything we are going to see. So this is also done. Now install kops. It's time to install kops. Let me clear the screen first. To install kops, so again we'll get into our documentation, and this time I'll say install kops, installing Kubernetes with kops. Creating a cluster, Linux. Yeah, so we'll go the Linux, not and then it's kops Linux AMD64. Kops Linux AMD64. This is the correct version. So we are going to take this kernel. Of course, you will have another ways of installing this using packages and all, but I would love to go with binary file. That's pretty easier than other ways. So Linux, because I don't this could be this can be used in any Linux distribution, so that's the reason I'm gonna do with this. So again, let me do curl the binary file of kops AMD64, and let me do ls. Yes, here you should see kops Linux AMD64. kops Linux AMD64 binary file is absolutely visible. Now let me do ls lrt and kops Linux AMD64. Nobody has execution rights, execution permissions, neither owner nor user, neither owner nor group members nor others. So now the first activity that we are going to do is chmod plus execute permission X and kops Linux AMD64 and execute. And let's cross check that. And here it is. Execute, execute, execute. User, owner, group member, and others all has the execute permissions. Now let's shift this file from root home directory, root user home directory to the binary directory. So kops Linux AMD64 and / user local bin and kops. Oh, sorry, not kubectl, it's kops. So this is where I want to move into the kops directory, and let me execute this. I think it's successfully moved. Yeah, no file here. So now I'm gonna validate the installation of kops. For that, I would say kops and help option. That's it. It's successfully installed, and you can see the available commands of kops create. This we use to create the cluster, a Kubernetes cluster, and delete to delete the cluster, and we have update to update the cluster, and version. Let's give the version kops version, and here it is, the client version 1.25.3. and now let's mark this. So installation of kops is also successful. Now it's time to create a first ever Kubernetes cluster. But before we create a Kubernetes cluster, we will verify our domain also. Okay, we'll verify our domain whether it's been properly integrated with our AWS Route 53 hosted zone or not. That's what we're gonna do. Let's validate that. For that, I would say ns lookup, that is naming server lookup, and option is type. What type you have to look, that is ns naming servers. You look for naming servers, and it's a cube v pro, that's our hosted zone, that's what we have given, and imlaek.com. Correct? That's it. Here it is, server and cube non-authoritative answer, and you could find out that kubevipromlac.com has been connected, because this is mlac.com and this is naming servers. Properly it's been connected. Okay, so we are able to find out the information about this. So we have verified our domain. So this has shown all the 4 naming servers which are running in Route 53 hosted zone. Okay, so now it's time to create our Kubernetes cluster. So let me clear the screen. It's a very big command. So kops create and cluster. Now name of the cluster equal to cube vpro dot domain. Cube vpro is subdomain and main domain is imlaik.com. And state, where did we put the state? State is S3 bucket. Let's get into that and we'll copy that. Connect to EC2 instance and let me click on S3 bucket service. Let's bring it up. So yeah, I have this S3 bucket and let me click on this S3 bucket, and if you want to upload or download anything you can get it. And the properties and US West absolutely fine, and this is what we want. It's a V profile, S3 V profile cop state. Okay, let's copy this. Let me click on access point. Yeah, it's fine. The rest of it's okay. Yeah, state equal to, we are using S3 bucket and name of the bucket is this. I'll paste it here. Done. Then Jones US West. So I will go with US West. Okay, but before, let me cross check what all that US West has. EC2 instance and global view. Yeah, we are in. Let me come down. US West, US West, US West, US East, US East. 1, 2, yeah, European Union, US West 2. Let me click on this. It has US West subgroups. So I'll use this Oregon. Yeah, here you should find zone name. You have US West 2A, 2B, 2C, 2D. Total we have 4. So I'm gonna use just US West 2A and 2B. That's more than enough. So US West 2A comma US West 2B. That's it. And after that node, then we have a node count. How many nodes you want to have, that you have to mention. So node count. So I'm gonna have node count of 2. I will create a 2. Okay, 2 nodes. Kops is our main node and remaining 2 nodes are our working nodes. Okay, 2 nodes. And size of the node size, that's a T3 medium. Our T3 small is also absolutely fine, but that's okay. T3 medium. Then DNS zone, this is very important. DNS zone, it's a DNS zone we have written. Let me copy that from here, or else whatever from, yeah, this is S3 bucket. Yeah, this is our DNS zone, cube Wipro imlight.com. Yeah, it's I'll paste it. DNS zone name done. Then node volume size. What's the volume you want to provide for your working nodes? Node volume size equals to 8 GB. Then master volume size, it's a master for a master node. So master node volume size, I'm gonna give, how much would be better? Just let me think. I think for master volume size it would be 8 would be fine. It's okay. 8, 16 also okay, but 8 would also be okay. That's it. So now we have to enter and see what's gonna happen. So if you go through the output, it's been printing on the screen. Okay, finally configure your cluster with kops update cluster name. Okay, so it's been the template has been created. Now we have to update this, and then we have to validate that. So once the validation is done, so we could see. So we have to update the cluster. So it has, so now you could see that the cluster configuration has been created. That means a template has been created. Now suggestions, list clusters with kops get cluster. I did this cluster, that's okay. And then edit your node instance. And so now finally configure your cluster with kops update cluster, and the name S and admin. Of course, we have to provide the S3 bucket also. That's very important. Without providing the node, uh, without providing the S3 bucket information, you cannot store the state of the object. So that is the reason we have to provide. So now the template has been created. Now we need to update it, and then finally when we say validate, everything will be created. So now let's update the template. So kops update cluster name option. So it's a cube Wipro, it's on top. Let me copy this and paste it here. Then after that we have to attach the state, that is S3 bucket. State, we are using S3 bucket, and it's a V. Where is that? Okay, I might have, yeah, here it is. I copied some, yeah, V profile Charan cop state, correct? Exactly. So let me paste it here. Done. And let us say yes and admin, and let's execute. So cluster is gonna start issuing new certificate etcd peers CA events. If you remember the etcd, we have discussed about the etcd and what it does. So now here you can see clearly on the screen what the etcd is doing. Okay, cluster is starting. Now it should be ready in a few minutes. So suggestions from kops validate cluster. So kops validate cluster, wait 10 minutes, and list nodes, kubectl get nodes. If you use these commands, you can do this kind of task. That's what the suggestions are doing. So now it's we have to wait for 15, at least 10 to 15 minutes to uh, for the setup to happen. Okay, after 10 to 15 minutes we're gonna do kops validate the cluster. So then our, let's wait for few more minutes and we'll get back to this. Yeah, now let's validate the cluster. So for that I am gonna say kops validate and cluster state, again s3 bucket, sorry, s3 bucket, and the name of that is, I'll just copy it exactly, I don't want to make any mistake, so I'll just copy and paste it. Yeah, that's it. Let's execute and see what's gonna happen. So using cluster from kubectl context, that's a kubevpro.mlac.com, that's our route 53 hosted zone. So validating cluster kubevpro.mlac.com, and here you could see master node, US node, a master node, and a working node, and a working node. So all are of T3 medium, and US West 2A, 2A, 2B, all has been the node status master node, working node. One master node and two working nodes have been created successfully. Your cluster kubevpro.mlac.com is up and running. It's ready for, it's ready to serve you. So now let's validate and look at Kubernetes cluster from kubectl, and we'll see what's going to happen. But before that, let's mark these things. Okay, all done, all done, absolutely all done. Now, so let's validate this Kubernetes cluster from kubectl using kubectl. So let's do ls, and we have these files because we are in a root home directory or root user home directory. So I am gonna say cat, and I will give the absolute path tilde / dot, and it's a cube, and then inside that you will find the config file. So this config file is very, very important. This is called a kube config file, a Kubernetes config file, and this consists of a lot of information. But for us, a few parameters are very much important. So this is the file which is mainly for the kubectl, but this file is used by kubectl to connect to the cluster. If you want to connect to the cluster from external instances or external server, even from your local machine, still you can do it, but you need to have this config file in your local machine. So that's why this is very, very important. That's a config file of kube. Okay, let's look into that one more time. Yeah, it starts here, and here it's mentioning the clusters. Cluster, the first cluster, the certificate has been given certificate authority data. Inside that you can see that the name that we have mentioned, the kubevpro.mlac.com, absolutely this is ours. And the domain that we have used, if you remember, http, this is the complete URL of our server, and API, this is still that it's API, and after that kubevpro is subdomain, and mlac.com is our main domain. And contexts, we have a cluster with this name, and user with this name, and name also with that name, and here you can see the usernames. You can attach more users if you want. So client, here they have given the client certificate data. That's all about this kube config file for now. So we are going to delve into this kube config file later, but for now this is more than enough. Then this is mainly used to connect to the cluster, the kubectl. If kubectl should connect to the cluster, that is only possible through this. And now let's give one more command. So kubectl get nodes. This is the first ever command that we are giving in this course. Till now we haven't typed any kubectl commands, and first time ever we are typing our command. So we have to celebrate this moment. Cheers for you and me and all everybody who is following this course. Okay, I'm executing the first command in this kubectl get nodes. Cheers, guys. Yes, that's it. And this is the response. So total, how many nodes are running? 3 nodes. One is control plane, other one is node. These are two are working nodes, and this is a master node. This is a control plane. The cluster, we have created a cluster with one control plane and two working nodes, and age 7 minutes, 6 minutes, 6 minutes. Just recently we have created this. So now the next step, so we have done enough of validation inside our so validations of kubectl config file, and then kubectl command. Now we will done. So now we will validate directly in AWS console. Validate the cluster in AWS console. Okay, so let's get into the AWS console, and Oregon, let me click on EC2 instances. Okay, it's dashboard. Let me scroll up. We are in EC2 instances only, and let me refresh it. Here is the magic. Here is the magic. Kops that we have created, and remaining 3. Let me make it yeah, fine. Node, master node. So master node is this, and working node these two. So all 3 instances have been successfully created by kops. So big congratulations to everybody, whoever is following and whoever is able to do this till now or thus far. So one more thing you should able to see here. So let me get it back. Let me get back to that. Yeah, here resources, auto scaling groups. Now you should see auto scaling groups also in addition to instances. What is this? So now this is created by auto scaling group. Whatever these 3 instances were created, those were created. It's not it's not magical. It's a proper systematically happen things. So that was done by auto scaling groups. So if you come to auto scaling groups, you should see 3 auto scaling groups. Absolutely, you see that? So one for master. Let me make it. Yeah, this is master US West 2A, and other 2 for working nodes are workers. Okay, that's how. And this one is created by the AWS itself. Okay, so auto scaling group. So this step is also done. Now let's look into an VPC which was created by kops. So let me note down this. So these 2 were done. So next validation that we are gonna do is 8th one, that is looking into an VPC which was created by kops. Let's get into that. So I will type VPC, a virtual private cloud. I have clicked it on. Yeah. So now I'll click on your VPC, and here it is. Our VPC, that's a kubewipro.com. So we have created a virtual private cloud, and here you can find all the information. DHCP option set you can find out here, and here you could find out CIDR. We have discussed about all this terminology in networking module. If you haven't watched it, kindly you go there and watch it and come back here, because you will have a lot of fun there. So this is our CIDR. This is for IP version 6, and here you could see IP version 4 CIDR. We have clearly explained about this CIDR there. Kindly watch there. So main route table also you can see, and network ACL, and all the information that we can see here. So now let's go to the route 53 zone, and we will validate that also. But let me mark this. So this is also done. Now validating route 53 zone. Yes, here you could see DNS management. You have one hosted zone. Let me click on that one hosted zone. Yes, it is. Here it is. That's kubeviproimlag.com. This is our hosted zone, which is public. It's a route 53 record count 5. Let me click on kubevipro.imlag.com, and you could see the complete information about that. Of course, we have seen this before, but few more important things you might have seen on this. Those are all three. Let me make it bigger, and here it is. See, we got 3 more servers which are included in route 53. One is API kubeviproimlag.com. So route 53 in your hosted zone, you will see new records that are created API kubevipro.imlag.com. In this points to the master node IP. So then you have an internal that points to the master node private IP. This is the internal. It points to the master node, whereas this one API which points to the master node, whereas internal which points to the master node private IP. Okay, API master node, this is also master node, but this points to the private IP. You can see that here. You can see that 172 private IP, and the top one is public IP. This is basically our API server. Inside one component, that's an API server. And here you could see the kops controller. This is not important for us because this is out of basically cluster. This is what our cluster. This is private, and this api.kubeviproimlag.com, this is a public one. So now enough of validations. Now let's delete cluster. Let me get back to our server. Let me clear the screen. Okay, gone. Clear the screen. Yeah. So now let's delete the cluster. So how can you delete that? I would say kops help, and to delete, this is to update a cluster. This is to upgrade a Kubernetes cluster. Validate we have used. Version we have used. Export completion is here it is. Create a resource by command line, and this is to delete. Delete clusters, instance groups, instances, and secrets. Okay. So let's delete this. I'll say kops and delete cluster, and name of the cluster equals to, we know that it's a kubevipro.domain, that's imlag.com, and state S3 bucket. That's what it's storing the state of our objects or of clusters. So that's let me copy this directly. Yeah, here it is. Yep. So that's it. Now let me say S and done. Error reading cluster information cluster.kops.kh. Oh, that's it. So that's the that's the issue when you type names of the cluster or S3 bucket. See, I missed out a zero O there, so it could not find that. So now it's gonna delete the cluster. It's deleting that. Not all resources deleted waiting before re-attempting a deletion. That's okay. Volumes, DHCP options, route tables, subnets, completely virtual private cloud is going to be wiped off. An internet gateway, and let's wait for a few more minutes. Volumes are getting deleted. That's okay. So it's going to delete all of them, and it takes some time. Once the cluster is once the cluster is deleted, it's going to give it's going to give us back our shell. And never ever do not try to delete this cluster manually, like when we were kids, when we were watching WWE. So that time they used to say, do not try this. So I am also saying, do not try to delete this cluster manually, because it's lot. There are a lot of things are there. So if you really want to do it manually, then you have to start from auto scaling groups. First you have to delete auto scaling group, then you have to delete one by one all the services that we have used. Okay, that's it. Deleted kubectl config for kubeviproimlac.com. This is our cluster name. So the cluster has been deleted successfully. Now let's rerun the cluster. I'm just playing around. Okay, now let's rerun the cluster. So to rerun the cluster, now if we want to create it once again, it's just two commands, just two commands. So but most important aspect is the most important thing is you should not remove your prerequisites. That means I'll show you that all those things should not be removed at all, like S3 bucket, IAM user, route 53 hosted zone. These things you should not touch it. If they're intact, that means you can recreate our cluster with two commands. Okay, the first command is kops. Let's give the command directly, or I'll just volume is 8 and master volume is 8. Absolutely fine. Let me create this. Now the template is going to be created. Then we have to update the changes. We have to update it and we have to validate it. So that's it. Okay, error reading. What's the issue? Okay. S3 bucket, na? The issue is with S3 bucket. Okay, let me copy that. Let me check the S3 bucket. Okay, kops, maybe cop, some spelling mistake. V profile cop states. Okay, I got it. I got it. I got it. I got it. The issue is here. Yeah. Anyway, I'll just paste it. State again. That's also one more issue. Yep. That's it. CIDR. Let's wait for that. Finally, configure your cluster with kops update cluster. So let's update that. Kops update cluster and name. It's a cube vpro dot imlac Okay, we'll keep this one and we will do the changes. Till state will it remains same, then adds a yes, and admin. So rest all fine. So this is also okay. So here I'm gonna say kops update. Yeah. So the template is being updated, and finally we to validate, then our cluster will be up and running. But before, yeah. So that's it. The cluster, it should be, the cluster is starting. Now the cluster is starting. Now after a few minutes it should be ready. So we have to say validate. So validate is nothing but we are just cross checking whether the cluster is started or not. So first one, when we say kops create, it will just create a template. It will make sure everything is done, all are available. And once we say kops update, then it's gonna create, it's gonna do actual action, it's gonna create those things. And when we say validate, and it's all done, it's cross checking, it's validation. So now let me say kops validate and cluster, and here name is not required. Let me give the state, that's s3. V profile Charan and kops state. That's it. Let's see. I think it will take some time. Okay. Okay, it's taking some time. Let's wait. Cluster not at healthy. We have to wait for a few more seconds, a few more minutes maybe. That's it. Our cluster cube wipro.imlac.com is up and running. Let's validate it one more time. So EC2 instance, and here it is. We are in Tokyo. Let's go to the Oregon. That's US West 2, and you should see instances running, and we will go for all instances all. That's it. See, 3 instances were terminated because we have deleted the cluster. So those initial 3 were terminated, and now again master and then working notes again has been started back, and you can see the complete information about that. Okay, I think it's pretty clear for you. So we have seen enough. Now what we're gonna do is, if you want to if you want to continue with this with the next tutorial, you can simply leave this cluster up and running, or else you can delete this cluster saying kops delete command. Okay, but I hope you will follow me for the next session. So keep that cluster up and running. We will see you in another tutorial, that too specifically on Kubernetes objects and config files. Now let's look into a kube config. So welcome to the world of Kubernetes, and specifically the one which makes you to use a kubectl, that is a kube config. Welcome to the kube config. When I first executed my kubectl commands. In few minutes, I started wondering how this kubectl is connecting to the Kubernetes cluster. How does it know where is my master node and how does it get authenticated and get all that information from the cluster or even create information in the cluster? How does it do? How is it doing? That is the answer is kube config file through config file. So in this slide, what we are going to discuss is all about kube config file exercise. So let's what we are going to do here is we will look into the documentation of kube config. Then we will explore config file in kops kops instance, and third we will use the config file in our local machine to connect with our cluster from local machine. For that we have to install kubectl in our local machine, and we will try some commands from local machine. That's what our agenda for this exercise. Now let's get into the documentation of Kubernetes. Documentation of a config file. So let me type, here you can see the config file, but let me type kube config. Kube config files. Yes, this is our documentation for the kube config files. What is kube config file will do? Organizing cluster access. That's it. The one point. It organizes the cluster access using kube config files. Use kube config files to organize information about clusters, users, namespaces, and authentication mechanisms. This is very important. I will put it here. So that's what the kube config file will do. Okay, cluster, it will have information, it will organize information about clusters and users and namespaces and authentication mechanisms. Okay, so the kubectl command align tool uses this kube config files to find out the information it needs to choose a cluster and communicate with the API server of a cluster. This is what I'm going to show you again. API cluster, API server. That's what another thing you're going to find out here. That is API server in master node. And by default, kubectl looks for a file named config. That's very important. That will be located in home directory .kube directory. So this is where you will find out. So you can specify other config files by setting up a kube config environment variable to this kube config flag. Okay. Then you can read about context, but before that, let's get into our instance and we will open the kube config file. So sudo I I'm in root user home directory. Then here I'm gonna give that kube config file directory. So I would say let me do cd and tilde, that's a present directory, and forward slash, it's in root virtual, it's in present directory, that's a root user home directory. Then we have a dot, and it's a cube because it's a Kubernetes. Inside that we'll find out. Let me do ls, and here you should see cache and config. We have two directories. We have two files in it. One is cache, other one is config, and cache is directory. Let me do ls l, and here you see that cache is directory, and this is a file, config file. So here we should clearly see our file. Okay, and this is where the file will be located, and that's what it's mentioned here, home and cube. Okay, now what all this consists of? It consists of a context. What is a context? It consists of a context element. A context element in a kube config file is used to group access parameters under a convenient name. So each context has three parameters: a cluster, a namespace, and user. Okay, by default, the kubectl command line tool uses parameters from the current context to communicate with the cluster. So let me show you that. I will do cat and config, and let me scroll up to the context section. Yeah, here is the context section. You see that this context section will be till here, current context. So this consists of information about cluster, user, a name, and current context. So basically this context, what it will do, it marries the cluster and user. Basically it connects the cluster and user. Here both are same, kubewipro.mlag.com, kubewipro.mlag.com, but they are not same because one is the name of the cluster, other is the name of the user. So this context makes a provision that user can able to access the cluster. And the name of the context is kubewipro.mlag.com, and here the current context, you can see that this is what the current context. And if you see that what it's saying, uh, the current command line, the cubes by default, the kubectl command line tool uses parameters from the current context to communicate with the cluster. So whatever the current context you have mentioned, so kubectl by default it uses the current context to communicate with the cluster. So you can use this command basically to get the current context from our okay. So kubectl config, you see that the current context is kubewipro.mlag.com. Of course, you can read in directly look into that file. Then we have a kube config environment variable. So you can directly use this. The kube config environment variable holds a list of config files. For Linux and Mac, the list is :delimited. You can put a lot of config files, but you have to separate or delimit using colon. Then merging kube config file, and I would urge you to go through this file documentation of kube config file, and here is an example. So proxy is just an example of how a config file looks like. You can configure kubectl to use a proxy per cluster using proxy URL in your kube config file. So API version, you see that kind. A type of object is config object. We have seen a lot of objects, and out of them, one of them is config. And here you have a cluster information, user information, and context information. This is what a config file consists of. And then cluster information, you have to mention the cluster and then server. Here is that. The server is API server, and then name, and here is the user. Then the context actually marries this, connects this user with the cluster. And here you can see the context. And you can create a lot of access multiple config files. Just go through this. And now let's go through the config file one more time. So we have seen a context. We have seen, yeah, this is a cluster information first, and then a cluster. And let's look into the cluster information, the certificate you have seen, and this is very important, a server. So what is this? This is API URL, a server URL. This is a server URL. Where, what is this server? It's a API server. I'll show you that. Let us get into this. Amazon EC2 instances, and Route 53. Hosted zone, kubevipromlag.com, and scroll down. Now you should find, you see that API kubevipromlag.com. This is a API server, and you just copy this and paste it in sticky note here close to the API server. Now let's get into the EC2 instances. You should see the master node public API, public IP same. So EC2 and it's Tokyo. Let me get into the Oregon, that's US West, and EC2 instances. Just 4 is up and running. Now let me click on master, and this is master node, and you see that. I'll copy this and let's compare both. Space it and paste it. You see that 54201 first 2 octets and second 2 octets exactly same. That's what I'm saying. Now I'll show you exactly what I'm talking about. Let's get back to the our yeah, here, not this one, other one. Yes, this is what I want to show. You see that a master node consists of a API server, because I have shown you all those things theoretically. Now I have to show you practically. So this is a master node. I'll show you the master node now. Let me get into the instances, and this is our master node. Clear? This is our master node. Now this is our master node, and this is our working node. This is a working node. So 2 working nodes. Now I'm going to show you 2 working nodes. So these are our 2 working nodes. You can see that 2 working nodes which are up and running, and this is a one more working node. So this is our cluster. It's clear. Now in working node you will have all this information that we will look into that later, but for now I want to show you this master node. In master node we have a lot of components, out of which API server is the one which we have discussed too much about it. So now I am going to show you that API server practically. Okay, and the API server, here it is. This is the API server that we have shown it to you in infographic, and this is that API server where it is, which is inside the master node. And how can we prove it? How can we prove that? This is how we prove it. See that API server has the public IP of master node. So that's how our API server looks like, and this is name of the cluster. Okay, now it's clear, the API server. Then we have discussed about the context, and then this is what type of object it is. It's a config type object. So we have begun with the config object. Then users, user name is this kubevipromlag.com, and then user certification, client certification data is that, and here is client key data. Basically, if you want to log into SSH, you need username as well as key. That's what we are doing now. When we say connector, let me show that also. Why to worry we have when we have everything. So for example, let me click on here. So if you want to connect with this, so I'm usually copying this command, right? So this is consisting of user ID, Ubuntu, username, Ubuntu, and then here, see the key, ID, RSA, the key. Okay, so similarly, if you want to log into that cluster, you need a username that's mentioned on top and then client key. This is the key, we have to use it. Okay. So that's it about Cube. So how many things we have covered up? So documentation of Cube config API server has been demonstrated, and then we will explore config file. It's done. Now the final task in this config object is we will use the config file in our local machine to connect with our cluster from local machine. That's what we are going to do. So for that, I'm randomly opening our git bash anyway, or else I'll open it particularly in this directory. It's Linux. I'd go for Windows. I'll click on Windows. So Windows, there are plenty of options, but simply I'll go with Choco. Yeah, this is better for me. Copy this. It's the simplest and fastest. So do. Let me open Windows PowerShell. Run as administrator. Clear the screen. Paste it and execute it. So that's it. The kubectl has been installed, and then now let's get into the find out the kubectl version. Okay, it's 4.5.7. Let's create a directory cd and .cube. Done. So let's run that. Now let's get into our yeah, two files are there. Let me come here. Yeah, clear the screen. ls, the config file is there. Now let me say kubectl version help, do cat / dot cube and config. Yes, there is a file client. Okay, this is a different file. It's a Docker desktop. It's kubechurn. So user name is something else. So Docker desktop. So I'm going to change this. So what will we do is we will do the cat of the same file, and because this file is connected from the Docker desktop, so that's the reason. Let me click to the Docker desktop. So by default it has taken Docker desktop file. Let me go to the settings, and here you should see Kubernetes. So from here the Kubernetes has been connected. You see that Kubernetes. So that's the reason. If you want to create a cluster from here, so that by default file is required. So that's the reason. So let me read that one more time. Yeah, cat, and you can see that file. Let us go through this file one more time. Uh, cat cube and config. Yep, I think it's clear now. So the clusters, this is the cluster name, and the server is Kubernetes docker.internal, and the name is Docker Desktop. And here you should see the context. The cluster name is Docker Desktop and user name is kubecheren. I'll show you the username. And where is my Docker Desktop? I closed it. Yeah, this is my username. That's a Docker Desktop or kubecheren. And you see that the kubecheren, that's my username. Here, okay, fine. So that's what the config file belongs to a Docker desktop. So what I will do is I will copy this and I'll place it in my, because after that I'm gonna use a Docker desktop, so I have to replace this. So that's the reason I'll copy this and paste it in my directory. So I'll take a text document. This is config Docker desktop. Yeah, let me save this and close it. So now what I'm gonna do is I'm gonna replace this file. So vim, replace this with our config file, our default config file. So putting it in, so let me delete this, %d, enter. So I think all cleaned up, completely wiped up. So now let me get into my server and copy this from here till till here. So copy and paste. That's it. You can see that username is kubevipromlike.com and cluster name, everything is fine. Yep, let's save it and let me zoom it now. Let me do kubectl version. That's okay. Now let me do kubectl get nodes. That's it. I'm in my local machine and I am able to fetch the Kubernetes cluster from my local machine. You see that control plane node 2. If you have a doubt, let's look into this. We'll copy this thing, or else we'll see, we'll compare both from here. Come to the EC2 instance and EC2 instance. Instance is running and you should see both. Master node ends with 9E9, ends with 9E9. That's a control plane. Control plane ends with 9E9 46385B. Exactly correct. If you have a doubt, we can cross check here also. So kubectl get nodes. See that? Exactly. So that's the power of config object or config file. Basically, you can explore, you can connect with your Kubernetes cluster using kubectl from anywhere, from any machine, if you have a config file, if you have written a config file object. Okay, hence this also has been proven. So all this has been proven. Now I am gonna replace the our cube file with the existing Docker desktop, or else I can't use it again. So let me do the sorry, percentage D to delete all. So all has been deleted. Now let me copy this. Where is my file? So it's here, it is the config docker. So control C and copy is done. Now let me paste it. I think it's properly pasted. So complete information. Let me go up a bit. WQ. Let me do that. Yeah. So Docker desktop user name is Docker desktop, client key, absolutely fine. It's all done. Hence, proved that API server is part of master node, and we have practically demonstrated the same. So till now we have seen and demonstrated practically about kube config. So now we are going to talk about namespaces. So this is a Kubernetes object namespace. We are going to talk about namespaces, how you can group or isolate your resources, that we are going to look into. So namespaces is basically used to group or isolate your resources. So what is a namespace for us? A namespace is an object which isolate or which provides a mechanism for isolating groups of resources within a single cluster. Names of resources need to be unique within a namespace, but not across namespaces. Namespaces of resources which are there inside that the names of resources which are inside that namespace need to be unique within a namespace but not across namespaces. I hope you got that. Namespace based scoping is applicable only for the namespace objects, example deployments, services, etc., and not for cluster-wide objects such as storage class, nodes, persistent volumes. But the question arises when to use multiple namespaces. Namespaces are intended for use in environments with many users spread across multiple teams or projects. For clusters with a few to tens of users, you should need not to create or think about namespaces at all. Start using namespaces when you need features they provide. So namespaces provide a scope for names. Names of resources need to be unique within a namespace but not across namespaces. Namespaces cannot be tested, namespaces cannot be nested inside one another, and each Kubernetes resource can only be in one namespace. Namespaces are a way to divide cluster resources between multiple users. So it is not necessary to use multiple namespaces to separate slightly different resources such as different versions of the same software. For that, you have to use labels to distinguish resources within the same namespace. So normally you can create namespaces for development environment and production environment, and like this you can isolate your environments. For example, you have a dev environment, prod environment, testing environment, and staging environment. For each environment you can have a specific resources names, because each environment you can make it as a namespace, and then each namespace can have a resources with different names. Like this you can isolate your environments. You can also create a different namespaces for different projects and for different teams. So now let's also look into some of the fundamental namespaces that we found inside the inside the Kubernetes. A pod is similar to a set of containers with shared namespaces and shared file systems. So Kubernetes starts with 4 initial namespaces. So what are those? The first one is default, the second one is kube public, and third one is kube node lease, the fourth one is kube system. So what are those? That we are gonna directly jump into our server and we'll see. So let's get into our server. Yeah, this is local. Let me close this. Okay. Done. Exit. Yeah. Clear? So Kubernetes cluster namespaces can be seen. The default one can be seen. So to see that, we have to say kubectl get ns or namespaces. Here it is. Either you can also say kubectl get ns. Either one works. But you can see here, so some of the initial namespaces that will be generated with your cluster are these. What are those? Default. The first one is default and active 138 minutes ago. It has been created because that time it was created. The kops cluster has been created at that time. So all have been, these are the initial namespaces. Okay. So what is default? A default namespace in this Kubernetes includes this namespace so that you can start using your new cluster without first creating a namespace. That's what the default namespace. You don't need to create your own first namespace because the default is there for you. Then we have a kube node lease. This is the second initial namespace. A kube node lease. This namespace holds lease objects associated with each node. Node leases allow the kubelet. Kubelet is part of the working node. Okay, this node leases allow the kubelet to send heartbeats so that control plane can detect node failure. So this is how, okay, this is how your system, your control plane, your master node will check the health checkup from this using this namespace. And we have a third initial namespace that's called kube public. This namespace is readable by all clients, including those not authenticated. This namespace is mostly reserved for cluster usage in case that some resources should be visible and readable publicly throughout the whole cluster. So The public aspect of this namespace is only a convention, not a requirement. Then the fourth one is a kube system. A kube system, the namespace for objects created by Kubernetes system working with namespaces. So now we have seen initial namespaces. So we can create our own namespaces also, but before we create our own namespaces, we can also get the resources that are included in that namespace. For that, what I can do is I can also say we can show all the names in my default namespace. How can I do that? I can say kubectl, and when I say get all, by default it will bring all the resources names that are presented inside the default namespace. Okay, let me do that. You see that this is a default namespace. It's service forward slash Kubernetes by default. Okay, I did not create and you did not create and nobody else has created this. By default it was created, the name. And then type is cluster IP, and 142 minutes ago it's been born, and cluster IP is this. Okay, that's the default namespace. And we also can see all the resources from all the namespaces. If we want to do that, what we have to do is we have to say kubectl get all from all namespaces. Here it is. Oh, that's huge. Let me scroll up. Yeah, lot of there are 4 namespaces and there are a lot of resources in that. Okay, yep. As we have discussed earlier, let me get into this slide also. So default kube public, and or else let me make it smaller this time so that I can give a comparison. Yeah, I think this works. Yep, no, it's fine. So the last one we have is a kube system. Okay, so it begins with the kube system itself. The kube system. This is a kube system namespace, and inside that you have a lot of names. One is pod AWS Cloud Controller Manager. Then we have a node EBS Elastic etcd. You see that etcd manager that basically stores the key value pairs, and kops. You see that kops controller. Even kops controller is also part of this. So the kops, the kops instance that we have given now, so that is also part of this. It's part of kube system namespace. And kube API server, you see that kube API server is also part of this kube system namespace. And kube scheduler. So what I'll do is I'm going to show the exact picture of all those things so that it would be much clearer for you. Yeah, here it is. So I'm going to show you every component of this, every component, maximum every component. So this is our architecture, our cluster architecture. We have seen the API server, but now we're going to see again. So, yep. So kube scheduler, here it is, scheduler. So this is the pod, again a scheduler, kube scheduler pod. And kube proxy, I'm going to show it. The working node will consist of a kube proxies, and here is that kube proxy. How many kube proxies we have? 1, 2, 3, and this belongs to this kube proxy. Okay. Then we have kube controller manager. I'm going to show that also. Here it is. Controller manager. Then we have API server. Here it is. Here is that API server. Then kops controller. This is main kops controller. For that I have to get into EC2 instances, and here is that our kops. Okay. Then etcd manager, and that's here, etcd manager. Then we have other information also, but I hope I have shown you most of the things now. And that's our kube system namespace. These are the names that are present inside that kube system. Now another namespace is default namespace. Inside that we have only service Kubernetes, and then kube system with TCP, it has a service kube DNS. Then another name, kube system, it consists of AWS cloud controller manager and kops controller, and EBS. Yes, this is all about our namespace, that all namespaces and all the resources which are present inside that. So now if we want to see the resources from the specific namespace, only specific namespace we can give. For example, I want to see from the kube system, because we have seen, but again we'll see that here is that kube system. So for that, all I'm gonna do is kubectl get its svc and namespace n option, and that is kube system, and here it is. So specifically, a kube system namespace consists of kube DNS, a cluster IP with this one, and UDP, TCP, and one more protocol it's following. This 53 port, and 9153 port, and this is part of kube system namespace, and this is the name of that resource. Kube DNS is a resource, kube system is a namespace, and kube DNS is the name of that resource. Okay, so now let's look into the more. So we have viewed the namespaces using kubectl get namespace. Now we will create a new namespace. Let's do that, and then we will delete the new namespace. This exercises we are going to do. For that, again we have to get into our server, our kops. We are in kops instance. So clear the screen and make it bigger. It's fine, I guess. So now let's create our first namespace. So what I'm gonna say is, to create our first namespace, I'll say kubectl create ns, that's a namespace, and namespace, I'm gonna name of the namespace is kube first ns. This kube first namespace, that is the name of the namespace. Now let me click execute. That's it. The namespace kube first ns has been created. So now what we're going to do is, we will create a first pod, and then we will attach that pod. Pod itself is a resource, right? And this resource name we will be attaching with the kube first ns namespace. That's what is our activity. So activity is to create a nginx pod and attach this nginx pod resource with kube first ns namespace. Okay, done. So let's do that now. So let me create a pod, sample pod vim. The name I'm gonna give is pod1.ml. So let's start writing this. We'll begin with API, sorry, API version. It is v1. Then kind, what type of object you want to use. I'm gonna use pod capital P. Then metadata should be entered now. Metadata. So inside that metadata, okay, that's the issue here again. Okay, it doesn't work. So we'll face some issue with. I'm gonna open Visual Studio Code. Yeah, this somewhere. I'll create. This is my namespace directory. So here I'm gonna open Visual Studio Code and so pod1.ml. Okay, let's begin. So first one is API version. That's a v1. Then we have kind. Kind is pod. Okay, we got the sample. So I'm gonna keep this pod is fine. Okay, let me remove this first. Yeah, rest all is okay. So kind is pod. Then metadata name I'm gonna give nginx1. And labels I'm not going to use that labels now, because now we are dealing with the namespace, so I'm removing these labels. Then spec containers. So container, you bring the container, you run a container from nginx image. You run a container inside a nginx pod, and then image name I'm gonna give nginx latest. That would be fine. Nginx latest. Yes. And ports resources, let me remove this, it's not required at this moment. Yeah, one more. Yep. So ports. So container port I'm gonna take at 80. Okay, name is wrong because it's nginx1 that we have attached here. So name of the pod nginx. So spec containers and name image ports container port. I think this is the issue. Yeah. That's okay. Let's see. Okay. This is one more problem. Port 80. That's done. There is something wrong here. I think let's see. That's fine. Rest all is okay. So let me save this and copy this and come to our kops and paste it here. I hope it's fine. Let's see. Latest is also okay. Yep, it's done. Now we have mentioned that's our actual pod. So now in this pod we have to mention the namespace. We forgot to mention the namespace. Okay, let me mention that, or else we'll do that here only. Yeah, so namespace comes inside the metadata. after nginx1, yeah, here the namespace comes. Let's say namespace and the cube first ns, that's what the namespace, and wq, that's it. So our definition file to create our first name or to attach a resource to the namespace is ready. Now it's time to create the pod. So to create a pod, so we have to type kubectl and apply an F option, and the name of the file is pod1.aml. Let's execute it. Pod nginx1. The name of the resource is nginx1 is created. What type of object it is? It is pod type, because that's what the kind we have given there. So now let's fetch the pods from the cube first ns. Let's see what all there inside that. kubectl get pod and option n, that's a namespace, and after that we are going to give our namespace, that's a cube first ns. That's it. Your nginx is up and running. You see that it's running. There are no restarts, it's running. And again you can give kubectl get ns, and you should see your namespace here. Just 7 minutes ago we have created, and this is the namespace that I have created. You should also have created this namespace 7 minutes ago if you are following my video. So cube first ns, it's been done. Now it's time to delete the namespace. To delete the namespace, I can simply say kubectl and delete, and ns namespace is cube first ns. So namespace cube first ns has been deleted, and it's waiting for something else. We can see that it's deleted. Now let me give kubectl get ns. That's it. There is no cube first ns. The namespace has been deleted. Kubectl get node. Okay, so at this moment we have 3 nodes, and I will say pod no resources found in default namespace. Of course, we have specifically attached a namespace, and that namespace was deleted, so at this moment there are no pods. By default, when you say kubectl get pod, it will basically bring that pod, it will search for that pod inside the default namespace, not anywhere else. If you want to specifically get a pod from certain namespace, then you have to say kubectl get pod, pod, and then you have to mention the name and the namespace. So cube first ns, of course it's been deleted. It will say no resources found in cube first ns namespace. Of course there is no such namespace, also it's been deleted. But that's how it works. That's how basically you can create a clusters, or you can create a namespaces inside that. You can group your pods, group your resources into certain you can group your resources into certain sections. Okay, that's how you can isolate your resources using namespaces by grouping together. Now we are gonna look into the smallest deployable units of computing that you can create and manage in Kubernetes is a pod. This is very important unit of Kubernetes. A pod. A pod is a group of one or more containers with shared storage and network resources and a specification of how to run the containers. A pod's contents are always co-located and co-scheduled and run in a shared context. A pod models an application-specific logical host. It contains one or more application containers which are relatively tightly coupled. In non-cloud contexts, applications executed on the same physical or virtual machines are analogous to cloud applications. So analogs to cloud applications executed on the same logical host, as well as application containers. A pod can contain init containers that run during pod startup. You can also inject ephemeral containers for debugging if your cluster offers this. So then the question arises, what actually is a pod? The shared context of a pod is a set of Linux namespaces, C groups, and potentially other facets of isolation. The same things that isolate a container. So within a pod's context, the individual applications may have further sub-isolations applied. A pod is similar to a set of containers with a shared namespaces and shared file system volumes. So while Kubernetes supports more container runtimes than just Docker, however, Docker is the most commonly known runtime and it helps to describe pods using some terminology from Docker. So now how to run a pod? That's the question. How to run a pod? We have run a one pod. So I'll show that. Sudo option I think the namespace that we have used, that we have cleared off. I think kubectl get pod. Yeah, no resources found in default namespace because that we have removed. So now we are going to create a new pod, but before that, let's get into the concept. How can we create a pod? There are two ways. One is imperative. Second one is definition file. So the following is an example of a pod which consists of a container running the image nginx 1.14.2. You see that? So this contains four sections. This is called a definition file. This is called a definition file. So this contains four sections. First one is API version. Then what kind of object it is? It's a pod. Then in metadata, the name we have given is nginx. Then spec containers. Inside the spec, we have mentioned the container runtime engine should come into the action. Then the name of the container is nginx. and image name is going to pull nginx 1.14.2 and ports should be container port 80. Let's do this first and then we will move for the next concept. Okay, let's do this first. And first we will write a definition file for this. Okay, but before that let me do it in first pod.yaml. Okay, so let's write our first definition file for pod. So the first one, as usual, the first section of this, the first object of this YAML file is this definition file is API version. It's v1. Then as usual, what type it is, kind, I will go with pod because we are dealing with pod. So once you give the pod, you will get the information, a definition, sample definition file of pod. So let me take that. So now we have to attach a metadata section. Metadata is nothing but a data about the pod. Okay, so in this, the name I'm gonna give is first pod. Labels, I don't want labels at this moment. I will remove the labels. Then spec containers. So name of the container, I'll give nginx. Then image. So image, I'll get it from my account. Let me get back to the repositories, and here you should find sked nginx. I have to find nginx. Yeah, here nginx. We have how many versions? Only one. So let me copy this, paste it here. So the name of the image is this. Okay, then now resources I don't want at this moment. Let me remove this, and we have ports, and container port is, I want to map it with 80. I think rest all fine. I think no problem. So it's okay. Containers is fine. Name, image, ports. So total major sections are API version, and then kind, metadata, and spec. So now let me save this, and let me copy this. So here I'm gonna create a directory mkdir defs ls cd defs and mkdir. Okay, mkdir first pod cd first pod, and inside I'm gonna write first pod dot yaml. So here I'm gonna paste. So this is our first definition file. I'll save it. I think everything is fine, and now so it's done. Now let's get back to our slide. So the definition file with 4 sections has been written, but in spite of nginx 1.14.2, I have gone with the nginx v1 from my account, my Docker Hub account. So then it's time to create a pod using kubectl apply option F. Okay, let's do that. Let's create that. So kubectl, apply, option F. So first pod ml, that's it. The pod, basically the first pod has been created. The name of the pod is first pod, and let me check. Kubectl get pod, here it is. First pod running, it's up and running, so the container is up and running. So you can check get, sorry, kubectl get ns and default get so a first pod is up and running. So now let's get back to the slide. Okay, that's what the pod, and that's how we write a definition file, and that's how we create our first pod. Now we have a workload resources for managing pods. Usually you don't need to create pods directly, even singleton pods. Instead, create them using workload resources such as deployment or job. If your pods need to track state, consider the stateful set a resource. Pods in Kubernetes cluster are used mainly in two types, mainly in two ways. So pods in Kubernetes are used in two main ways. One is pods that run a container, the one container per pod. Pods that run a single container is the first way. So this pod takes one container, that's it. So one container per model is the most common Kubernetes use case. In this case, you can think of a pod as a wrapper around a single container. So Kubernetes manage pods rather than managing the containers directly. Then the second way is pods that run multiple containers that need to work together. So a pod can encapsulate an application composed of multiple co-located containers that are tightly coupled and need to share resources. These co-located containers form a single cohesive unit of service. For example, one container serving data stored in a shared volume to the public, while a separate sidecar container refreshes or updates those files. The pod wraps these containers, storage resources, and an ephemeral network identity together as a single unit. So each pod is meant to run a single instance of a given application. If you want to scale your application horizontally, scaling your application horizontally means to provide more overall resources by running more instances. So you should use multiple pods, one for each instance. In Kubernetes, this is typically referred to as replication. Replicated pods are usually created and managed as a group by a workload resource and its controller. So then let's see how to manage these pods, how these pods manage multiple containers. the pods that we have seen so far can manage multiple containers, but how do they do that? So pods are designed to support multiple cooperating processes. Processes in this, obviously, as we have discussed in Docker image, a Docker image is a heavyweight one which consists of all the files, all the data. Sorry. Whereas a container is a just process which is running, which is a container is a process which is running from the image that we have built. So that's why I say pods are designed to run multiple cooperating processes. Processes means a container that form a cohesive unit of service. And the containers in a pod are automatically co-located and co-scheduled on the same physical or virtual machine in the cluster. So the containers can share resources and dependencies, communicate with one another, and coordinate when and how they are terminated. So let's take one example. So a container that acts as a web server. So this is our web server. A consumer fetches data from this web server. A consumer sends a request and gets a response from this web server. Then we will have a pod. This is a pod. We will have a one more container inside the pod, which is for a shared volume. This container is for files, to store a files in a shared volume. Then we will have a separate sidecar container that updates those files from a remote source, as in the following diagram that you see on your screen. Now, some pods have init containers as well as app containers. So init containers run and complete before the app containers are started. If you look into this example, so we have a web server, and web server should be connected with a volumes container so that the volume container can store all the respective data and provide that data to the web server. And whereas we have a file puller, so file puller is our content manager. So now a file puller is like a sidecar. So now a sidecar container, this updates those files from a remote source, as in the following diagram. So the sidecar updates the files into the volume, and then once the volume has enough files and some consumer, if he requests for certain files, then web server asks the volumes to respond with that file. Then the file will be given to the web server, and inside that web server it will be visible for a consumer. So here total 3 containers are running, and they'll be running in coordination with each other so that they can serve the consumer. That's the output. This is how a pods manage multiple containers. However, web server is the main container, volume is the shared volume container, whereas file puller is the sidecar container, and sometimes you can have an init container too. So pods natively provide 2 kinds of shared resources for their constituent containers, that is networking and storage. So then let's look into various pods and controllers. So now let's look into the pods and controllers. You can use workload resources to create and manage multiple pods for you. A controller for the resource handles a replication and rollout and automatic healing in case of pod failure. For example, If a node fails, a controller notices that pods on that node have stopped working and creates a replacement pod. The scheduler places the replacement pod onto a healthy node. So here are some examples of workload resources that manage one or more pods. The first one is deployment, second one is stateful set, and third one is daemon set. So let's look into the pod templates. So controllers, we'll begin with the controllers. Controllers for workload resource create pods from a pod template and manage those pods on your behalf. So pod templates are specifications for creating pods and are included in workload resources such as deployment, jobs, daemon sets. Each controller for workload resources use the pod template inside the workload object to make actual pods. So the pod template is part of the desired state of whatever workload resource you use to run your app. So let's see the sample. Let's see some of the samples of these definition files. So this is the first one. This is a job type object. You have an API version. For this we have to use API version batch v1, and kind is job. Metadata name of this job is hello. Spec template, this is the pod template. Spec again container name. So basically busybox 1.28 we are bringing, and command, this is what we are executing, and it will come and say hello Kubernetes and sleep again. Restart policy on failure. So that's the pod templates ends here. Okay, this is one. This is a job type. So let's build. Let's create a definition file for this. So let me get into the VS Code and type job.yaml definition file. So API version. So I'll go with the batch v1. So then kind. This is job. Yes, we got it. So let me remove the top one because we got that. Yeah. So API version batch metadata name first job, then spec it's not required, so let me remove this. I'll go with the template, and inside the template I'm gonna attach a command if it's required. This is the pod template. This is the pod template. Then spec, it's a container, so I'm gonna use a pi, or here I'll say array. Then image, I'm gonna take busybox 1.28. Command, in spite of parallel, I'll say sh shell as an command, and after that option C, then echo. What I want to echo is echo Hare Krishna Kubernetes and sleep. $3,006. Okay. Okay. Restart policy on failure. On failure, rest all is fine. Or else I'll remove this. It's not required and sleep 3600. Yeah, this would be better. It's all fine. So let me save this. Copy this. And get into and sudo option I, clear the screen, ls cd defs ls mkdir job def and cd job def vim. This is job def dot ml and paste it here. Okay. So that's it. Let me save this and quit it and say kubectl apply option F jobdef.ml. So the job def is invalid, spec.template containers name invalid, array lowercase. Okay, got it. That's the mistake. It is absolutely wrong. So we missed it. Spec. The problem is with spec. Yeah. That's it. The job.batch first job has been created. And here is that. This is our first pod and this is our second pod. So it's been executed and the status is completed. It's not running because it has to come. It has to start and print a message and die. That's what it's gonna do. Clear? Yeah, that's what a job. And the following is an example of deployment. It creates a replica set to bring up 3 Nginx pods. Let's see that. So deployment, and this is a deployment object, and this is going to bring 3 replicas, basically 3 replicas of that. All are of Nginx. Let's quickly do this. def.ml API or kind. Yes, we got it. And let me remove this. It's not no more. It's not required. API version, fantastic, kind, deployment, metadata, name. I'm gonna go with Nginx deployment. Nginx deployment. Then specs selector is not required. Match labels, replicas, we'll put the replicas before that. Yeah, replicas, how many? 3. That's it. Rest all selector match labels I'm gonna with Nginx only. Then template metadata labels app, I'll say Nginx. Then spec containers, I'm gonna push my Nginx image. That is, I'll get into that. Yeah, is this the one? Yes, this. Let me copy this and paste it here. Let me, yeah, fine. Resources is not required at this moment. I will remove this. And image ports container port 80. That's it. Rest all absolutely fine. Let's save this, copy it, get into our machine, cd mkdir, and after the mkdir, let me give the name of the directory here. I would say this is dep def cd dep and enter vim def.aml and paste it. That's it. It's time to run kubectl, apply option F dep.aml. So deployment.apps, it's not just pod, deployment.apps has been done. So the name is nginx dep. So created, let me see that. kubectl get pod. Here are the 3, all are up and running. You see that? The magic of the deployment object, you see that? All 3 are up and running. Then we can describe a daemon set in YAML file. For example, the daemon set YAML file below describes a daemon set that runs the flaunted Elasticsearch Docker image. So this we're gonna do in our further slides, but for now you have seen 2 types. One is job type, second one is deployment type, and last one is daemon set type. So next we will look into the storage building blocks. So before that we will also see service here, and a service uses a selector to define a logical group of pods and define a policy to access such logical groups. Because pods are not durable, the actual pods that are running may change. A client that uses one or more containers within a pod should not need to be aware of which specific pod it works with, especially if there are several pods or replicas. So there are several types of services in Kubernetes, including cluster IP, node port, load balancer. A cluster IP service exposes pods to connections from inside the cluster, whereas a node port service exposes pods to external traffic by forwarding traffic from a port on each node of the cluster to the container port, whereas a load balancer service also exposes pods to external traffic as node port service does. However, it also provides a load balancer. So then we will look into the volumes. Volume, a container file system is ephemeral. If a container crashes, the changes to its file system are lost. So volume is defined at the pod level and is used to preserve data across container crashes. So volume can be also used to share data between containers in a pod. A volume has the same life cycle as the pod that encloses it. When a pod is deleted, the volume is deleted as well. So Kubernetes support different volume types which are implemented as plugins. So basically there are two types. One is persistent volume and second one is a persistent volume claim. So all these things, this service, volume, deployment, all these objects, we are gonna look into these objects in deep. Okay, in our further forthcoming slides. For now, we will seriously jump into the pods. So let's get into our kops machine. Now let me say kubectl get nodes, and here you can see 3 nodes are up and running at this moment. One is control plane and second one is remaining 2 are working nodes. So now to fetch the information about the specific node, we are talking about nodes, not the pods. To fetch the information about the specific node, say for example a working node, so we have to give kubectl describe and then node name is this. I'm going to give this, and let's say that's it. You got the lot of information, huh? Fantastic. Yeah, it's too much information. Let's go through it one by one. Let's scroll up a bit, reach command stage. Yeah, we got that. So here where we have described, this is a working node. You can see that name of the node, and then what is the role? Role is node. It's a working node and it has a lot of labels, and US West 2A, you can see that that's one of the label, and topology, annotations, timestamp, and here you can find out some more information. That's memory pressure, disk pressure, PID pressure, and addresses. You can find addresses, internal IP. This is what the internal IP of the node. This is external IP of the node. This is a private and this is public. And internal DNS. See this one, domain naming system, and then host name. Basically, the complete host name is this. Either you can use till here, and or else you can use complete host name to fetch or to get the information about that node. And external DNS, if you want to attach it using external DNS. So this is what the address of this one. So capacity 2 CPU and ports 110 it can take, maximum ports it can take 110, and memory is also given in kilobytes. And ephemeral storage, let me scroll up, I completely came down. Yeah, so machine ID, system UID, boot ID, kernel version also you got it, and then voice image that we have used is Ubuntu, you can see that, and operating system is Linux, architecture AMD 64, and kubelet version is v1.2 and kube proxy. So that's the lot of information you can find out from here. In addition to that, you can find out some of the CPU limits, memory requests, and CPU requests. And if I scroll down completely, say CPU and memory, you can find out events. At this moment there are no events, none events. Okay, so now this is pretty complex to understand, so pretty complicated to understand. So that's why what I'm gonna do is I'm gonna fetch the similar information in AML format. Let's do that. So let me go up, use the same command, attach option wo, and say AML. Okay, kubectl describe node and option O YAML. I think this option has been deprecated. That's okay, but that's how you basically convert this into the YAML format. So then let's create a pod which basically runs an application. That's a Wipro app. So let me clear that, and meanwhile you can find out the way to do this. Okay. Now for that, I'll get back ls. So I'm in defs. So here I'm gonna create a directory which says the name of that is mkdir viprod. So vipropod, that's what, and cd vipropod, and inside no file. So now I'm going to create a file, vim vipropod.ml. So let me keep it. In spite of typing here, I'm going to do the same here. So I'll create vipropod.ml. As usual, kind. This is a pod. Yeah, I got it. I got the pod. So kind. Now let me remove this first. Yeah, everything is fine. API version v1, kind pod, metadata name I'm gonna give is Wipro app, and labels is I'll give Wipro app again. Yeah, spec a container name is app container, and image I'll take from my organization, my Docker Hub organization. So let me click on here and click on repositories, and I'll find vprofile Charan. This is what I want. So let me click on this and take the see all tag and copy this and put it here. Yeah, it's all fine. Yeah, yes, it's done. So now resources is not required at this moment. So I'll remove this. Okay. Then we have ports. So port, I will attach the name for the port. So it's a name Wipro app port, and the container port, I'll remove this. Yeah, that's fine. And the port, I'm gonna give this time 8080. I hope everything is fine, no issue at all, no red mark. Let me save this, let me copy this, and let me paste it here. That's okay. Get back to VS Code, copy everything and paste everything. That's it. Save to WQ. Now it's time to run or create our pod. So for that, kubectl create f option and wipro pod.ml. Execute. That's it. Wipro app has been created. So now let's see what's the status of the pod. So kubectl get pod, Here it is, Wipro app. It's successfully up and running. You see that? One is ready and one is running. Now it's running. It's up and running. It's not dead. It's up and running. You can see that. Now let's just describe the Wipro app and we'll see. Just see the what's happening inside and what's the content is there. How exactly looks like this pod. Okay. We will look into the pod. We have seen it. We have gone into the container. We have gone into the image. Now we are going to enter inside the pod. So kubectl describe pod and the name of the pod is Wipro app. Wipro app. Yeah, Wipro app. Correct? Yeah. So this is our pod Wipro app. Let me scroll up and let's look into this one more time. The most important information for us here is required the IP. We'll begin from top. Namespace is default. You see that we have discussed in namespace. If you do not specifically attach a namespace while creating your pod, it will take a default namespace. This is the default namespace and Wipro app. Priority. So node, it's been created in this node. Okay, let me check. Which node is that? Copy this. Put it in sticky note. This is nodes object and let me paste it here. Now let's get into our instances and bring up node 463. Here it is, the bottom one. This is in this node, basically node. It is in best US West 2B. So in working node, in this node, it has deployed that pod. So I'll show you this one more time. I'll take you back to our picture and I'll show it to you so that it will be much clearer. Yeah, here it is, the diagram. Now I'll show you that. So what we are experiencing at this moment is a pod in working node. A pod in a working node. I'll show you in both places. Here you can see that. So this is our pod which is in this node. And inside that inside that pod, this is your container. This app container is running. You can see that all practically you can see. And inside that container, this container is spun from this image docker.io vprofile charan. Okay, from my image. See, vprofile charan, vprofile v1 tag. Now here it's everything is clear. I'm gonna show you one more time. This is the working node. Inside the working node, you have a Docker and you have a pod. Inside the pod, you have a container. I'll show you that exactly. First, I will show the working node. This is our working node, which is just an EC2 instance. Now, inside this EC2 instance, you have inside this node, that's our node EC2 instance. Inside that, you have a container. The IP of the container IP is that. And inside that container, this container consists of this container is spun from this image and image ID and the port 8080. This has been exposed. The app has been exposed to the 8080 and then host port not yet mapped 0 and state is running. That's how it works. You see that? A node, a pod, a container. Everything you should be able to see here. I hope it's brilliant for you too. Then you have a mounts where run secret Kubernetes dot. These are mounts attached and conditions. Then volumes, a kube API access and more information, download API and events. This is what the final one, events. As our pod is up and running, so these are the events. So the normal scheduled, okay, it's been scheduled. The first, it has started with this one 76 seconds when you said create a pod. That time first the scheduler has come into the picture. Let me show you that. Don't worry, everything I will show you. This is our scheduler. Okay, the scheduler first came into the action 76 seconds ago. It has came into the action. That's default scheduler. And what it has done, successfully assigned default Wipro. Just a minute. Yeah, it successfully assigned default VPR. Okay, the scheduler. Then after that, we have pulling. The next event is pulling. For that, the kubelet has come into the picture, because where will be the kubelet? Kubelet will be inside the working node. So here the kubelet, the scheduler through API, it has communicated with the kubelet, and then kubelet is in, the kubelet has swung into action. Now the kubelet has started pulling the image. The kubelet started pulling the image. That is successfully, then kubelet successfully pulled the image. That's a v profile Charan v profile app v1. That's been done. So then created, who has done? Again kubelet. Started, who has done? Again kubelet, because it all happening inside the node, a working node. Whereas the first one, the scheduler, has took the initiative from the master node or control plane. Remaining all activities are done by the kubelet. That's what this image conveys. Your scheduler through API server communicate to the kubelet. That's it. Your work is over. Then the kubelet swings into the action, and remaining all activities will be done the kubelet using the containered or container engine, or runtime container engine. Now let's get back to the action now. That's enough. Too much explanation. So that's how Wipro. So that's how the pods will be used, and that's how we create a pod, and that's how we describe the pod. So let's meet in another object. So now let's look into the more complex concept of a pod. So let's imagine, if you face some issues, some problems during working with pods, how do you handle it? So that's the question. Basically, when it comes to Docker, so you have a Docker logs, you have Docker inspect, and you have Docker exec. Using these commands, we are gonna troubleshoot the image and container both, and we will find out the problem. So where is the problem? And then we solve the problem, and we'll again rebuild the image, or rerun the container. So that's what we will do. But how do you handle the problems which are inside the container, inside the pod? How will you troubleshoot the problems that you get with the pods? So that's what we are gonna look in this session. So basically, fault finding, troubleshooting. So we have to find out the faults. So let's get into the instance or kops machine. So let me do kubectl get pod. Sorry. And here you should see some problem. Nginx, dep, all three are absolutely fine. This is our deployment. It's working fine still. Wipro app working absolutely fine. A first pod also working, completed. But Nginx F is image pull back off. So basically, it's not spinning. It's neither completed nor running. So that means there is something wrong. There is something wrong. You see that 0 by 1. So how do you find out that? What's the issue there? What should I do now? How should I proceed? There are a lot of questions, but only one answer. That is fault finding. Let's do that. Let's swing into action now. So I'm gonna say kubectl pod option wo and wide. I'm gonna get more information about that. So instead of using describe, as I just said this. So now I got this 5, out of which, so I'm gonna get information about each and every one. So out of that, you see that nginx f. So node, you can see the nodes also. So Wipro app is in node 2, and then nginx is in node 2, and these are all, and one more is in node. So few are distributed into node 1, few are distributed into node 2, and whereas nginx f is in node 2. No, node 1. Nginx f is in node 1. The issue is clearly mentioning that is image pull back off 2 minutes before. So, and here the IP of the container is also presented. So now let's put this into AML format. So let me specifically call kubectl get pod and specifically mention the name of the container, sorry, name of the pod, that is nginx f, and rest remains same, option wo aml. That's it. You got the complete information in AML format. I think in our previous in our previous video, that in pods section, I forgot to put maybe I forgot to mention the pod name. So that's the reason it was not showing. You just mention it because I was in hurry to close that because that video has become too long. So that's the reason I was in hurry to close without addressing the problem. So now I'm addressing the same issue. Okay. So here is the complete information about our pod, the one which has failed. Let's go into that and let's look into each and every, yeah, yes, here from here it started. API version metadata is no issue. Here we want no problem. So let's get into the containers image. Yeah, here. So image is this. Image pull policy if not present. Name nginx. Container port and mount path, and there are a lot of more information. Tolerant, tolerations, no execute, config map, service token, status. Here you could see the status. Containers not ready, containers with unready status, nginx. So the problem, last prop full. Okay, okay, there is something, and then status is false. Okay, this is the image, container statuses. That's okay. It started is false again. It hasn't been started. So name is nginx. The problem is very clear here. You see the state. Sorry. So the state is waiting. It's waiting. Okay. Message is back off. Pulling image. Okay. You see that? Image name. Image name. Okay. Reason image pulled back. Host IP pending. Okay. That's the issue. I got the issue. I got the issue. So now let's do kubectl describe also. Another command that we can use to fault for the fault finding. So kubectl describe pod. It's nginx f. Here, let's look into that. Here we may get more information, I guess. Yeah, state reason is clear. This is the container information. You see that container information. So image is this. State, the problem is it's not ready. Let's get down and see here. Volumes and events. Let's get into the events. This would be far better. This will give you more information for the fault finding. So normal scheduled as usual, 7 minutes 5 seconds. Default scheduler successfully assigned. The work has been successfully assigned to the kubelet. Now kubelet has come into the picture and it started pulling. So pulling image cube Charan Nginx v1 got failed. While it's pulling the image, it's got failed. Yes, that's the issue. That's the issue. Okay, okay, okay. Exact issue is this. So while pulling the image, it got failed. Failed. That means there is something wrong with the image only. Okay, let's look into that. So warning failed. So kubelet failed to pull image. So code unknown failed to pull and unpack image. That means it's the problem is here only. So failed to resolve reference. Yes. The problem either it could be the image is not there or maybe pull access denied. The pull access denied or repository itself does not exist. Oh, either of this. The problem either a pull access denied or repository does not exist. Either of this could be the problem. Okay, or may require authentication, authorization. So this is where you got the actual solution for your problem. Either of this. Okay, we have to find out that. Now error image pull. Okay, rest all fine. Okay, but so now let's look into that. Basically, let's look into the definition file and we'll see what's the issue. So ls vim. Okay, let's do the vim. Yeah. Okay, these are all fine. There is no issue. Containers only the problem with image. Either this repository should not be existed or authentication problem. So now let me get into my repository and we'll see. So these are repositories. Whether I have this repository or not. First I am going to see that. Nginx, Nginx, Nginx. Where are you? Where are you, Nginx? Yeah, here are you. Yeah. So I have that. But okay, let me copy this. Oh, got it. The name, the repository name, there is some issue. Yeah, it is cube charan. It's not charan. It's not charan. It's a charan. So I got the problem. You see that? I'll paste it here so that it will be clear for you also. Yeah, this is what the image name. Image name is cube charan and nginx v1. Rest all fine. A is missing. So let's do that now. Let's put it. Let's fix it. We found the problem. Now it's time to fix it. Yes, here it is. Here is the problem. Brilliant. Now let's fix this. Now let me save this W and Q. So now I will rerun it. kubectl, apply, option F, and faultydef.ml. That's it. Pod nginx f configured. Configured. It's not recreated. It's configured. Now let me see. kubectl get pod. And this time it's up and running. It hasn't created a new pod. The existing pod has been solved. This is how you repair the faulty pods. This is how you find the faults. This is how you troubleshoot. Now it's time to deep dive into Kubernetes object service. Service, if you want to expose your pod, the application running in the pod as a network service, like you want to host Nginx or a Tomcat or any front end or even for the back end, you need to use service with your pod. Then a service is similar to load balancers, like what a load balancer does. ELB, Elastic Load Balancer in AWS. Same service will be doing for the pod. So for the starters, it's really not so difficult to understand. Just like a load balancer, and you want to expose your pod communicating with each other, you need a service in front of your pod. A service is abstract way of to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. So then the question arises, so why was really a service created? So why do we need a service altogether? If we don't use service, is it not possible to run our pods, run our application using Kubernetes? So actually the issue is Kubernetes pods are created and destroyed to match the desired state of your cluster. Yes, correct or not? Yes. So pods are non-permanent resources. This is the pain point. If you use a deployment to run your app, it can create and destroy pods dynamically. Each pod gets its own IP address. However, in a deployment, the sets of pods running in one moment in time could be different from the sets of pods running that application a moment later. So this leads to a problem if some set of pods, let's take an example, backend pods provides functionality to other pods. Let's take them as a front end pods inside your cluster. How do the front ends find out and keep track of which IP address to connect to, so that the front end can use the back end part of the workload? So if there is no proper connection, if continuously the back end is changing the pod, changing its address inside the cluster, then how can the front end can catch up, can bring them, can connect with the back end to show the required features and functionality on web application UI? Of course, it's difficult, it's impossible. That's where the service comes into the picture. The service comes into the picture and it makes a proper connection between back end and front end. A solid connection it will make. That's the main reason to have a service. So in Kubernetes, we have three types of services. The first one is node port. A node port which is similar to port mapping. Node port is nothing but, it's not just similar, it's almost equivalent to port mapping. So we have seen in a Docker a host port you pick up and you map it with the container port. Yes or no? We have done it. We have done it 15-20 times during each and every exercise of Docker. Kindly go back to the Docker module and watch it. So node port exposes the service on each node's IP at a static port. Basically, we call it as a node port. To make the node port available, Kubernetes set up a cluster IP address the same as if you had requested a service of type cluster IP. So it's exactly the same way, and mostly it's exactly the same way as the port mapping of the Docker container. So, and mostly it's for a non-prod purpose, not for production. So, this node port mapping node port service will not be used for the production purpose. So, not for exposing the front end to the production, and only this is to expose your pod to the outside network. That's it. This is limited, and node port is only limited, so it's impossible for you to expose. For example, you have two pods, one is front end pod, other one is back end pod. So it is difficult for you to expose the back end pod to the front end pod it's difficult. With node port, the only thing that's possible is you can uh, expose the front end pod to the front end pod to the external network or outside network. That's why you can use a node port only for exposing your pods to the external network. Then you may ask, how can I expose internally one pod to other pod? So for that we have few more services. The second one that we have is a cluster IP. If you don't want to expose it to outside network but internal, like Tomcat connecting to MySQL. So for MySQL you need a static endpoint. So you can create a service of type cluster IP. So cluster IP exposes the service on a cluster internal IP. So choosing this value makes the service only reachable from within the cluster. Within the cluster, the problem that we have discussed during the node port service has been solved using the cluster IP. So this is the default that is used if you do not explicitly specify a type for a service. So you can expose the service to the public with an ingress or the gateway API. That's if you want to expose this to the external outside network, then you can use either ingress or the gateway API object. But however, we are not worried about that. So cluster IP for internal communication. So here there will be no port mapped to your node internal communication. Then the third service that we have is a load balancer. It will do both. So third one you have is a load balancer. It exposes the service externally using a cloud provider's load balancer. It's gonna connect with cloud provider's load balancer. So this is again to expose to the outside network for production use cases. It's basically widely used. Load balancers are widely used for the production use cases. So we are running a Tomcat pod and I want users from the internet to access that. I want consumers and users from the internet to access that. For that, I will create the service of type load balancer, and on AWS, it's going to create actually an elastic load balancer and map my pod to it. So then we will look into the services object high level architecture. So every pod or a cluster of pod that are running, you need a service in front of that. If it is a network, if it is providing a network service, okay, like a front end, we will have a service for backend. Example, RabbitMQ, Elastic Cache. You will have again a service in front of it, and MySQL you will have a service in front of it. Everywhere you see that service here, service here, service here, and service even for the MySQL database. So that's how the communication happens between pods and between user to the pods. So first we will understand the service of type node port. This is specifically about node port. So node port architecture. So let me change this. It's to node port. And so let's say you have two pods running inside a single cluster. This is our the yellow color one. This is our node port. Sorry, this is our node. This is our node. That means one EC2 instance. Inside that, two pods are running. Pod 1 and pod 2 are running. So you have two pods running over here. So pod will have label and pod will have an IP address, and of course container running inside that will also have an IP address. So the Nginx container is running on both the pods, one container per pod, uh, and it's exposed on port 80, that's 80. So okay, so pod has an IP address and a port number to access it, and has a label too. So now service will be like a load balancer, as I said, in front of it. In front of it, so service will have a static IP address. Okay, so this is our service. The service will have a static IP address which will not change until unless you don't delete it. That's the benefit. So this is not dynamic, it's a static address. So the service will have a static address. So it will have a front end port, like a load balancer has a front end port. So you see that this is the backend port. You have a front end port, and this port will be mapped with the port of this Nginx pod. And similarly, the port of this service will be mapped with the port of the Nginx pod. And similarly, you have a port mapping. This is external port mapping, and this is node port of the node. Okay. Then we have, this is the internal front end port. This is internal front end port, and we have here the it's for internal communication. The internal front end port is for internal communication, and it has a back end port. Back end port, that is back end port will be the port number of container, obviously. Okay, service like a load balancer has a front end port and back end port, but how does it know which port it has to route the request to? So there could be hundreds of ports running like this. Well, it's going to match the label selector. It's going to use a label selector. This is what you see, that label selector. Using label selector, it's going to find out that pod. It's going to use a label selector to find out the port, and then port mapping also will be done. So this port will be mapped to this port, and then how would that find out that pod? Using the label selector. Now, so we give a label name, any pod that has the label app front end, any pod is going to forward the request to that pod 80. So now I have two pod, it run exactly. Now, okay, this is internal. When you say node port, you have to mention a node port number. Say, let's say 30,000. This is a 30,000, and so a node port, this is a host port. 30,000 will be mapped to your service. When you access the node by giving its IP address and the node port, the request will forward to the service. The service is going to forward the request to the pod. Pod will send it to the container, and the same way it comes back. If there are multiple ports over here, the similar thing. This is our the IP and node port IP. This is a node IP, and this is node port. when you call a node IP with the port, this will be connected, this will be communicated with it will be communicated with the internal port 80, and then that will be connected with the port of pod, and pod will connect with the port of nginx using IP as well as ports. So that's what the node port is. So now let's look into the one example here. So let's defining a service first. For example, suppose you have a set of pods where each listens on TCP ports 9376 and containers a label. So this is how it looks. So basically a service definition file looks like this. You see that? In Kubernetes, a service is an abstraction which defines a logical set of pods and a policy by which to access them. So the set of pods targeted by a service is usually determined by a selector, that you can see that which pod you want to target is determined by the selector. So for example, consider a stateless this one image, and here the selector has targeted specifically this pod. Then obviously when you run this service, when you create this service with the port mapping will be done to the this pod. And another example, so it consists of API version kind in addition to that metadata, whereas in spec the most important is selector, and then in ports you have to mention this protocol as a TCP, and then port name either you can directly give 80 or you can mention the port of target port is the one which should be mapped properly. The target port either you can give it a port ID port directly, or you can give the port name also if it is mentioned in the pod. So here this is a service. On other side you can see the pod. So pod definitions in pod have names, and you can reference these names in the target pod attribute of a service. For example, we can bind the target port to the service to the pod port in the following. Let's see that example. Now you see that this is the pod. So pod kind nginx labels. Label is important. Then spec, and in ports we have mentioned the port, container port and 80. So the name of the port we have given as HTTP web SVC. So now in spite of mentioning the target port as 9376, what I can do is I can directly give the name of the target port of the pod. So the pod has to be targeted. The pod selector has to be mentioned here. And you see that selector, that's a proxy. So these are the main important points to be taken care before you run a service. Run service to service is pretty simple. It's just compare, just take the analogy of any web application deployment. You will have a web app, your app, okay, an application. To run that application, we are using either HTTP or Apache 2 or Nginx or any other kind of service. Yes or no? Similarly, what that service makes? The service makes the communication possible with the external or outside network through internet using browser. Similarly, here the service is one object that we are going to create, but this object what it's going to do is our pod is equivalent to our application. Now this object, this service object will make sure the communication possible between external network as well as internal network. If it is a node port, it is only for the external network communication, whereas internal, where if it is a other cluster IP, it's for internal. If it is a load balancer, you can manage both. So that's how a service object basically makes our pod to externally access through internet or browser. So first let's do this example. Service object, the node port service, and here we are gonna do node port service. This example we are going to take. Okay, so for this, I think it's time to get into the action. It's pretty simple. So here we will have a pod. The pod could be in any node. It could be in working node 1 or working node 2, it doesn't matter. Whereas the service that we are going to create can be in any node. It could be the service can also be in master node. It will be across all the nodes. So master node, working node, and this. So when we create a master node and when we check the master node, we should able to find the endpoint where that endpoint is connected with this pod. So now it is, if the service is properly connected with the pod, then we can directly go to the browser. Using the IP of that service, we should able to access the using the IP of any node. It could be master node or working node, or master node or working node, because service exists across all the nodes. So that's the reason any of your from any of your node you should be able to access the service, and then your pod, and then through your pod your application. I think I hope you got it. So let's do the exercise so that it will be much clearer. So now it's time to get into the example. So it's node port architecture example demonstration. So let me get into our kops. Sudo option I, clear the screen. So let's do ls cd defs. So now I'm going to create svc mk dir svc defs. So cd svc defs. Inside that, I'm gonna create one more directory, that is mkdir. So first service we are going to explore is node port svc, cd node port svc. So here we are gonna create our pod first, then after the pod we are going to create a service. So let me do vim. Okay, but first, before that, let me get the pods. So get kubectl get pod. I think our vpro app is up and running. So let me clear the screen and say vim. It's a vpro app dot vpro pod dot aml. So let me, basically we have that file ready. So this is what the one we have used. So let me copy this. We have used it uh, so far so many times, so that's why I'm using the same. So I don't need to explain again. So that's it. Then now it's time to create the service. Anyway, that pod itself is running, so we don't need to touch. Now service. So for service, vim vipro app, this is node port dot aml. Let's create that service. We'll create the service first, and here I'm gonna say Wipro app node port dot ml kind, it's a service. Okay, API version v1 kind service. Yes, we got the sample file, so let me remove this. Yeah, rest all fine. So kind is service metadata. So name, I'm gonna say name of this is hello world service. That's the first one, so we have named it like that. And spec, so what will we do is, this is ports, will keep that. Selector is not required in this. Ports, and inside the port directly I'll mention 8090, and the target port well, okay, before that let me mention the node port. Its node port is 30,000, right? Yes, 30,000. Then we have the target port. So I think port name that we have given there is Wipro. Let me cross check. It's a Wipro. Yeah, it's Wipro app port. So Wipro app port. Wipro app port. And protocol. The selector we have removed. We should not remove the selector. Okay, we will attach the selector again, or we'll attach the selector at the bottom. No issue at all. Or else we'll attach the selector here itself. Yeah, selector app. It's a Wipro app. Then type I'm gonna give node port. Everything is absolutely fine, no issue at all. Okay, so let's copy this and paste it here. That's it. Let me do WQ. So our service definition file is ready. So now let's compare both the files. So cat wipro pod.ml and let me check cat wipro app node.ml. Yeah, let's check. So name is fine, that's anyway specific to this. And selector, let's check that selector what I'm selecting, Wipro app. Is the name is same, app Wipro app, absolutely fine. See, name is Wipro app, even the label is also Wipro app, the labels tag that we have mentioned here. So one more thing that I just want to say, like if you want to know, here inside the file these are all dictionaries and this is a list, and again this port item is also list. Okay, now the selector is absolutely fine, no issue at all. Then type is node port type, because we are working with node port type service. Then port mapping 8090, inside, and node port, the port of the node is 30,000. Let me show the picture first. You see that? Not this one. Yeah, this one. See, this is the node port of this node, port of this machine. Then this one will be mapped with this. You will have that node port static service. That service will have a static IP, and then it will have a port, and this port will be mapped with the pod, and then the pod's port will be mapped with the container. So that's how from external world, using browser, using node IP and the node port, you are able to connect to the container. So let's get back to the service again. Yeah, so I think it's clear. So node port is clear, 30,000, which is used to connect from external world, and port is 8090, which is static. Basically, this neither port, this port and this IP is also static, and then target port. This is a Wipro port, Wipro app port, because we want to target this pod, okay, this container directly, that pod's container. So the pod's container's name is this Wipro, okay, protocol TCP. Rest all fine, absolutely fine. I hope. Let's see that what's gonna happen. So now let's create the service, but before that, let's check is do we have any services here? Kubectl SVC. No. Okay. Um, let's cross check. So okay, existing some Kubernetes service is there, but that's absolutely fine. It is not a big deal. So let's create a service. kubectl create and F option, and the name of that service is, what's the name of the service that we have mentioned? Sorry, that definition file, Wipro app nodeport.ml. Let me execute that. Absolutely fine, no issue at all. Service hello world service is created. Now let's say kubectl get svc, and here is that hello world service and node port, and this is the cluster IP, and this is the X. Oh, okay. This is our, look into this endpoint. Okay, this is our internal. You see that 8090 internal, and this is 30,000 is external. I'll show you that again on the image itself. You see that 30,000 is the node of this port, or sorry, port of this node, or port of this EC2 instance in other way. Okay, and then 8090 is the service port. Basically, it's a static IP. The service will have a static IP and then port. So now 30,001 is mapped to the 8090, and this 8090 is targeted to the container port through the pod. That's what the magic is happening here. Okay, now let's get back to the work again. See, 8090 is our internal, and 30,001 is external, and then TCP is our protocol. Now let's describe the container. So let me say kubectl describe svc, and what's the name of this container? Hello world, and it's service. That's what the name we have given. So here is that endpoint, and it begins with the name hello world services, and the namespace is default. By default it takes the namespace, as we have discussed in namespace session, that if you don't specifically mention the name, then namespace then it's gonna take the default namespace. Selector is very important. So using this selector itself, it has selected the respective pod, and then type is node port type, and then IP version 4, and these are the IPs, and target port is Wipro app port, so that's 98080, I guess. Then we have 30,002 TCP. Then endpoints is this. This is our endpoint. Let me copy this and let me put it in sticky notes. Just then we are going to use this later just for the comparison. So now what I'm going to do is, so the endpoint, what it says is the endpoint, this is the endpoint of the container, so it's going to connect it. So our hello world service, let me show this again. This hello world service will be connected with the endpoint, the container endpoint directly. So whatever the endpoint it is showing should be the container. So container IP. Let me check whether it is yes or no, whether it is same or not. So for that, I have to describe the kubectl, describe pod, and then name of the pod is Wipro app. Okay, describe, sorry, pod, it's Wipro. I think it's okay. Before that, let me do kubectl get pod. Yeah, it's a Wipro app, so no issue at all. So let me do kubectl describe, and it's describe pod Wipro app, and then grip IP. You see that this is the IP of our pod, IP of our pod. Inside that our container is running. So once you access the pod, and the pod will be connected with the container. So let me take this and copy it in the sticky note, and let's compare this. You see that both are same, both are same. That's what I'm saying. Hence it's proved, hence it is proved. So the service, the static IP of the service is mapped with the pod IP, and in turn the pod will be mapped with the container. So in turn, when I access the node IP with the node port through the service port, through the pod port, through the pod, it will connect with the engine container, and inside the container port we will have our application running. That's what the architecture. So now we have seen enough, so we got that. So endpoint automatically mapped with our pod, so that's the power of using service. Now let's see who said basically the mapping is also automatically, the endpoint is automatically created by the service. Okay, so now let's access the app from our browser. For that we need to add some SG rule, the security group rule, because we're not sure, we haven't. Let's get into the EC2 instance. Master, anyone, let me take uh, any node, or else I'll take master group, because the service can run from anywhere. So I'll take the master itself, and let me come scroll down and get into the security group. Security, oh, there are a lot of security groups. Let me scroll down. Security, yeah, we have one security group here. Sorry, that's a storage from ingress. and like that. Okay, let me click on this. How many security group rules are there? So for permissions, let me come to the inbound rules. So a lot of inbound rules are there. Let me click on edit inbound rules. So a lot of stuff is there. So all traffic is also there. So let me add one more. This time I would say all traffic and my IP. That's it. And I'll save the rules. So the nodes.kubewebpro.im like it's been added. So now it's time to take the IP of the public IP of the node, or any node is possible. So it really doesn't matter which node is the pod is running, because we are going to access the service which is across all machines, even in master node. So let's get into that. We'll take that EC2 instances, and it's copy this and put it here, and it is port number 30,000. That's it. Here it is. Our app is up and running. And technology about blog login sign up. You can click on login, and you can sign up. Yep, you can sign up. You can do the login. So whatever you want, you can do that. Let's get back to our work again. So now it's been proven, so that we are able to run a service. Through that service we are able to access the container which is running inside the pod. Okay, so let me show this one more time so that it will be much clearer. This is our node EC2 instance. Inside that one, we have created one pod. That pod consists of one container, which is the container consists of our application. Example, vProfile application that you see on your screen. Okay, all clear right till now? So now to access this application we need some service. Similar, even in manual deployment, traditional deployment also, we need to have some service. For example, Apache 2, HTTPD, Nginx, whatever it may be. Here also we require a service. For that service, what we will do is we will write a definition file. Inside the definition file we mention which pod to be targeted, and which port to be targeted, which pod, and then that pod's port, both will be mapped. Once it is mapped, then we will access the node with the port, and anyway node port will be mapped with the pod, and pod will be mapped with the nginx. So that's how the flow goes, and that's how we are able to access our application that you see on the screen here. Okay, so now let's get into our machine, and then let's delete this service first, because we are going to run a second type of service, that is load balancer service. For okay, mhm. So now let's delete that. It's kubectl delete svc. First we'll get the service kubectl get svc, then kubectl delete space name of the service is this, copy and paste it. Okay, so it's been deleted. The service hello world services is deleted. So now let's clear the screen and let's write load balancer. So before we write that, let's get into our theoretical concepts. Service, node port. So now it's time to look into load balancer. So here you see that ELB endpoint will be there, and then you have an application load balancer. Now this application load balancer, in spite of port mapping, this will work on a different way. So it's you will have a service, and the service will have a IP, static IP, and then port, and then label selector basically will select the pods, and then app front end, so backend port. So similar rest all works similar way, and then all will be mapped. So with this service, all will be mapped with this service, not through the port. Again I'm saying it is not through the port. It's not through the port, it will be through the IP, and then that service itself. Here which service we will get it? We will take the load balancer service from the AWS, because now we are doing it in AWS. So here elastic load balancer, the ELB of the AWS service will comes into the picture, and this will connect with all the pods which are there inside that, based on the selector. Okay, the node port is depends upon node port mapping, whereas here this service is depends upon load balancer functionality. Okay, so now let's begin our action. So let's do mkdir lbsvc, that's a load balancer service, ls, yeah, lbsvc, and inside that we'll create the vim. Okay, or else we'll get back to that directory and there we'll find out. Copy, inside that we're going to create vim wipro load balancer dot ml. Okay, let's write this file. So let me create a new file, load, sorry, pro load balancer dot ml file. So kind, it's service, yeah, Kubernetes service. Click and remove this part. So kind is service, metadata, the name I'm gonna give for this service is, this is load balancer service. Then selector will name is done, spec. Inside that selector I'm gonna say app, it's wipro app, that's what we have been using, wipro app. And after that we should have a type. So we missed a type here. Type, it's load balancer. Yes, we got it. Done. Then selector is done, type is done. Now it's time to attach the ports. So port mapping, now here it's 80 because we are using the load balancer. So load balancer is at port 80 is absolutely fine. Then target port, I think it's a Wipro app port. We have used it. Yeah, here it is, Wipro app port. Then the final one, protocol, it's TCP. Yes, got it. All got right. No problem at all. Let me copy this and paste it here. That's it. WQ, save and quit. Now let's begin. So let's create a load balancer service. First, for that, kubectl create option F and Wipro load balancer.aml. Let me execute it. Here is it. Service load balancer service is created. It's better to copy this and keep it. When we are deleting it, it would be easy, or else we are typing something and some other thing is happening. Okay, so now our service is ready. Now let me say kubectl get svc. Here it is. Load balancer service. It's still pending. So once your external IP, that's endpoint, is up and running, you can get into your EC2 instance. Yeah, it's here. Yeah, so you can get into your EC2 instance and you should see your load balancer running. Let me click on load balancer. So here you should see your load balancer up and running. Once your load balancer is running, you can copy the file, copy the link from description from the load balancer, and if you paste it, you should be able to see the application. So that's how a services object through load balancer works. Yeah, it's all done. Now it's time to delete the pod as well as services. So kubectl delete pod, that's Wipro app. That's it, it's been deleted. Now kubectl delete service. Hell, this is load balancer service. That's it, this has also been deleted. Now it's time to wrap up the service object and we will enter into another type of object in Kubernetes. Now it's time to look into one more Kubernetes object, that is replica set. And this one is pretty easy to understand. A replica set maintains a replica of your pod. What does it mean? Okay, but why do we really need it? Okay, so we have a pod running on a node and users are accessing it. The pod is running let's say some web application, and for some reason the pod goes down. Uh, the users won't be able to access the service. Of course, if the pod goes down, how can the users access the service? It's completely gone, the blackout. And that's it. The end of the story. Someone needs to log in, delete the pod, recreate it, and fix the problem. It's a lot of work. But if the pod is running with a replica set object you mentioned, these are the pods I want to run. So these many replicas I want to run of this pod. So replica set will do that for you. Any pod crashes, it can recreate a new pod for you, and you can mention replicas for scaling. You can add more pods into the replica set. You can remove pods from the replica set, and when I say replica, it doesn't really need to be really replicas. You can just say one also. So replica 1, you'll see. If I have to mention 1, so why will I use a replica set? That's what the question might be from you. So we use one replica set basically for health checks. If your pod goes down, you don't need to manually recreate it. Replica set will do it for you automatically, and the best part is you're mentioning more. So replica scheduler will distribute your pods across multiple worker nodes. So in an event of entire node crashing, pods running on that node can get recreated on healthy worker nodes. This is the magic. This is the magic I like. So the best part is you are mentioning more replica scheduler. Well, so replica scheduler will distribute your pods across multiple worker nodes. So in the event of the entire node crashing, pods running on that node can get recreated on healthy worker nodes. So let's look into that. Replica set, more about replica sets. Replica sets purpose is to maintain a stable set of replica pods running at any given time as such. It's often used to guarantee the availability of a specified number of identical pods. Mark my word, it will guarantee, and it's used to guarantee the availability of a specified number of identical pods. Now, how a replica set works. A replica set is defined with fields including a selector that specifies how to identify pods. It can acquire a number of replicas including how many pods it should be maintaining, and a pod template specifying the data of new pods it should create to meet the number of replicas criteria. A replica set then fulfills its purpose by creating and deleting pods as needed to reach the desired number. When a replica set needs to create new pods, it uses its pods template. A replica set identifies new pods to acquire by using its selector. If there is a pod that has no Warner reference, or the Warner reference is not a controller, and it matches a replica set selector, it will immediately acquired by said replica set. So now the question comes is when to use a replica set. A replica set ensures that a specified number of pod replicas are running at any given time. However, a deployment is a higher level concept that manages replica sets and provides declarative updates to pods along with a lot of other useful features. Therefore, we recommend basically our Kubernetes organization recommends us using deployments instead of directly using replica sets unless you require a custom update orchestration or don't require updates at all. So this actually means that you may never need to manipulate a replica set objects. So simply use a deployment instead and define your application in the spec section. However, let's understand the replica set well with an examples. So this is one example. This is the example we are gonna do. So consists of API version, kind, and then metadata. In metadata, you have the front end. App name is guestbook, and 3 replicas we have attached. And a specs, we have a container, and the name of the container is PHP Redis, and image is gonna get from some URL. Now saving this manifest into frontend.ml and submitting it to a Kubernetes cluster will create the defined replica set that pods that it manages. Okay, this is what we are going to do now. Let's jump into the action. Where is my, yes, here it is. So if you have pod running on a node without without with if you have a pod running a node without a replica set, just you created a pod and that node goes down and then pod goes down, that's it, the end of the story. But if it is created with a replica set, it will recreate that pod for you. So we have seen enough theory. Now it's time to look into the action and the practical demonstration. So for that, what we are gonna do is cd root defs lscd. It's a, let me create the new directory. It is mk there, and it's a reps defs and cd reps defs ls. Now here I am going to create my replica.ml file. Okay, so, but before that, let me create that file in VS Code. So let me create this new one. I'll say replica.ml. Yes, so the kind, this is a replica set. Yes, we got it, the replication controller, but I'm gonna go with the replica set. That's okay. Yeah, so kind API version is not just v1, we'll do with the old one, that's apps v1. Okay, and the kind is not a replication controller, or else you can go with the latest version of this also, but we'll use a replica set. Okay, so now it's been changed to the replica dot. So metadata, I'm gonna give this name as front end. Then let's get into the labels. Let's add some labels. Labels app, it's a guest book. Then tear, it's a front end. Then spec. Okay, modify replicas according to your case. So how many replicas that you want to have? I'm gonna put 3 replicas here. And selector name we will attach as match labels. So the selector, I'll give match the labels. That's very important. Match labels. How should I match? Using tar. So front end. Then let's go for the template. Okay. So template is of same indentation as the selector and replicas. So metadata inside the template. So I'll remove this labels. So inside the labels, I'm gonna go with tire front end. So in spite of the label app, my app, we are using tire, and then this is a front end. Yeah. Okay. Match labels is done. Then template metadata labels tire front end is done. Now spec. So spec is container. So name of the container is PHP Redis image. Let's take from GCR. Okay, for that let me get into the documentation of that so that I can get that. So replicas, where it is GCR Google Cloud, I think Google Container Registry. Let me find out. Yeah, here it is. And app 1.0. That's hello app 1.0. Let me paste it as an image. And that's it. Then rest all is fine. So no port is required in this case. So let's it's part of controller. Ports are not required. Let me remove this. Save this and control all and paste it here. That's it. So let me do ls, and replica.ml file is absolutely ready now. So once the manifest has been saved into frontend.ml definition file, and submitting it to a Kubernetes cluster will create the defined replica set and the pods that it manages. So let's do that. So kubectl apply, and F option we can go with, and then name we have to mention. So either you can use apply or create. I'm gonna do with create now. Create F option, and it's a replica.ml. Let me click enter. Yes, that's it. Replica set dot apps, a front end created. Let me copy this and put it in sticky notes so for the later usage. Okay, that's it. So now let's look into that. So how many pods we have? So kubectl get pod. There are a lot of pods are there. Let me delete all these pods one by one, because anyway these are not required. So now we are going to use a replica set. Okay, it's already been created, 3 front end. That's fine. Anyway, now let me delete all others. Only will keep these replica sets. So kubectl delete, and pod nginx f, and there are a lot of Okay, now let's kubectl get pod. Okay, nothing has been deleted because these are also replica sets only. Anyway, but now we will look into this, the front end stack. So clear the screen, and now let's look into the front end stack only. Absolutely. So I'll say this kubectl get rs, that's a replica set. You see that we have two replica sets. One is front end, just 2 minutes ago we have created. Other one is nginx tip, nginx deployment a replica set. This is using deployment, this we have done it using deployment object. Okay, anyway, that's fine. Our focus will be on front end only at this moment. Now let's do kubectl get pod and all three are up and running. Now I'm gonna delete two pods out of it. So kubectl delete pod. I'll take front end bg pjt and front end gd nsb space and enter. So these two pods has been deleted. Now let's do kubectl get pod and see what's gonna happen. And here it is. These two pods bg pjt gd nsb, these two pods has been deleted, but the new two pods has been arrived. That's a bk b2t ljjgp. So these are the new pods. As soon as the pod gets demolished or destroyed, a new pod will be created. That's the power of a replica set. So now let's do a configuration, to little more configuration to this vim, and then it's where is that file, ls, yeah, vim replica.ml. So I will change the replica size. I'll put it as 5 or 6. I'll put it as 6, that would be better. Yeah, let me save it and quit it. Now let's execute that again and see. So kubectl apply this time. Last time we have used create, now I'll use apply, and the file name is replica.ml. And you see that warning, see the warning, resource replica sets front end is missing the kubectl.kubernetes.io last applied configuration annotation which is required by kubectl apply. So kubectl apply should only be used on resources created declarative by either kubectl create save config or this, whatever it may be, or replica set dot front end has been configured, whatever it may be the message, the warning, but it's been configured. Let's do kubectl get pods. You should say that 5 front ends now. 5. You see, all 5. So this is a declarative way of scaling up. We can do the scale up, scale down. Now we'll do the scale down now. So vim, and this time I'm gonna say just 2. Let's see what's gonna happen. Scale down. Yes, replica set dot apps front end configured. Now let's get the pods. You see that only 2. Front end bkb2t, front end ljjgp. Only 2 are left. So that's how we scale up and scale down declaratively. So now we also do the imperative. imperative using commands. Imperative scale up and scale down. So for that, we have to give a command. So kubectl scale, and option is replicas equal to 1, and rs it's a front end. That's the name. Let me say 1. So it's been scaled. You see that replica set.apps frontend has been scaled. Now let me do kubectl get pod, and it's just 1 frontend ljg Now this time I'm going to scale up imperatively. The last time we have scaled down. Now let me do the scale up. Let me make it 7. So the replica set dot apps frontend scaled. Now let me see kubectl get pod, and you see that almost 7. It's close. It's 7. Okay. Now let's do the scale down to 1. Just 1. And kubectl get pod. You see that you have only one ljjgp. So that's how you scale up and scale down. Now let's edit the replica set frontend def file. For that, I'll say kubectl edit rs frontend. Yeah, here is that file, API version apps/v1, and kind is a replica set. Here you will find the metadata completely. Then here labels, 2 labels, tar frontend and app guestbook. Name is this, and namespace, a resolution version, and UID. And this is the YAML file, the complete information of that front end replica set definition file. Let's do WQ. So it's all done. Now it's time to delete kubectl get all, kubectl get pod. Now let's remove the replica sets. Just say delete rs front end, or else you can say rs/front end without space, whichever is fine. Did you mean delete? Okay, that's my mistake. Let me remove that. Yes, I meant delete. So replica set dot apps frontend has been deleted. Now let us check kubectl get pod. That's it. It's gone. You see that? No front end, no front end LLGP or anything. No front end LLGP. This is how we handle the replica set, and always it's better to have a replica set. However, you can use the better option, that is a deployment. Now let's look into one more Kubernetes object, that is deployment object, which is widely used by DevOps guys or DevOps tools. So deployment is one of the most used object by us or DevOps guys, or tools which are involved in DevOps. If you see that the most of the DevOps work is involved around deployments, making changes, making regular changes to the application, to the code, and by using deployment object, you can upgrade your apps, upgrade your pod images, basically roll back something goes wrong, and it's going to be gracefully in a rolling fashion. So by definition, it says deployment controller provides declarative updates. You declare it in a definition file for pods and a replica set. So deployment uses a replica set. A replica set we have seen in the previous lecture. It makes changes to your pod, or it maintains the replica of your pod. So you give a definition of deployment. This in turn creates a replica set, and replica set will maintain your pod. And when you want, you can make changes. So you can define the desired state. So I want this particular way of happening in our DevOps, so that we can handle Kubernetes, we can handle our containers or applications using Kubernetes pretty well. So now we will see few more concepts of deployments object. So deployment provides declarative updates for pods and replicas, replica sets. You describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. That also we are going to see. You can define deployments to create a new replica sets, or to remove existing deployments and adopt all their resources with the new deployments. So now let's look into some of the use cases of deployments. The following are the typical use cases for deployments. The first one is create a deployment to roll out a replica set. The replica set creates pods in the background. Check the status of the rollout to see if it succeeds or not. And second use case is declare the new state of the pods by updating the pod template spec of the deployment. A new replica set is created, and the deployment manages moving the pods from the old replica set to the new one at a controlled rate. So each new replica set updates the revision of the deployment. So this is also we are going to do. So each use case we are going to demonstrate here. So first one is create a deployment to roll out a replica set. That is one. And second one is declare the new state of the pods. Okay, that also will do. Now, and the third one we have is roll back to an earlier deployment revision. That also will do. So if the current state of the deployment is not stable, so each rollback updates the revision of the deployment. And we have a few more scale up the deployment to facilitate more load. That we can do. That's not a big deal. And pause the rollout of a deployment to apply multiple fixes to its pod template spec, and then resume it to start a new rollout. Then we have a few more. It's a clean up older replica set. So, and you don't need any more. If you want, you can clean up. If you don't need any more, all the pods and replica sets, you can completely clean up. That's using delete. And use the status of the deployment as an indicator that rollout as rollout as stuck. So now let's look into one example, creating a deployment. The following is an example of a deployment. It creates a replica set to bring up 3 Nginx pods. You can see that on the screen. A deployment named Nginx. This is the deployment object, and the name of this deployment object is nginx deployment. Okay, now in this nginx deployment, what all things is going to be happen. The first one, in this deployment, a deployment named nginx deployment is created when you using a command kubectl apply f option, and then if you give this deployment.aml file, so the uh, nginx deployment will be created. So this will become the basis for replica sets and pods which are created later. So this consists of for the following information. So nginx deployment is our deployment, and the labels is app nginx, and 3 replicas. So replica set is nginx. I think replica set is nginx, you see that, and template is nginx, and spec. So here we have our image, it's 1.14.2, and then container port mapping is 80. So now when we say kubectl apply, it will get applied, and when we run a kubectl get deployment, we'll get the deployments. And when we say kubectl rollout status deployment, the output the waiting for the rollout, so the deployment will be rolled out. If you want to roll back, you can give roll out, or you can roll back also. Okay, so now let's get into the action. Why to wait more? So what will we do is, we will enter into our server, that's a kops VM, where it is, yeah, here it is. Clear the screen. Sudo option I cd root defs ls. So here I'm going to create a directory saying defs. I think it's there. Yeah, first one, def cd def and ls. We have one. So this time I'm going to create one more directory, that's nginx, mkdir nginx dep and cd nginx dep. So inside that I am going to create a deployment.aml file. So vim deployment.aml file. So let's write this file on VS Code. So let me deployment.aml file, and kind it's deployment. Yes, our template is ready. So now it's easy. So kind deployment metadata name, I'm gonna give the deployment metadata. It's the deployment name it's asking. The name of the deployment, I'm gonna give nginx, and it's nginx deployment. That's fine. Then spec. So now in spec I have selector. So at this moment, but before that I want to attach a replicas. It doesn't have a replicas object. So inside the spec, immediately I'm gonna attach the a replica set. So replica, how much you like to have? Okay, metadata and name is done. I will add a labels also here. App nginx. Yeah. So now spec. So replicas 3 is fine, and selector, so we want to match the labels. So what's the label that we have taken? That's app nginx. So then We had template, metadata, again labels app. This time also it's nginx. Then one more spec, it's indented, a nested spec inside the template. So this consists of a containers data. So let me add the containers data here. So name of the container, I'm gonna give nginx, and image I will fetch it from nginx, I think, yeah, version 1. Yes, no, yeah, this is fine. Version 1, nginx version 1. Then resources is not required. The only thing I can have is port. That's it, that's more than enough. Let me remove this. Yeah, ports, and container port is 80. That's it. Rest all fine. This is our deployment definition file. So let's get into the server. That's a kops machine, and paste it. So our deployment definition file is ready. Now it's time to create our first deployment, first ever deployment. So kubectl, I'll say apply option F, and okay, before that let's delete any container with that name or pods with that name. So kubectl get pod, kubectl delete pod nginx f. Nginx f has been deleted. Now we have nginx dep. Let me copy. Okay, if we delete all those, so okay, specifically nginx is not there, so that's okay. So let's create deploy. So kubectl apply option F and deployment dot aml. So the deployment dot apps forward slash nginx deployment has been created. So that's what, if you remember, that's what the name we have given, and nginx deployment. So now let's say kubectl get deploy. So this will give you all the deployments that we have. So we have two deployments. One deployment we have done earlier, that is 6 hours 18 minutes ago. That's nginx dep, but this time the name that we have given is nginx deployment, just 30 seconds ago. Okay, so now let's do kubectl get replica sets. You see that your nginx deployment, this is our replica set. You can see all three. That means it doesn't mean 3 plus 3 plus 9. No, not at all. So we have desired 3, and we have desired 3 pods. So current 3 pods and ready 3 pods. So the status is absolutely fine. We have desired for 3 and the current state is also 3. So hence 3 are also ready. So that's fantastic. So all are successfully executed. 3, 3, 3 each. So now let's also see kubectl get pod. And you see that we have our nginx deployment here. just 2 minutes ago. So with this, the benefit of deployment object is, with the one definition file, you are able to create a replica sets, and you are also able to uh, create pods. You don't need to specifically create a pod. You can create pods and their replica sets using one file called deployment. Deployment. Once you deploy your pods using with the replica sets, then you can create your services. Then that services can make your application communicate with make your pods communicate with each other, and make your overall application accessible to external user or outside network. So that's the main objects. These are objects which we widely use. So then so everything will get so once that is done, now let's describe a specific pod, or else we can also describe uh, deploy or rs replica set. Let's do kubectl. Okay, I'm not describe, I'll go with describe. Describe its pod and its nginx deployment, anything we can take. Yeah, yeah, here you should see. So successfully assigned default nginx, so container image name. So created container nginx and started container nginx. So at this moment a container is successfully spinning. Let's look into the image name. I hope we'll find it. Yeah, here it is. This is the image name that we are using. So this time what we are going to do is we are going to change the image name and we will run it again. Okay. So for that, or else we can do the similar thing, kubectl describe. Let me kubectl get this time it's a deploy, and these are the three. So kubectl describe deploy nginx deployment, and here you should see this is our deployment description. So type normal, scaling replica set, of course, age is 4 minutes 50 seconds, and from deployment controller, scale up replica set nginx, so 2 3. So how many? 3. Rest all it's fine. Nginx deployment id and row desired is desired, updated, unavailable. So that's what. Now let's also do kubectl get it's rs a replica set. We have two replica sets. So kubectl describe rs, that's our replica set, and this is our replica set object, and execute. Here we should see, so total a replica set controller into action, and 3 has been created, the first one, second one, and third one. And this is the image. This is our container. A clear cut information about the pod template. This is the pod template information. You can see that labels is nginx label, and containers, it's a name of the container is nginx. Inside that image you are using is kubectl nginx version 1, and then a port is 80 tcp. Okay, this is what we want to change. We will do the change to this, and we will rerun that. But before that, if you want to roll back to the previous replica set, rolling back to the previous revision is also possible. But for that, before that, let's see the replica sets. It's cube kubectl get rs. So we have two replica sets here, nginx dep and nginx deployment. Let me try to do that. Of course, these are two different kubectl rollout. These are all of not the same file. So that's the reason. What will we do is we will do a small modification to our file, and then we will create one more deployment. So what we're gonna do is first we'll do it imperatively. So for that, nginx is the container name, and update the container with the latest version directly. Okay. So what I'll do is kubectl set image deployment dot v1 dot apps / nginx and deployment. So here name of the container is nginx, and image I am gonna say nginx latest. That's it. And let me execute it. So there is the unknown command images deployment. That's okay. Let's directly so in spite of try to solving this okay, it's image. Where is that? Kubectl set, and that's image, not images, but that's okay. It's imperative way. I don't advise you to do this imperative way. Okay, it's done. Anyway, I don't advise you to do this imperative way. So nginx deployment image updated with the new image, and let me check. Let me clear the screen and say kubectl get rs, and here it is. One more has been created, and the old one has been completely gone. So this is the 9 minutes ago, 53 seconds it's gone, and this is the new rollout. This is new update. The old one has been gone. The new one has been updated with 333, with the 3 pods. So now let's also see the kubectl get deploy, and you see that the deployment nginx just 10 minutes ago, whatever is there, it's proper, no issue with it. So now what we're gonna do is kubectl will describe that deployment, and then we'll describe this specific deployment object. Then kubectl describe, and then pod. Let me get the pods first. Kubectl get pod just to see the new image. That's it. We have updated with the new image. Let's look into the new image, or else we'll do it using rs only. You don't need to use specific so I'll use rs. So kubectl, and it's describe, and it's rs replica set, and the name of the replica set, here is the replica set. This is the old one. Let me go with the new one. This is the new one. Let me check it. Yes, yeah, you could see that a pod templates, app nginx container. You see nginx container, image is nginx latest. This is nginx latest, the old one, nginx latest. The new one is nginx latest, whereas the old one is kubechern nginx version 1. So that's how you can update. I'll show you that. So we have done create a deployment to roll out a replica set. That's the first activity we have done. We have rolled out three replicas of our pod. Okay, and the second one, declare the new state of the pods. Just now we have done it. We have declared new state of the pod. So I'll show you that also again. kubectl get deploy, and you see that this is nginx deployment. This is a new state. This is absolutely new state. To cross check whether it is new or old, you can use a specific command. But before that, what we are going to do is we are going to undo the deployment back to the role. Okay, let's create one more deployment file. So that's the imperative way. We have done it imperative way. This time we are going to create nginx one more deployment. So let me clear the screen first, and let me do vim deployment.ml, and I'm going to change it here also. Directly changing. We have done it imperatively before. Now we are going to do it declaratively. So latest, and I will remove this too. Yeah, and then save. Let me run it. kubectl apply option F deployment.ml. So the new deployment.apps nginx deployment has been configured. It's been configured. Now kubectl get deploy. Sorry, you see that nginx deployment has been configured. Now let me check the kubectl get rs, and this is what 5 minutes 24 and then 14 minutes. Now what I'm gonna do is I want to roll back this status. I want to roll back this whatever the previous one. I just want to I just want to have that deployment only, not the latest one. Okay, for this is what we call it as a rolling back. So let's roll back to the previous replica set. So rolling back to the previous revision, that's what we are going to do. So for that I will say kubectl rollout undo, then deployment. So this is what the deployment and nginx deployment, that's what the name we have given. I think nginx deployment, nginx deployment. So the rollback has been done. It's successful. You see that nginx deployment rolled back. Now let me cross check that. kubectl get rs, and you see that magic. So this is the old one, and all the pods have been moved to the old deployment, old nginx replica set, and new replica set has been gone. 6 minutes 48 seconds. This is the latest one. Latest one is no more in use, and the oldest one is in use. That's how we can roll back. So with this we have seen the third. With this we have seen the Third use case, a roll back to an earlier deployment revision. So now let me say kubectl get pods, and here are those pods. So all pods are just 68 seconds, 66 seconds, 67 seconds because we have rolled back. We have rolled back. That's the reason. Now what will we do is we will have more fun. This time I'm gonna, okay, first we will cross check this, the image, and after cross checking that, we will have one more version. So kubectl describe, I will use rs. So nginx, this is a new one, this is a old one, recently rolled back to the old one. So I'm gonna give that describe rs, yeah, all fine. And these are the events that had happened. Let me scroll up to find out the image name. Yes, yes, you see that the container and the image name is kubechurn nginx v1. This is how you can roll back, and this is how you can use your deployment to get the maximum benefit out of the Kubernetes. So let me give kubectl get pods, and you see these are all recent ones. These are not too far. These are the recent ones. If we do the roll back again, then it will be shifted to others. So roll back kubectl get kubectl roll to roll back to the nginx deployment. So nginx deployment rolled back. Now let me say kubectl get pods. You see that just a few seconds before the pods has been started. That's what, whenever you deploy, it will begin newly. Whenever you deploy, it will just start a fresh pods. That's what I want to tell you. And now let's see the kubectl get rs also. And now you could see again it has rolled back to the earlier one. That's the 10 minutes before one. We have two, right? This is the first one, nginx deployment cd one is the first one, and this is the later one. Now we have rolled back to the later one. So now let's we can also give kubectl rollout history to see how many times we rolled out. So deployment nginx and deployment. You see that revision, change costs, and 3 4. So this is how you will get the complete revision history, rollout history and rollout revision history. So now finally let me say kubectl get deploy, and we have two deployments at this moment. So let me get back. So this is how we use deployment. So the deployment is nothing but it's deploying a replica set and pods together. So the benefits that we can get uh, out of this is we can roll out, we can update, we can get a desired state, and we can also pause the rollout of a deployment. You can clean up the complete replication replica sets also. Basically we will have a flexibility to handle, because if you directly handle with a pod, it's not that easy. So if you handle with the deployment, so deployment can easily tackle both the replica sets and then pods objects in our Kubernetes. Now let's look into volumes object. So volumes is a pretty important object. So to store the data and to have the persistence, the data persistence. So volumes must be attached with our container, with our container using pod. So on disk files in a container are ephemeral, which presents some problems for non-trivial applications when running in containers. One problem is the loss of files when a container crashes. So the kubelet restarts the container but with a clean state. That is the issue. That's the problem here. So the issue here is on disk files in a container are ephemeral, which presents some problems for non-trivial applications when running in containers. One problem is the loss of files when a container crashes because the kubelet restarts the container with a clean state. A second problem occurs when sharing files between containers running together in a pod. The Kubernetes volume abstraction solves both of these problems. So familiarity with pods is suggested. You should know that before we enter into this. So if you are not clear about what is pod and all those concepts, you just kindly watch this Kubernetes video from the beginning and get the complete exposure, and then you come here for this video that volumes. So then Docker has a concept of volumes, though it is somewhat looser and less managed. A Docker volume is a directory on disk or in another container. So Docker provides volume drivers, but the functionality is somewhat limited. Kubernetes supports many types of volumes. A pod can use any number of volumes, typically any number of volume types simultaneously. So ephemeral volume types have a lifetime of a pod, but persistent volumes, these are very, very important, but persistent volumes exist beyond the lifetime of a pod. That's what we want basically. We want volumes to be persistent beyond the lifetime of a pod. When a pod ceases to exist, Kubernetes destroys the ephemeral volumes. However, Kubernetes does not destroy the persistent volumes. For any kind of volume in a given pod, data is preserved across container restarts. At its core, a volume is a directory, possibly with some data in it, which is accessible to the containers in a pod. So how that directory comes to be, the medium that backs it and the contents of it are determined by the particular volume type used. To use a volume, specify the volumes to provide for the pod in .spec .volumes, that's inside the spec object of the YAML file, and declare where to mount these volumes into the container that you have to mention in the container section. And the container section, in the volume mount section, you have to provide this information. So now volumes cannot mount within other volumes, but also volume cannot contain a hard link to anything in a different volume. So now let's look into the types of volume or various types of volume that can connect with our Kubernetes. So Kubernetes supports several types of volume: AWS Elastic Block Store or AWS EBS CSI migration complete, Azure Disk CSI migration, and OpenStack CSI migration. Let me look into those from our documentation, Kubernetes documentation. This is volumes in background. Here there are different types of volumes from AWS Elastic Block Store, which has been deprecated, and here you can find out a configuration file, definition file for that, similar, but this time it's a pod itself, the pod. Then we have AWS EBS CSI migration, Azure Azure file, Cinder, OpenStack CSI migration, config map, the most important one, config map. Then we have FC, GCE persistent disk, that's a Google, GCE, Google Cloud Engine, and then we have more, that's GC CSI migration, clusters, and this is what the host path. This is what we are gonna do. So this example we will do. So before that, let's cross check what all are there. There are a few more types: local, NFS, persistent volume claim, and projected lot, a secret, vSphere CSI migration, a lot more. Yeah. So now we are going to do this one. So it's a host path. Volume mounts a file or a directory from the host node file system into your pod. This is not something that most pods will need, but it offers a powerful escape hatch for some applications. The most important, for example, some uses for host path are: if it is a Docker, we can use var lib docker. Inside that you will find the volumes. A running C advisor for a container, it's /sys, and some other thing will have that. And here we are going to use a MySQL one. So MySQL will have a /var lib MySQL, and this is the config file. This is the sample definition file for the volumes. So, and we have also attached an AWS Elastic Block Store sample file. So it consists of API version, kind, metadata. So there you have to give a test DB or test EBS Elastic Block Storage and spec. And inside that container information, there you have to mention the volume mounts. And then after that, the volumes as to be defined. Okay, let's get into the action. Okay, so it's basically we have seen so many options here. If you remember, we have gone through so many types of volumes. There are many options, and based on what project and what company you are working for, so they may use a storage solution. Your job will be to map that particular storage volume for to your Kubernetes volume. So we will do one example over here with host path, and The host path means the worker node directory, the worker node. So host path means which is on the worker node. We pick up a directory on the worker node and we map that as a volume to our pod. So let's look at the definition. Let's look at the definition file. But before that, let me create a directory mkdir vol def and cd vol def, and let me say vim. It's mysql pod.aml. But before that, let me write the similar file on here, and then we'll get back to that server or kops. So it's mysql pod.aml. So kind is obviously pod. Yeah, it's done. API version v1 kind pod. Metadata, I'm gonna say db pod. Then labels is not required, but if you want to have a label, you can attach the same db pod. And spec, we have our containers. So container, I'm gonna take image. So name MySQL, I'll give MySQL, and image, I'll get it from my Docker. Okay. Docker hub, and I'll go with the MySQL. So I should have two versions. Yes, we have two version. I'll go with the v5.7 see all and v5.7, and copy this, and image name here I'm gonna paste it. Yeah. So then let's attach the volume mounts. Let's remove this. So here I'm going to attach below the name. Okay. Yeah, here I'm going to attach the volume mounts. So volume mounts. Yes, we got it. Volume mounts. And so the first mount path. So mount path, I'm going to mention. So this is MySQL. I will take var lib MySQL. Okay, this is our mount path inside the container. Inside the container. So the name I'm gonna give as db vol. So now this is our mount path. This should be mapped with db vol, which is inside the host machine. So volumes. So let me attach the volumes. Volumes. Name of the volume, I'll say db vol. Then let me attach the host path also. So host path. host path, I'll give it as a forward slash data or anything, whatever you require, you can give it. It's not an issue. Forward slash data, and then the finally, so the port mapping we are not taking because it's not to be accessed. So then finally we'll have a type. I will go with directory or create. That's it. I think rest all absolutely fine. Host path, volume, DB volume, everything is okay. Let's see. Then let me paste it here. That's it. Our file is ready. So now let me do kubectl apply option F and mysql pod.ml. So pod has been created successfully. So now let me say kubectl get pod, and here is the db pod. It is on. So there is error, something is wrong with this. So let me check that. So for that, what I have to do is kubectl describe pod and its db pod. Okay, the problem with the problem here is, so scheduled, this is no issue from the default scheduler, no problem. And kubelet a pulling image, also no issue, successfully pulled image. And created container mysql, started container mysql, and normal. So container image cube charen mysql already present on emission. So warning, back off, kubelet back off, restarting failed the container. Okay, so if you restart a container, it failed. So that's what it's saying. So directory or create, let me reconfigure it. So kubectl apply option F mysql pod.ml, it's reconfigured, and kubectl get pod, and it's same, it's db pod. Here it's 35 seconds ago, it's pulled off completely. And so now let's so we have described the pod. Let's look into the describe again one more time. We'll describe the pod to find out the volumes, exactly how the volumes are connected. So let me scroll up. Yeah, here it is, you can see that. Yeah, mounts, this is not going to continuously run because this pod itself, it will start, and then after that, if you try to start it again, it will not start because it's mysql database. It's not a container to spin continuously. Okay, so here we have varlib mysql from db wall. So these two things are mounted, and then host path is forward slash a data, and host path type is directory or create. So host path, and this is how these mounts, these are volume mounts, and this is how they got mounted. So now let me delete the pod. Kubectl delete pod and then db pod. That's it, the db pod has been deleted. Now let me get back to the, that's it, this is how volumes work. However, we can have a much complex volumes, and every volume, every type of volume, we can clearly see that. We can clearly see different types of various sample templates on our on Kubernetes documentation. You can see that various templates for various types of volumes. Now let's look into at another Kubernetes object, that's a config map. So if you put the config map uh, in a simplistic way, so it is a way of storing the environment variables and files in one Kubernetes object, and whenever you want, you can use it wherever you want, and whichever pod is required, we can inject these config maps into that pod so that we can easily use them without writing or rewriting them again and again and again. If it is a small of one or two pieces of environment variables, it's not required. But whereas when you deal with a very complicated and complex uh, applications, in that case you are going to have a lot of environment variables and lot of files. So in that case, it's very difficult to write those things again and again and again. So what will we do is, we will create a config map. So once the config map has been created, we will inject that config map into any pods that we are going to build. And if you want to specifically map certain environment variables, certain files, that is also possible. So that's what we're going to see here. So what is a config map? Config map is an API object used to store non-confidential data in key value pairs. Pods can consume config maps as environment variables. Command line arguments are as configuration files in a volume. So what all it takes? It takes environment variables and command line arguments, and also it takes configuration files inside the volume mounts. Before we have seen volumes object. So volumes object, now we can basically store configuration files inside that volumes object. After that, whenever you want, you can inject these into the pods which you are going to run. So these pods can consume config maps as three: environment variable, command line argument, and config file. Okay, configuration files. So a config map allows you to decouple environment specific configuration from your container images so that your applications are easily portable. Now, before we see config map object example, so what's the motivation behind bringing a config map? That should be understood. Okay, so use a config map for setting configuration data separately from application code. That's the important point. For example, imagine that you are developing an application that you can run on your own computer. That's in, basically we call it as a development stage or development environment. And in the cloud, to handle a real traffic, you write the code to look in an environment variable named database host. Okay, so locally you set that variable to localhost. In the cloud, you set it to refer Kubernetes service that exposes the database component to your cluster. So this lets you fetch a container image running in the cloud and debug the exact same code locally if needed. A config map is not designed to hold large chunks of data. The data stored in a config map cannot exceed 1 MB, 1 megabyte. So if you need to store settings that are larger than this limit, you may want to consider mounting a volume or use a separate database or file service. So that's the main motivation of bringing up a config map in Kubernetes. Now we will look into the config map object. A config map object is an API object that lets you store configuration for other objects to use. And like most Kubernetes objects that have a spec, a config map has data and binary data fields. This is very important. Remember this, note down this, mark down this. A config map has a data and binary data fields. So these fields accept key value pairs, specifically key value pairs. We are going to use that. Key value pairs as their values. So both the data fields and the binary data are optional. The data field is designed to contain UTF-8 strings, while the binary data field is designed to contain binary data as base 64 encoded strings. So before we look into the declarative type of config map, we will see imperative and then we will go for the declarative. So but let's get into our instance and yeah, here. So let me create one, and this time I'm gonna write mysql.aml. Okay, just mysql.aml or mysql cm config.aml. So what we are gonna do is, so we will talk about variables, also about configuration, how you can inject data in the pod. So now we know pods are disposable. Of course, we know the pods are disposable because we have played with the possibles we have played with the pods so far. So if we want to make change, we have to delete them and create a new pod with a new image, a new container image. So we have the persistent changes, but while we are running the pod, we can also inject variables and configuration in the pod. First, let's uh, let's talk about environment variables, which is very simple, assigning a variable. So just like what we have seen in Bash and Python. So in a part definition file, you have to do this. So env option name of the variable value. So there we have to mention the information about that. So let's do that. Let's create one MySQL environment variable file so that we can get more clarity. So here I'm gonna use kind pod. Yeah. So I'll remove this kind one initial. Yeah, rest all is fine. Pod. So name I'm gonna give. So this kind is fine. My app. This is db pod, and then label db pod and spec container MySQL image. I'll give my image, that's a cube Charan MySQL 5.7.4. Let's keep this same. Of course, it's not required. That's not the point of discussion here. So the point of discussion here is ports. Port is not required in this case. So what I'm gonna do is I'm gonna create one more So it's env. So when we attach an env, so there in this we can give our environment variables. So list of environment variables. So here I'm gonna say list. The first is the name. So name of the database I want. So I'll mention the name of the database environment variable as MySQL database. Then we have value. So that's how we write a key value. So accounts. So this is our environment variable MySQL database, and then value to that is accounts. Similarly, we have one more. This time I'm gonna use name. It's a MySQL root password. So value, it's passwd, whatever it may be, some random passwd. So this is how basically these are environment variable, and this is how we attach those environment variable with our with our containers. Now my question is, see, you have to run a lot of pods with MySQL. So, and by and large, you will use the same database name and then same value. What will you do? Will you type this again and again and again forever? No, nah. Yes, of course you have to type because you do not have any option. No, you have an option that is called config map. So this config map, what it will do is config map, we have using this environment variable specifically, you have to create a config map object CM. So once you create that config map config map object with these environment variables, and later you can inject them in a different way. How to inject them, we will see that. How to inject them into our pod, that we are going to see. But these are the environment variable, and these environment variables can be injected into our pods using config map. So now what will we do is, let's look into some of the imperative way of doing this. Of course we won't be doing, and I will also not suggest you to do this, but however I would like to show the commands. Yeah, sudo option I, clear the screen. So to do that, what we can do is kubectl and create yeah kubectl create config map and db config, and here you have to mention from where literal what all things you want to inject, that is MySQL database, and what is the value? The value is accounts. Then one more tool that we want to inject, that is from. This is imperative way, we are injecting imperative way, but this is not the way of doing. From literal, and it's MySQL root password, and pass WD. Okay, just a minute, I'll make it smaller. This is our password. That's it. So, and if you click enter, so it will be created. Let me do that. But I have to remove that hash. This is how we can create our config map. So error unknown flag F. Okay. So unknown shorthand flag F in. Okay, somewhere. Okay, we missed. Okay, that's good. Let me put it here. Flag. It has become a shorthand. It's actually longhand flag. That's it. Your config map, DB config map has been created. Now you can say kubectl get config map cm, and you see that you have db config. That's the name we have given, db config, and then we have another kube root ca.crt. That config has not been created by us, but whatever it may be. So as this is root, this is a default config file, and this is created, and this one will be used by our configuration file, the ca.certificate. So that's how we imperatively create a config file, and we see that config file imperatively. Then we can also do kubectl here is that. So when you say kubectl describe that config map and the name of the config map, so you will find all the information. So name of that config map is db config, and namespace is default. By default it took the default namespace, and data, so what all the environment variable it's storing, this config map is storing. So it's storing MySQL database and the values accounts, and MySQL root password, and the password is passwd, and there is no binary data here. Okay, this is the data, there is the binary data here. Okay, so that's how imperatively it stores this data. So in this MySQL container, this container has two variables, which is MySQL underscore database and MySQL root password, and we can basically echo, we can say, you can say echo and dollar, and then if you say MySQL database or MySQL root password, we should get these values respectively. If it is MySQL database, we should get accounts. MySQL root password, we should get passwd value. Okay, so it basically exports these variables in the container. So that's how we can set variables for the pod, but really this goes beyond this. When you are running any application, set any stack, you will have many variables and also configurations that can change over time. So you can use something called as a config maps to store all our variables and configuration at one place. It's a storage space. A configuration map, a config map is a storage space, and then whenever you want in any pod, you can just inject these variables or files into any pod. So that's what we have done it. We have seen it using we have done it using imperative way. So we have said kubectl, then get cm, so basically config maps, and out of that db config map, that's what we have created, db config map, and option o, and I'll say haml, and here is that the db config map aml that's been created. Of course, we have created it imperatively. It's not the one which we have used a file, but you can take this data as a reference config map data. You can just copy this and you can use it in your config file also. You see that API version you have to mention, and then after that data, here you have to mention MySQL database. These are the two dictionaries, that's a key value pairs, key and then key and then value, a key and then a value, or you can call it as a strings also. Then the name type is config map, and metadata is this. So name db config, namespace default, and this is how a config map object looks like. So now let me describe this kubectl. We have seen it earlier, but one more time I want to show it to you. Kubectl describe, and it is cm and db config. Let me enter, and you see that your db config, how it looks. It consists of two environment variables, and that's how it looks. Okay, so now let's get into the serious example. For that, let me come here. You see that the config maps documentation, but before we come to the documentation, let's get into our slides. So now config maps and pods. So we can write a pod spec that refers to a config map and configures the containers in that pod based on the data in the config map. The pod and the config map must be in the same namespace. This is very, very important. Whenever you work on the config maps and then pods, for example, you have created a config map with some environment variables and some configuration files. Okay, that's absolutely fine. But if you want to inject this config map into some pod, you have to make sure that the config map and pod are in the same namespaces. If you are not clear about the namespaces, you just go back and watch my video where I have talked about the namespaces object. Okay, so here we'll take an example config map that has some keys with single values and other keys where the value looks like a fragment of a configuration format. You see that API version kind config map, this is what we have mentioned, and the name of this config map is game demo. We'll use the same name, and data, it's begin, the data is begin. So first one is a player initial lives, that is 3. This is a single value, and second one is UI properties file name, but here instead of value we gave some properties, user interface dot properties. So that is here, it's mentioned here. So it consists of a lot of values, color dot good, color dot bad, allow dot text mode. So it's like referencing again. So it consists of more, and similarly game dot properties also. So it's like file like keys. This is not a single key value pair. It's not single value. It consists of a multiple key value pairs. That means it's a file like keys. Okay. Now what will we do? We will get into our kops and we will create an example. We'll work on one example. Okay, for that what I'm gonna do, cd root defs, I think, yeah, ls. Yeah, here I'm gonna create mkdir. This time it is cmdef. So cd cmdef, and inside I'm gonna write our first config file. So to write that, let's get into our, yeah, this is our config maps. So here you should see about config map object. Then here you can find out the config maps and pods. So you can write a pod spec that refers to config map and configures the containers in that pod based on the data in the config map. The pod and config map must be in the same namespace. Again, I'm reiterating this. They must be in same namespace. Don't do this mistake. So let's take an example of config map that has some keys with single values and other keys where the value looks like a fragment of mm, configuration format. So we'll take this, we'll copy this exactly. We have, and so name is the name that we are gonna give for this is a sample cm.ml or first cm.ml. So let me get into here. Let me say vim sample cm.ml. This is a declarative way we have done it. We have created an ml. We have created a cm imperatively. Now we are doing declaratively. So let's go through this one more time. API version and config map is the object type, and the name of this config map is game demo, and this consists of a data. So one is player initial lives. This is a simple value. You can see that property like keys, each key maps to a simple value, and this one is mapping to a simple value, and this one is also mapping to a simple value. But this again got user interface dot property consists of again three values. You see that this is key value pair, and this again this value consists of a three key value pairs, or and similarly this enemy dot types. And okay, it's like file like keys. These are called file like keys. Now let me do wq save and quit. Now let me create the config map object. So kubectl apply option F, and this is sample cm.ml. That's it, and let's create. So the config map, the name of the config map is game demo, has been created. Now let's get the kubectl get cm. So we got the game demo, the config map. It consists of 4 data points, not one. So 4 data points. So what will we do is we will do kubectl get cm, and let's do that. Let's look into the file itself again. Kubectl get, and this is a config map, and the name of the config map is game demo that you can see on the screen, and I want it in AML format, and here is that. Yeah, it has begun from here, and here you got the data. The first one is game.properties. It consists of enemy.types and aliens, monsters, a lot of data inside that. and then it's a config map, metadata, annotations, and yeah, basically this is the data we have. Total four. Okay, we will do it in, we will look into that in a better way. So again, let me get the config map, kubectl get cm. Yes, now let me describe this kubectl describe cm game demo. Yeah, here you see that. So let me scroll up a bit. Name game demo space default. So user data has begun. So we have user interface dot properties. It consists of three data points inside that, and you have game dot properties. It consists of again two values inside that, and player initial lives, it consists of three, and UI properties file name, it consists of user interface dot properties. So this is the data that config map consists of. Events are none so far. So now let's get back to our documentation again. So if you see, there are 4 different ways that you can use a config map to configure a container inside a pod. This is nothing but injecting a configure map or data points of configure map into the pod. How do we do that? There are different ways. The first one is inside a container, inside a container command and orgs. The second one is environment variables for a container, and the third one is add a file in a read-only volume for the application to read, and the fourth one is to write code to run inside the pod that uses the Kubernetes API to read a config map. So these methods lend themselves to different ways of modeling the data being consumed. For the first 3 methods, the kubelet uses the data from the config map when it launches containers for a pod. The fourth method means you have to write a code to read the config map and its data. However, because you are using Kubernetes API directly, your application can subscribe to get updates whenever the config map changes and react when that happens by ascending the Kubernetes API directly. So this technique is also lets you access a config map in a different namespace. That's what we are going to look into now. So we will take an example. Here is an example pod that uses values from game demo to configure a pod. So let's exactly copy this, or we will look into this here itself and then we'll copy and paste it there. So API version v1 pod, this is a pod, object is pod. Now metadata config demo pod, this is what, because we are injecting a config map into this pod, so that's why we call it as a config map demo. Then containers, inside the containers, these are name of the container is demo, image name is alpine, and command we have given is sleep at 3600 seconds. Then here the game starts env. So when we say env define the environment variable, and then first env we have given the key is player initial lives. So notice that the case is different here from the key name in the config map. So now after that we have said value from. So value from, we are using config map key ref. That's what, see, in spite of giving value to the environment variable, you see that we gave the name. This is the key. This is the key. Okay, but what we have done before, let me show that. Here we have mentioned the value. This is the key, and then below that we have set value, and then we have mentioned the value. But here we are injecting, so that's the reason what I said is value from, and we have to mention that config map key ref, and then name of that config map is game demo. The config map is game demo, so that's the value you have to give. And then key, and one more, player initial lives, the key to fetch. Okay, this is our game demo config. Let me show that. Game demo config consists of that key player initial lives. You see that this is what they want to fetch. Okay, from game demo config map they want to fetch a key player initial lives. That's it. And then one more environment variable is UI properties file name. That's the key. And then value, again you want to get it from config map key ref. That's a name, config map game demo. And the key that they want to fetch is UI properties file name. I'll show you that. UI properties file name. This is what they want to fetch. So then finally we have a volume mounts, because using volume mounts you can also store the files inside that. So for that we have attached the volume mounts, and volume mount name again config, and mount path is /config and read only true. So volumes, we have to specifically attach a volume object also. This is where we have set up the volume object. You set volumes at the pod level, then mount them into the containers inside the pod. So name config, and then config map, you have to give the reference of the config map, that's a game demo, and then all the items whatever you want to store in that volume, so you have to mention. So key, game properties, path, everything. So let's copy this, and we will create a file, a pod object, and inside our, okay, we're going to create a pod object saying sample dot from the sudo I cd root defs ls cd cmdef config map def, and ls, yeah, sample cm.ml is there. Here I am going to create vim. We want to read the cm, we want to read we want the pod to read this config map file. So that's the reason I'm going to name it as vim space read cm pod dot ml. So let me execute that, and let me say I, and paste it, complete file, and do wq quit, save and quit. Now our file is ready. Now it's time to create the pod. So for that, so what I'm gonna do, kubectl apply option F read cm pod.ml. Let's execute this. That's it. Pod config map, basically this is a pod, and config map demo pod, that's the name we have attached. So that has been successfully created. Now let me say kubectl get pod, and here is that the config map demo pod, it's successfully created. So now let's log into the pod and check variables and files whether they are existed or not, whether they are copied or not. For that, if you remember, for Docker we have used exec command. Yes or no? Yes or no? Exec, right? We will do the same. So kubectl exec, and we'll take the input, that's std in option, long option, then tty terminal, this is also long option, then the name of the pod, it's a big one, let me copy that, it's better, config demo pod, I'll copy it and paste it here. Then option bin / bin sh. Yes, we are inside the pod. You see that? We are inside the pod. We have inside the dock. We are inside that pod. So now let's do ls. Okay, as usual, it consists of a bin, dev, home, media, opt, route, everything. So I'm going to look into the ls. You can see the config file here, config directory. ls option L. This is a minimum requirement. Yeah, you have that config. The config is a directory, correct? Now let me enter into the config, cd config, and let me do the ls option L, and you see it consists of a two. Okay, let me do the ls only. It consists of a game.properties and user interface.properties. If you remember that. So now let's do, these are the two files. Okay, ls lrt, and it's a linked, it's also linked. So both are, these are not directories, these are linked files. Okay, these are linked with a data in a you have a data directory, and inside the directory you have a user interface dot properties, and this file in this file which is in this pod has been linked with another, linked with a file which is inside the data directory, and similarly game dot property also linked with dot data, and it's a game dot property. So these are files. So the successfully we are able to store the files also. Environment variables we have done it. Now even the files has been stored using volume mount, using volumes. So now let us cat game.properties and we'll see what is there inside that. You see that the game.properties consists of enemy.types is aliens and monsters, and player.maximum lives is 5. Fantastic. So now let's cat user interface dot properties, and this will consist of information about the color. Good color is purple, bad color is yellow, and allow text mode is true. So that's what, and we can also use we can also echo the variables, echo environment variable. So I'm gonna say player initial lives, player initial lives. Execute. That's it. You see 3. So player initial lives are 3. So with this, just to come out of this, we can say exit. Yeah, you came out. So with this, we have successfully, if you want to just compare, validate, just say kubectl describe, or first we'll get the cm kubectl, and get pod kubectl describe pod and config map demo good demo pod. And here you should see, so all container created container started, all are absolutely fine. And cube ca.certificate by default it has taken. And here you should see the environment. This is what I want to show you. This is the mounts here. Yeah, environment, player initial lives, and UI properties file name, and mounts. These are the information about the mounts. And similarly, let's also check kubectl get cm. I want to show that also. So db, it's a game demo, so that's what we have used, correct? We have used a game demo. So let me do kubectl describe, and it's cm and game demo. Yeah, if you remember, player initial lives environment variable we have used inside that pod, we got it 3. Then we have two file names, UI properties, sorry, user interface properties, this is one, and game.properties, this is another file. For the game.property file, this is the information it consists of. For the UI properties, this is the information consists of. So we have successfully validated the same. It is there, the files and an environment variable has been successfully injected into the pod that we have created, hence proved the power of config map. In the previous lecture, we have seen a config map, and we have seen that config map stores, how that config map stores variables or files in a clear text. So if you're storing things like passwords or your Docker registry credentials, which you will inject in your pod definition file, then these informations which are sensitive like passwords will be in clear text in your repository, because all the definitions file that you write will be in your repository, in a Git repository. So who have access to that Git repository can see the passwords in clear text, which is very, very, very bad. So we can store variables encoded, we can store these variables encoded or encrypted by using secret, then we can inject it safely in our pod. So this kind of pod, we call it as a secrets pod. A secret is an object that contains a small amount of sensitive data, such as a password, a token, or a key. Such information might otherwise be put in a pod specification or in a container image. Using a secret means that you don't need to include confidential data in your application code, because secrets can be created independently of the pods that use them. There is a less risk of the secret being exposed during the workflow of creating, viewing, and editing pods. Kubernetes and applications that run in your cluster can also take additional precautions with secrets, such as avoiding writing secret data to non-volatile storage. So secrets are similar to configs but are specifically intended to hold confidential data. So then what are the use cases for secrets? There are three main ways for a pod to use a secret. First one, as files in a volume mounted on one or more of its containers. Two, as a container environment variable. Three, by the kubelet when pulling images for the pod. So the Kubernetes control plane also uses secrets. So let's create a secret object using imperative method. Then we will do it using declarative method. So let's begin to create a secret object using imperative method. So let me say, let me clear the screen first. Kubectl create secret, and it's a generic, then name db seek seek imperative from literal equal to environment variable, that's MySQL root password equal to pass wd. Let me execute this and see what's going to happen. Error, failed to create secret unauthorized. kubectl create secret So if you get an error like we are unable to log into your server or log into your server, that means maybe because of because of AWS reset, or if you don't use the AWS for more than 6 to 7 minutes, 6 to 7 hours, automatically the instances will get reset and it will be updated with the new public IP. So that's the reason the connection will be lost to the. Now to get back the systems, to roll back the systems, to swing back the systems instances into action, so we have to say this kops update cluster and name bucket state and as admin. So then after that you can give kops validate, then your within after giving these two commands, proper connection will be established with the cluster. Kops will have a proper connection with the cluster. So then you can see kubectl get pod. You see that all the pods have came. Same similarly kubectl get node, and again all three nodes are there and these are updated versions. Okay, now let's swing into the action. So we are gonna create secrets using imperative method. So I have that here somewhere. Yeah, I think this is the one. Let me copy this. I'll keep everything same. Yeah, let me execute it. So db config is already exist. Okay, this is config map. Let me create. So kubectl create secret object, and that too it's a generic. Then the name I'm gonna give is db sec and it's imperative. Then from option, long from option, and short literal option, literal equal to MySQL root password equal to pass wd. Let me execute it, and here it is. Secrets db sec imperative has been created. Now let me do kubectl get secret, and you have only one secret, and that too it's opaque type. It's a opaque type data. It has only one data, and 15 seconds ago it's been created. Let me execute. Let me check it, what is there inside that. So what I can do is kubectl describe, and it's a secret, and db sec imperative, and here is that it consists of only one data point. You see that one data point, that is MySQL root password, and that too it's not shown what's the password that we have mentioned, and it's 6 bytes. That's it. It's a 6 bytes. 1 2 3 4 5 6 and 6 bytes. So we can also fetch the file from this kubectl get secret and db sec imperative imp, and option o, I want it in AML format, and you see that SAML format API version v1, data that we have attached, that's only one MySQL root password dictionary, and kind is secret object, and here is the metadata about that object, and the type is opaque. So similar kind of declarative a similar kind of declarative script we are going to write, declarative definition file we are going to write. So for that I'm going to copy this into secret sec.aml. Correct. So now let's create one more now, but this time what we are going to do is we will create we will give the input as a file, not a single value. We will give a file. Okay, instead of giving the single input, we'll give the file. Okay, for that let me go to cd and root defs ls. So mkdir, it is secdef, and cd secdef ls. So here I'm gonna write one file, echo option n. So admin is the password, so admin is the username. So I want to give this as an input to the file that should be created in the present working directory. So the file name is username.txt. So let's do ls. You see that? And cat username.txt. And okay, that's admin. That's admin. You see that? That's admin. Vim username.txt. Yeah, you see that? Admin. Clear? Then similarly we will create a password.txt echo option n, and this time the password randomly I'll give, and give it to the password.txt ls and cat password.txt, and this is your password. Here you see here this part till here. Okay, so we got the username and password. Now it's time to run, it's time to create a secret object. So kubectl, okay, clear the screen before we start. No, we'll keep it. Kubectl create secret again, generic again. This time the name is db user pass, and now instead of environment variable, instead of a single environment variable, we are going to give a file name. So for that the option should vary from option with a file short. Okay, user pass and from with file equal to /username.txt, and another file is again from, and then file option /password.txt. Let me execute it. Okay, unknown flag. Obviously something is wrong. Let me cross check. From is fine. From is fine. Here double s. Okay, double. Yeah. Okay. So secret db, the secret object db user pass has been created. Now let me give kubectl get secret, and you see that dbsec imp that we have created before 6 minutes ago and DB user pass. Both are opaque type. This we have created just now. So now what will we do is we will do a kubectl describe secret and it's a DB user pass, and you should see that both the files password.txt and username.txt 9 bytes and 6 bytes. kubectl, so how can we incorporate a file inside the definition file? That we are gonna see now. kubectl secret db user and pass, and option O, and I want it in YAML format. And here is the complete file API version, and inside that you have to mention both the files password.txt username.txt. So username we gave something, it's been converted into something, and password also we gave something, it's been converted into something. So from this you should be able to understand what is this encoding. Then kind is secret, and this is the metadata about the secret object, and type is opaque as usual. So that's how we can imperatively, using imperative method or imperative command, we can create a secrets. So now what will we do is we will look into the encode concept first before we jump into the declarative way of creating Kubernetes secret object. So encoding is pretty much important in spite of simply, that's what fundamentally it will do. So in spite of simply putting or exposing all the secret information to the external users or just inside a repository, it's better to encode them and then use it there. So but the question arises, how do we encode it? How do we encode it? So to encode, this is encoding. So encoding, for example, let's take echo. I want to encode username such as name Charan. So this is what I want to encode. So for that I want to print the encoded version of this Charan. So for that I'm gonna say base 64. You convert this into the base 64. That's what is our encode, and this is what is the base 64, and that's what you have seen in our previous file also. Let me show that. kubectl get and secret, and it is after the secret the name is db user pass, and option O YAML. You see both are encoded, and this is also encoded. So next let me do the another example. So echo option N, and this time it's Divya, and pipeline base 64, and you see that encoded part. So now is it possible for us to decode? Yes, it is possible. Let's do that. Let's decode this. Okay, let's also see. So decode echo, and this is the one which I want to decode. Copy this and paste it here, and pipe it using base 64 option, long option, that's a decode. So we want to decode this. Let me enter. It's Divya. You see that? It's decoded. Let me do ls. You see the decode. I have created it. So now let me vim decode, and here is that. So basically the output of that decode I have piped with. I have redirected the output of the pipeline to the decode file. So let me say W and Q and clear the screen. This is how we decode, but we encode and decode. So for us, we need to have two things of two parameters to be encoded. The first one is username and second one is my secret pass. Both I am gonna put into the encoded one will be redirected into the output will be directed into respective files. So what I'm gonna say is echo option n, and this is admin, it's a username, and pipe with base 64 and redirect to the admin.txt. So that's it. And similarly, this time it's password. I would use my secret pass, same, and base 64, this is pass.txt. So ls, you should have a pass.txt and admin.txt. So these are the one which consists of our, so cat pass.txt, and here is that encrypted password. Similarly cat admin.txt, and this is our encrypted username. So both we have, so we can easily get it. So that's how we encrypt and decrypt the any string inside a Linux machine. Now, why do we need this? That's what your question. I'm going to tell you. Just wait a moment. So now let's look into create a declarative secrets. So let's use a kubectl and a configuration file. We call it as a def file, a definition file for the secrets object, and the customized tool. If you want, you can use that, or else kubectl and configuration or definition file is more than enough to create your secrets. You can attach any number of secrets. So using secrets as a files from a pod. If you want to access data from a secret in a pod, one way to do that is to have Kubernetes make the value of that secret be available as a file inside the file system of one or more of the pod's containers. To configure that, you create a secret or use an existing one. So multiple pods can be referenced on the same secret. One secret object can be referenced to the multiple pods, and to modify your pod definition to add a volume under the spec object with a volume section. So name the volume anything and have a spec dot volumes secret dot secret name field equal to the name of the secret object. So here if you see, the first modification will be done here, and then second modification will be done at the volumes. You have to define your volumes, and inside that volumes you have to use a secret, and then inside the secret section you have to mention the secret name. So secret name should be the same as the secret that you have created before. So this is very important, the matching. So the matching this pattern is pretty important. Now this is an example of a pod that mounts a secret named my secret. You can see that. Okay. Now let's get into the action again. So this time we are going to first write a secret file. We'll create a secret. So, but if you want to do a declarative, then you have to first encode your data. So we have encoded it and we have stored that encoded data in .txt files also. Now, and then when you create a secret declarative kind secret type opaque data key, and the value that you give, you would have already encoded it, otherwise there is no point. And then in the pod definition file you can read it like I'll show that. In the pod definition file you can read it like you can say env. If it is an environment variables, or if you are using a file name, then you can use a file name directly. So if it has a multiple, it's going to export all of them. But if you want to be selective, you can say value from secret key reference, a name of the secret and key. This is what the secret name, and then value of the secret name. Now this is the simplest form of using secret. Secret has some other types as well. As let's look into that, what all types a secret has. So let me click on there here and let's get into the documentation. Yes. So secrets, what is secret and what's the difference between the secret and config, and what are the types of what are the uses of secrets and alternative to secret, and working with secret, what all tools are required. And we have a important information for us that is lined up is projection of secret keys to specific path, secret files permissions, consuming secret values for volumes, and using secrets more updated secrets updated automatically, invalid environment variables, container image pool secrets. This is widely used using image pool secrets. This is widely used, and this kind of code. So here you should see that use case as a container environment variable. So kind, it's a secret object. Name of that secret object is my secret, and type is opaque, and data, it consists of a username and password, 2 data points. One is username, it's encrypted, and password is also encrypted. So then we can create remaining things. And here, so once that is done, we can use in from to define all the secrets data as a container environment variables. The key from the secret becomes environment variable name in the pod. And here in from inside that you have to mention the secret ref in the pod. This is a pod object, and then name of that is a my secret, and then rest all remains same, and you can run it. And we will look into the few more concepts of this. What are the use dot files in a secret volume, and use case secret visible to, and types of secrets. That's what I want to show you. Types of secrets. When creating a secret, you can specify its type using the type field of the secret resource or certain equivalent kubectl command line flags if available. Okay. So now Kubernetes provides several built-in types for some common use case scenarios. These types vary in terms of validations and validations performed, and constraints Kubernetes imposes on them. So the most widely used one is opaque. Opaque is arbitrary user-defined data, and then you have a Kubernetes.io service account token. This uses service account token. Then we have Docker config, the Docker CFG. This uses a serialized Docker CFG file. Then Docker config JSON, it uses a config.json file. And then we have a basic auth. Basic auth is nothing but the credentials for basic authentication. You will have basically a login, username and password. And SSH auth, this is credential for SSH authentication. Then TLS, data for a TLS client server, and token, bootstrap token data. So you can define and use your own secret type by assigning non-empty string as the type value for a secret object. So we will look into the opaque secrets only, not anything else. So opaque is the default secret type. If omitted from a secret configuration file, when you create a secret using kubectl, you will use the generic subcommand to indicate an opaque. When we say generic, previously we have used generic even in imperative commands also. So the generic subcommand indicate an opaque secret type object. For example, you can see that the following object that they have created. So, and this is example for the service account token secrets. Service account token secrets, you have to mention this is a secret object, but the type is a service account token. You see that here it's mentioned type is service account token. Then we have more other types, Docker config secrets, and here basically config normal and then config JSON, and here you can see the file, and type is kubernetes.io docker config. So based on your need, you have to use a specific file. So this is a best use case and it is widely used use case. When you do not have a Docker config file, you want to use kubectl to create a secret for accessing the container registry. This is widely used secret object. So to access a container registry, to fetch the container, we can use this, and this is the example. It's all mentioned: Docker email, Docker username, Docker password, Docker server. So almost all secrets are mentioned here. Or else you can attach as a JSON path. You can attach as the same thing, whatever is there, you can attach it in a JSON format, a JSON file, and then save that file and put it in your command. And we have basic authentication secret, the next one. So basic authentication secret is pretty simple. You will have a username and password, the username for the authentication and the password or token for authentication. So the Kubernetes.io basic auth type is provided for storing credentials needed for basic authentication when using the secret type. So the data field of the secret must contain one of the following one, that is username. You see that username and then password, and type is Kubernetes.io basic auth. And we have SSH authentication secrets. For SSH authentication secret, the type is kubernetes.io SSH auth, and then the data is we are gonna say SSH private key. So private key will come here, and public key will be attached in all other places where you want to access. That's the private public key. So you have to create SSH key, and then the private key should be given to the secrets file. That's how SSH authentication secrets work. And you have TLS secrets, and then TLS basically TLS.certify, TLS.key. So you will have both two, because we have when we have seen config file, in that we have user.crt and user.key. So both will be attached to the data here, and the type is kubernetes.io TLS. So that's how it works. Now let's do our first declarative object, a declarative secret object. So let me get into our server. Sudo I clear the screen and cd root def, and this one is sick def ls. There are a lot of files here. I am gonna create a directory that is mkdir. It is declarative. So cd declarative and ls. So here we are gonna write our first secret YAML file, a declarative script. So the name I'm gonna give is vim mysecret.yaml. So let's write it. mysecret.yaml. So kind secret. That's it. Our template is ready. So kind secret metadata, I'm gonna call this as a my secret, and type is opaque, and data I'm gonna attach two. One is username, so username, and other one is password. So at this moment I do not have those, so it will be there inside my server, so I will paste it there only, or else I'll bring it here. Yeah, a wq and a cat. I want username admin.txt. Okay, I have to get back cd and cat admin.txt, and this is my username, encrypted username, not just username, and I'll paste it here. So username has been pasted. Now it's time to get the password. So the password is in cat password dot txt, and this is my password. No, sorry, that's a different one. So pass.txt, that's what the one, I think. Cat pass.txt. Yeah, this is what I'm gonna go with, pass.txt. Let me copy this and paste it in password place. Okay, that's it. Our file is ready. This is our first secret definition file, or this is our first secrets object. Let me copy everything from here and let me get into declarative and ls. So vim mysecret.yaml and paste the code here. That's it. All set, up and running. So now let's create our first secret object from declarative definition file. For that I'm gonna say kubectl create option f and mysecret.yaml. That's it. Secret, this is a secret object and it's a my secret. The name of that object is my secret, has been created. So now let me do get kubectl get secret, and that's it. My secret and opaque type data, it has 2 points, username and password, and age is just 24 seconds. Age is just 24 seconds. Now let's also describe that kubectl and describe secret, and it's my secret. And this is what this my secret consists of: metadata about that secret, and then type is opaque, and the data, it consists of only two, that's username and password. And username, password is 12 bytes and username is 5 bytes. So then let's also look into the file one more time. So kubectl get secret my secret option o ml. We should get the same file, other than that the created file API version. You see that data point, its password, and then username in encrypted mode, kind is secret, and this is the metadata about our app, about our secret object. So now we have our secret objects. Of course, we have 3 secret objects, out of which we are going to take the my secret object and attach with the pod object to securely run it. So let's create a pod. Let's create a pod to read secret keys. So for that, let's get into that. So what I'm going to say here is the name read secret.ml. Okay, it's a pod one. I'm going to say read secret.ml. Read secret.ml. So kind, it's pod. So API version remains same, kind pod remains same, metadata. So what I'm gonna say, metadata name, I'll keep just name, rest all labels I don't want at this moment, or else I'll keep the labels also. So secret env pod, secret environmental pod. So same thing I'll say, secret env pod. Okay, so metadata is ready. Now specs, let's get into the specs directly from here. So containers, name of the container is my container, and image, Redis image without tag. So that means it will take by default tag is latest tag. Then after that, I'm going to mention env. This is very important. You have to mention env for to attach this information. So the first one, name, I'll say secret username, and its value, from where will you get this value, because this is the key. Whatever we have mentioned now, see, all environment variables should be like a dictionary, key and value pairs. So here when we say name, okay, this is a secret username, that's the name, and value, either you can directly give a value, or you can get you can reference a value from. So we are referencing this value from secret key ref, that's what we are using, secret key ref. And the name of that secret key ref, what's the name? Let me check that. Let me cross check it before I use. So this is kubectl get secret, and the name is my secret. So I'll say name my secret, then key is username, then optional is false. So now let's add few more things, that is name, and one more option that we're going to attach is name. This time it's a secret password. Before it's a username, and this time it's a secret password. So again, the value from, I think it's env. So the value from secret keyref, and let me put the name my secret, and key is password. And optional is not required, but still we can add optional false. So same as the optional, same as default, my secret must exist and include a key named password. So that's it, all done. Now let's remove this memory one, which is not required, and container port also. Now let's to give the restart policy, which is equal to the indentation of container. It's container. So restart policy, I'm gonna go with never ever try to restart it. That's it. Our file, a pod definition file is ready with us. Now let me save this and copy it and get into our server, and vim, the name of the file I'm gonna give is read. Okay, I think I have given read secret. Let me check. ls my secret is there, vim. So this is a pod definition file, the previous one is secret definition file. I'll say read secret.aml. So here I am going to paste everything, complete piece of code, and you see that API version. Let me cross check the code, all the key and value pairs one by one. So kind, pod, and metadata, we have name, secret, and pod, and after that at the same indentation we have a spec. Then in spec we have two containers and restart policy. Restart policy is always never, and in containers we have to mention the container name, and inside that container we are using image redis, and inside that image we have two environment variable. Basically one is secret username and the other one is secret password. So from where will you get it? From where will you get this secret username and secret password values? So the values you have to get from secret key ref, and then you have to give the name of that secret key. So for both we have given my secret because that's what the secret file is. Now let me do the w and q, that's a save and quit. So now it's time to create a pod with a secret object. The kubectl create option f. So read secret.aml. So the pod has been created successfully. See, the You see that pod object, and the name of the pod object is secret env pod. So now let's say kubectl get pod, and you should see our pod. Here it is, secret and pod one by one are up and running without any problem. So then what will we do is we will describe the same kubectl describe secret, and the name of the, sorry, this is not secret, this is pod. Describe pod, and name of the pod is secret env pod. And here you will find that respective information. So here you can see the events. So created container and started container. Let me scroll up and scroll up and scroll up. Here is that environment variables. So secret username set to the key username in secret. That's my secret. That's what I want to show. So keep that here. Secret username. That's environment variable. It's the value has been set to the key username in the secret my secret. Okay, so the value of this secret underscore username has been set to the username key inside a secret named as a my secret object. Similarly, for secret password, the key, the value of the secret password has been set to the key password in secret my secret. So it's all fine. Now let's also do kubectl get pod, and name of the pod is okay, kubectl get pod, and kubectl get pod, and name of that is secret env and pod. And after that I'm gonna mention o and ml, and this is the complete pod. And here you can find out the pod IP also, basically 196.227. More information, more, you can get a lot of information from here. And requests, yeah, here you see that containers and the complete piece of spec containers, image redis, image pullover, always name my container. So now it's all done. Basically this is using our file itself. So what we are gonna do is we have to cross check the secret username and secret password environment variable. For that we have to log into the system. So we have to log into the pod and we have to print variables. So kubectl get pod. Now let's log into that. For that kubectl exec and std in and tty, sorry, tty, and the name of the pod is secret env pod. That's the name of the pod. And let me do the bin bash. And here is that we are inside that. Let me clear the screen. Anyway, yeah, now you see root, and we are inside the secret env pod. We are inside the pod. Superb. We are inside the pod. So now let's try to fetch the environment variable. If you want to navigate if you want to navigate around the secret and pod or pod, you can do that. ls, you can give ls, because we are in the data directory. So cd root ls and cd ls. You see that you have bin data etc lib media opt root has been sys user. Almost all binary, all directories that are similar to the Linux we have, because it's Linux pod. So you can basically look into the each and every. It's similar to the similar to our container, similar to our virtual machine, similar to our Ubuntu distributions file system, nothing much. So now what I'm gonna do is, anyway we are inside the pod. Now I will say echo and secret, and it's a username, and let me execute and see that you got that. We gave an encrypted username, that's encrypted username to that. Okay, let me show that. So here is that pods and read my secret.ml, and you see that username we have gave it in encrypted way and we got it in a decrypted way, that's admin. And similarly I'm gonna say echo and dollar secret password and my secret pass, and that's what here it says. So this is encrypted password and that's a decrypted password. So again we can also do the following way: echo and the protection and secret underscore username and protection again, still you will get it. And same you can do for the secret password also. I'm gonna attach a protection to this. You see that? So we are inside the pod and we are able to access the environment variable that we have mentioned inside our secret file, which has been encrypted, and we are able to see a decrypted secret environment variables. So that's what all about secrets for now. Now let's look into the cheat, cheat sheet of kubectl or kubectl cheat sheet. So this page contains a list of commonly used kubectl commands and flags. It's pretty much useful because during my working environment, like when I was working on projects, we have used widely this cheat sheet. So it will come in handy. So most of the times, and so it's very difficult to remember all the commands, all the flags, all the options. So it's better always keep Kubernetes documentation with you. Always refer Kubernetes documentation. We also always refer Kubernetes documentation. I would also urge you to always refer Kubernetes documentation. So if you want to autocomplete at this moment, I do not have autocomplete option in my EC2 instance kops mission. So if you want to attach that autocomplete option, so you have to add this command basically. So this one. Then you can look into more information here. So we will begin with kubectl context and configuration. So set which Kubernetes cluster kubectl communicates with and modifies configuration information. For that, you can use this. Of course, we have done all these things. So kubeconfig is the environment variable, and then you have attached this kubeconfig, and then this is the configuration file that consists of an access to certain cluster. Then you can get the password for that e2 e user using the following commands: kubectl config view and option wo, and then JSON path, and then you have to mention the required. And similarly, after configuration is done, this is the first step of dealing with our cluster, because you should able to connect with the cluster first. If you are able to connect to your cluster, so then the next thing is to apply. We'll start applying we'll use the kubectl apply. For that, apply is the command which manages applications through files defining Kubernetes resources. It creates and updates resources in a cluster through running kubectl apply. So this is the recommended way of managing Kubernetes application and production. So we can create objects. So normally, to create an object, Kubernetes manifests can be defined on, we call it as a defined definition files. Either we can use YAML or JSON. The extension could be .yaml, YAML, or .yeml, or .json. Either of these three can be used as an extension for the definition files. So this is how we create a resource or our object. So you say kubectl apply and then option F, and after that you will mention the file or definition file name. Then it will be created. If you want to create a multiple files, if you want to create a object from multiple files, still it is possible. You have to add multiple files here after F option. And if you want to create a resources, if you want to create a resources in all manifest files in directory, from all definition files from directory, directly you can give a directory there. Or else you can also give GitHub repository. So you can start a single instance of Nginx. We have done it using kubectl create deployment Nginx. That's the container name, or that's the name. This is a deployment. This is a deployment object. We can deploy it. So, and after that, image is Nginx. Or simply create a job which prints hello world. So kubectl create job hello world. Image is this. Job name is hello, and then image is busybox 1.28, and what it's gonna do is it's gonna print, it's gonna do echo hello world. And similarly, create a cron job that prints hello world every minute. That also possible, but you have to use cron job. The name of the, you have to say the cron job. This is not a job object, this is a cron job object. You see, there are a lot of objects. So the name of this is hello, and name of the image is mentioned here, and then schedule option you have to take, and you have to mention every minute. Okay, every minute, every day, every month, every week, every year. That's what the cron job that we are running here. And finally, get the documentation for pod manifests using kubectl explain pods. And here are some example. Let's create multiple YAML objects from stdin, and these are multiple, and this is a secret, this is secret object. So once you have created your objects or resources, then it's time to view and find the resources. To view and find the resources, we'll use kubectl get services. It lists all services in the namespace, and kubectl get pods all namespaces. It will list all pods in all namespaces. And similarly, kubectl get pods option wo wide lists all pods in the current namespace with more details. When we say option wo and then wide, it will give more details about that. And if you say kubectl get deployment and mydep, it's gonna list a particular deployment. The deployment resource name is mydep. And if you mention kubectl get pods, it will list all pods in that namespace. By default, we will have it will fetch from default namespace. and kubectl get pod my pod option wo aml, it get a pods aml, it will get a pods information in aml script, or it will get a pods aml script, whatever way you want, you can take it. So now describe commands with verbose output. We will have a describe command. It will describes the either pod or node or deployment or service or replica set or secret, whatever it could be, or config map. And there are more to look into it. These are all basically imperative commands. And here you have a node selector, kubectl get node selector, kubectl get secret, my secret template, and there are more commands, more and more commands. So you have to go through all these commands to get the much more clarity. So once you have viewed your resources, now it's time to update resources. So kubectl set image deployment and upgrade or update this existing deployment with the new image version 2. This is how we will do. Basically in deployment, we have done it. We have done this exercise. We have updated or upgraded the existing deployment. Then rollouts. These are all rollouts. You can see that kubectl rollout history. This we have used it, and kubectl rollout undo deployment to roll back this one, and this one kubectl rollout undo, and kubectl rollout status, kubectl rollout restart. These are to roll out back to the earlier deployment resource. And cat pod json and kubectl replace. And finally, you can look into the patching resources. So kubectl it will partially update a node, not pod, a node. So kubectl patch node, and then node name will mention, and then information that we are going to attach in that. So patching resources, it's gonna partially update a node or update a container's image, or this kind of activity will be done. Here the last one, if you see, it updates a deployments a replica count by patching its scale sub resource. For that we say kubectl patch and then deployment object, then name of the deployment is nginx deployment, and option is sub resource, and that's equal to scale the value and type merge and option, and how many replicas we want, 2. So, and finally editing resources, you can edit your resources using kube editor, and this is very important, scale up and scale down the resources. It's scaling resources. You can say kubectl scale a replica option 3 to scale up, and if you reduce it to the current state, to the desired state, if current state is 5 and desired state is 2, that's a scale down. If the current state is 3 and desired state is 6, that's a scale up. So we can use this kubectl scale to scale up and down. Then final, all done, it's time to delete resources. To delete resources, you say kubectl delete option and mention the pod file, or else you can say kubectl delete pod unwanted now. So this will delete a pod with no grace period. And when you say kubectl delete pod service bash foo, this will delete pods and services with same name baz. That's what the benefit of it. So finally, if you want to interact with a running pod like we have done with our Docker, so we can do that. For that, you have to simply say kubectl logs. That's it. It will give you logs of your pod. And even you can do the piping to specifically get a certain information from the logs. And you can do exec. This is also very important. Exec, the exec command runs command in existing pod. Basically, exec is used to enter inside the pod, and in one container case. If it is a one container case, if you have a multi-container, then we have to say kubectl exec my pod, and option C, inside you have to specifically mention the container name. Then only you can enter inside that. existing pod with multi-container case. And you can start a single instance of nginx pod in the namespace. This is to start a nginx instance in a particular namespace. Here you said option name, and then here you have to give the namespace, so the pod will be started here. So copying the files and directories to and from containers, that also possible using the following commands. kubectl, you have to say copy cp, and then you have to mention or map the directories from where you want to copy and paste the files. Then more interacting with deployments and services. This is pretty important. To interact with deployments and service, we use logs, and logs you have to mention the deployment name, and again logs deployment, and then inside that deployment, if you want to specifically get the logs of certain container of the pod, basically if it is a multi container pod, then obviously you have to mention the container. And similarly you can do the port forward, so listens to local port and forward to port 5000 on service backend. That's what a port forward. And you can do the exec for even deployment a resource. When you do exec, you can run command in first pod and first container in deployment if it is a single or a multi-container cases. So similarly, you can interact with nodes and cluster. So kubectl cordon my node basically mark my node as unschedulable. If you cordon, so it will mark it as unschedulable. It will never get scheduled. That node itself will never be scheduled. Then kubectl drain my node in preparation for maintenance. So we want to do maintenance, completely drain the node. And uncordon, so mark my node as schedulable. So initially we have unscheduled it now, so that means we cannot do any operations on that. Now to uncordon, to make it schedulable again, we have to say uncordon. And we can say kubectl top node, and then you have to mention my node, so that matrix for a given, it shows a matrix for a given node. And more information, kubectl cluster info, and more. So that's what. So if you want to see the resources type, you can say kubectl API resources, and these are all, you will get it. These are namespace resources and options. These are very important. These are options which are widely used. If you want to output AML formatted API project, then you say option O space AML. If you want output in the plain text format with any additional information, and for pods the node name is included, you have to use option O wide. And if you want to print only a resource name and nothing else, then option O name. And more. We have used some, we haven't used some, you have to use some. That's it. Custom columns and more information. So kubectl output verbosity debugging, it's not that much important for us. That's what is our cheat sheet, a kubectl cheat sheet. It would be very important, it would be very useful. So I would urge you to go through it, and during your daily work, I would suggest you to use it widely, so that you can get a lot of benefit from this cheat sheet. Choosing the right object for the job. So designed as a simple building block, a replication controller's only responsibility is to maintain the specified number of replicas. A replication controller counts only live pods, terminated pods are excluded. So other Kubernetes building blocks or objects should be used together with a replication controllers for more advanced tasks. For example, an autoscaler can monitor application specific metrics and dynamically change the number of replicas in the existing replication controller. In addition, a replication controller does not support scheduled policies. Managing you cannot provide rules for choosing cluster nodes to run pods from the managed sets. And a replica set is another Kubernetes building block. The major difference between a replica set and a replication controller is that replication controllers do not support selectors with set based requirements, while replica sets support such selectors also. From this perspective, a replica set is just a more advanced version of a replica controller. Using only pods and replication controllers to deploy an application is, at least in part, an imperative form of managing software because it usually requires a manual steps. A Kubernetes deployment is an alternative that enables completely declarative application deployment. So here I'm just summarizing everything, whatever we have discussed so far in Kubernetes, from replica set, replication controller, pod, and then deployment. So we have gone through all those things. It doesn't mean every time you have to do pod, you have to create a pod, and after that you have to create a service, and after that you have to create a replica set. No, not at all. Not at all required. The highest object that we have here is deployment. What does the deployment will do? Using only pods, replicate only pods, either only pods object and only replication controllers to deploy an application is not a good idea, because it is like an imperative form of managing software. You have to give a lot of manual commands. In spite of that, we have a higher object to deal these things automatically. That is our Kubernetes deployment. So Kubernetes deployment is an alternative that enables completely declarative application deployment. You write in a definition file what you have to do, that's all, rest all will fall in place. So the deployment object is gonna look after rest all of the things. So now we will choose the right object for the right job. First, secret. A Kubernetes secret allows user to pass sensitive information such as passwords, authentication tokens, SSH keys, and database credentials to containers. A secret can then be referenced when declaring a container definition and read from within containers as environment variables or from local disk. Then we have a config map. A Kubernetes config map allows users to externalize application configuration parameters from a container image and define application configuration details, such as key value pairs, directory content, or file content. So config map values can be consumed by applications through environment variables, local disks, or command line arguments. Then we have job. A job is used to create one or more pods and ensure that a specified number of them successfully terminate. It tracks the successful completions, and when specified number of successful completions is reached, the job itself is complete. Then daemon set. A daemon set ensures that all or some nodes run a copy of a pod. A daemon set tracks the additional and removal of cluster nodes and adds pods for nodes that are added to the cluster. So terminates pods on nodes that are being removed from a cluster. Then we have a namespace. A namespace provides a logical partition of the cluster's resources. Kubernetes resources can use the same name when found in different namespaces. Different namespaces can be assigned different quotas for resource limitations. Quota sets resource limitations such as CPU, memory, number of pods or services for a given namespace. It also forces users to explicitly request resource allotment for their pods. So with this, we have come to an end of everything Kubernetes. So here we have gone through the history of Kubernetes and Kubernetes high level architecture, and we have seen the differences between traditional deployment, virtualized deployment, and container deployment. Then we have seen the benefits of the Kubernetes. Then we have entered into the cluster architecture and we have explored each and every component of cluster architecture theoretically as well as practically. So then Kubernetes API we have seen. Then we have nodes. We have discussed about the different nodes. Then high level architecture. Then controllers, controller types such as replication controller, replica set, deployment controller, then cloud controller manager, then container runtime interface, garbage collection. Then the most important concept is to differentiate imperative versus declarative orchestration. That also we have seen theoretically and practically also. Then we have entered into the most important and highlight of this part or highlight of this video is working with Kubernetes objects, specifically working with each and every object. That's what I have done it, because to differentiate, to remove that confusion in your brains, I have designed this video in such a way that it would be pretty clear, it would be cakewalk. You may think, if you work along with me, you may think that Kubernetes is a cakewalk, bro. So here we have discussed about the KH objects, each object from namespace, pod, service, replica set, deployment, volume, secret, config map, and we have done 2 to 3 examples. One is imperative way and declarative way, and we have written definition files and we have created respective resources of that object. And finally, we came to the cheat sheet. We have looked into the cheat sheet of kubectl, and then finally we have seen a way to choose a right object for the job. So with this part of video has been completed, wrapped up. Now I'm gonna see you in another part of Kubernetes video, that is basically hands-on Kubernetes. Of course, here also we have did huge amount of Kubernetes exercises, but there we'll be specifically working on 2 mega projects. One is using Minikube and other one using kops and kubectl. I will see you there. Until then, bye bye. See you. Keep subscribing it, keep liking it, keep loving it, keep spreading it. See you again.